All right, people. I believe everybody is doing great, nice, and absolutely fine. So, what's up, people? Let me know in the chats if I'm perfectly audible, visible to each and every single student. Everybody, guys, let me know in the chats. Let me know in the chats. How is it going, guys? Let me know in the chats if I'm perfectly audible, visible to each and every single student. And guys, we have an important session today. We'll be finishing, I would say, almost 12 chapters. The entire class 12th physics will be completing in the today's session. But I would want you guys to stay with me till the end because I'm going to show you all the problem patterns. Okay, each and every single point. If you haven't studied these chapters before, doesn't matter because I am going to start from the scratch. I'm going to start from the basics. Okay, let the people join and we are starting this particular session, and make sure everybody of you mark the attendance, okay, by smashing the like button, because liking the session is mandatory. Liking the session means marking the attendance. Okay. Yo. And one more important thing, guys, when it comes to the class 12th portion, like if we take electrostatics chapter, current electricity chapter, you take modern physics, these are considered to be the high weightage chapters. Okay, even in JE as well as NEET. So you cannot afford to miss this particular marathon. You cannot leave these sessions because all the problem patterns, each and every single thing, I'm going to start from the scratch. Is that clear? Is that clear, boys and girls? Yes. Okay, that's great. And when it comes to the number of chapters that we will be basically discussing, let me just show you over here. These are the number of chapters that we will be finishing by today. Electrostatics, okay, the potential portion, as well as I would say electric charges and fields portion. Capacitors, we say current electricity, we say magnetism, we say electromagnetic induction, we say AC. Then you have this is the modern physics portion, dual nature of matter and radiations, atoms, nuclei. You have got semiconductors, you have got wave optics, and you have got ray optics. These are the chapters that we will be finishing in the today's marathon, in the today's session. Okay. Yes. Is that clear? So make sure everybody of you smash the like button. Okay. And one more important thing, guys. I will be sharing the notes on this Telegram channel. So I would want you guys to join this Telegram channel also. That is t.me/Yawar, Yawar Manzoor, Manzoor. Okay. Or you can search this channel as Yawar Manzoor Physics. On Telegram, you'll get it as Yawar Manzoor Physics. Is that clear? That's great. Let's dive into the session. I think we must start. Let's start from the first chapter, that is electrostatics itself. Okay. So the first chapter is electrostatics. And when it comes to the chapter electrostatics, my dear NEET aspirants, I would say 4 to 5 questions are expected from this particular chapter. Okay, it is one of the high weightage chapters. 4 to 5 questions are expected from this particular chapter. Now, my dear NEET aspirants, when it comes to the electrostatics, the very first thing that we learn in this particular chapter is charge. What is charge actually? This is the first thing that we understand. This is the first thing that we learn over here. That is charge. Now, let me give you the simple and basic example by which you can understand this charge. Guys, make sure everybody of you make the notes, okay? Take the notes properly, because at the end moment means like just a day before NEET or 2 days before the NEET. Okay, You guys can revise from those notes only. Okay, it will take you hardly, I would say, 4 to 5 minutes in revising a complete chapter. Okay. Now, boys and girls, listen to me very, very, very carefully. When it comes to the charge, let me just give you the basic example over here. Let's suppose I take a comb. This is a comb that I'm taking over here. Okay. And I'll rub this comb with my hair. Okay. Then I'll take this comb near to the piece of papers. These are the small piece of papers. So these piece of papers will be attracted to the comb. These piece of papers will stick to the comb. That's what I can say. Why? Because when we rub this comb with my hair, at that moment, we say something is occupied onto this comb. When I rub the comb with my hair, something is transferred onto this comb. And due to that thing, we say these piece of papers are attracted. These piece of papers stick to the comb. And this is what we call charge. So can I say, whenever charge comes onto a body, due to this charge, it attracts other body, or we say it repels other body. As simple as that. Now, my dear NEET aspirants, listen to me very carefully. So charge is something due to which one body attracts another body. Like charge is occupied onto this comb when we rub the comb with my hair. Then it is attracting these piece of papers. So means because of the charge only, it is attracting these piece of papers. So due to this charge only, we get to see this magnetic effects over here. Yes. Now, my dear NEET aspirants, we have got two types of charge. The first one is positive and the second one is negative. Positive charge and negative charge. So boys and girls, if I say, let's suppose you have a rod over here. On this rod, you are placing positive charge. Let's suppose you are placing the positive charge on the rod. And then you have got another rod. On this rod also, positive charge is occupied, my dear NEET aspirants. So we can say, sir, these two rods actually repel each other. Okay. Why? Because positive repels. Okay. Like charges, we say repel. Now, my dear NEET aspirants, if you have negative charge and if you have negative charge on another rod, so we say in this case also, they will repel each other. Negative repels. Like charges repel and unlike charges attract. And if you have a positive charge, if you have a negative charge, we say positive, negative attract each other. So we say attraction is when you have positive charge on one rod and negative charge on another rod. So this is the definition of charge. Please tell me in the chats if this is crystalline clear till over here. Okay. Is this crystalline clear? Make sure you smash the like button because liking the session is mandatory. Now, my dear NEET aspirants, the first topic that we need to understand over here is Coulomb's law. Coulomb's law. Let's suppose, boys and girls, you have got over here that is charge Q1 and you have got over here charge Q2. Okay. Yes. Now, boys and girls, in this particular case, we say this is a positive charge Q1 and this is a positive charge Q2. These two positive charges are placed at r distance. Now, my dear NEET aspirants, we say whenever two positive charges are placed at certain distance, since this is positive, they repel each other. So means this positive charge is going to repel this positive charge with a force. And this positive charge is going to repel this positive charge with a force. And this force is what we call electrostatic force. So whenever you have two charges, they repel each other with electrostatic force. And my dear NEET aspirants, if somebody asks you, what is the value of this electrostatic force? You say K, Q1, Q2. K is what we call the Coulomb's constant. Q1 and Q2 are the charges divided by R square. This is what we call the force between the two charges. This is the Coulomb's law. So Coulomb's law says that if you have two charges placed at certain distance, they apply a force on each other. That is what we call Coulomb's force or electrostatic force. And my dear NEET aspirants, this K is actually 1 by 4 pi epsilon naught. This K is actually 1 by 4 pi epsilon naught. Now, my dear NEET aspirants, when it comes to this epsilon naught, this is what we call permittivity of free space. And value of this is 8.85 into 10 raised power minus 12. Okay. And my dear NEET aspirants, 8.85 in 10 raised power minus 12, I would say Coulomb square upon Newton meter square. Okay. Now, boys and girls, what I want you to understand, when you put the value of this over here, and then if you solve, value of K comes out to be 9 into 10 raised power 9. Okay. This is Newton meter square upon Coulomb square. This is the value of K. So from now onwards, my dear NEET aspirants, you'll be directly remembering two charges apply a force on each other, that is K Q1 Q2 by R square. So this is the force applied by Q1 on Q2. Similarly, force applied by Q2 on Q1. As simple as that. Is this clear, my dear NEET aspirants? Is this clear? Is this clear? This is the first question that we need to solve in this particular case. Is this clear, boys and girls? Come on, tell me. Is this clear? Is this clear? Give me the signal in the chats with the fire emojis, everybody. That's great. That's great. Make sure you smash the like button, okay, everybody? Now take a look, my dear NEET aspirants. What I want you to understand over here is, you guys are supposed to tell me what is the net force on at this 2 Coulomb charge. There's a square over here. You are supposed to tell me what is the net force on this plus 2 Coulomb charge, which is at this corner. So here it is minus 2, here it is plus 4, here it is minus 2. Now see, on this 2 Coulomb charge, positive plus 2 Coulomb charge, this negative is going to attract it with a force F1. Let's find the value of F1. F1 will be K Q1 Q2 by R square. Okay, K Q1 Q2 divided by R square. Now Q1, what is the value of Q1? It is basically the force between these two. Q1 over here is 2. Whenever you find the magnitude of the force, in that particular case, my dear NEET aspirants, ignore the negative sign, consider positive only. So Q1 is 2 Coulomb, Q2 is also 2 Coulomb. Ignore the negative sign because we are finding the magnitude of the force divided by R square. If this distance is 2, this distance is also 2, 2 square. 2 into 2 is 4, this is 4, so it will come out to be K. F1 is K. And if I say, so F1 came out to be K. Now this minus 2 Coulomb is attracting this plus 2 Coulomb with a force F2. If I ask you what is the value of F2, so I can say value of F2 is, that is K Q1 Q2 by R square once again. So we'll be saying K. What is the value of Q1? Q1 is 2. What is the value of Q2? That is also 2 divided by R square. This side is also 2 square. So this will come out to be K. 2 into 2 is 4. 2 into 2 is 4. Then, boys and girls, we say, what is the force due to this 4 Coulomb at this 2 Coulomb? This positive charge is going to repel this with a force. I call that as F3. So if I say the value of F3, my dear NEET aspirants, you again say K Q1 Q2 by R square. K. What is the value of Q1? So this is Q1 and this is Q2. You can simply say over here, this is 2 and this is 4 divided by R square. What is the distance between the two? That is 2 root 2. So you'll be saying over here, this is 2 root 2, its whole square. Now, boys and girls, 2 into 4 is 8. Now, 2 square is 4. Root 2 whole square is 2. 4 into 2 is also 8. So this is 8. This is also 8 when you solve. So it came out to be K. So what I'm trying to say is that this F1 came out to be K. This F2 came out to be K. And this F3 came out to be K. Now, boys and girls, listen to me very carefully. Listen to me very carefully. If I say, so this is the force F1, this is the direction of F2, and this is the direction of F3. F1, F2, and F3. How much is this F1? That is K. F2 is also K. and this F3 is also K. Now, one thing I would want you guys to remember over here, if you have two vectors, let's suppose, guys, these are the two vectors. This is F and this is F. What is the angle between the two? Angle between the two is 0. We say in this particular case, we say net force is equal to 2F. Directly remember. This is F, angle is 0. We say net force is 2F. If, my dear NEET aspirants, we say this is force F, this is force F. Two vectors are in the opposite direction. What is the angle between the two? 180 degrees. This angle, 180. When two are parallel means 0. In this particular case, we say net force is equal to 0. Cool? Absolutely. Then, my dear NEET aspirants, if you have a force F and if you have force F, angle between the two is 90. We say in this particular case, a resultant is root 2F. Directly remember, when theta is equal to 90. And if you have a vector F, another vector F, and angle between the two is 60 degrees. In this particular case, my dear NEET aspirants, we say net forces a root 3F. You guys are supposed to directly remember it. Okay? And if you have a force F, angle between the two is 120. So in this particular case, net force is also going to be F only. It will be F only. Okay, this is what you guys are supposed to remember. Now come on to this question. So you have got one vector K, another vector K. Angle between the two is 90. What is the resultant of these two? So resultant of these two is root 2K, because at 90 you have root 2. At 90 you have root 2, F root 2F, X root 2X. Okay. Now guys, take a look. Now you have mentioned the resultant of this one and this one. Now you can say from this side it is going to be K, and from this side it is going to be root 2K. Now, if let's suppose if this was also K and this is K, then I would have cancelled these two vectors. But since this is root 2K, this is K, in this particular case, I would say net force is going to be bigger force minus smaller force. That is a root 2K minus K. Now take this K out. You can say it is a root 2 minus 1. So this is the answer to the question. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Is this clear? Boys and girls, tell me quick. Let me know in the chats if this is crystalline clear. Now, this pattern I would say is very important. You can expect the question from this pattern in your NEET 2026. This pattern is important. Duration of the class is going to be 8 to 10 hours. Okay, we'll have to finish 12 chapters. Okay, we'll have to stay with me. Now, boys and girls, in this particular case, what does the question say? 2 point charges A and B, having charge plus Q and minus Q, respectively, are placed at certain distance apart. You have got a charge plus Q, you have got a charge minus Q, and these two charges are placed at certain distance apart. Okay. And force acting between them is F. So force between the two charges is F. We know that these two charges attract each other with a force F. And that F will be K, Q into Q, Q1, Q2. Q into Q becomes Q square divided by R square. This is the force between two. This force between the two. Absolutely. Now, then the question says, if 25% of charge, if 25% charge of A is transferred to B, it says that if you transfer 25% of this charge, 25% of this Q to this charge B, okay, then the force between the charges become. What is going to be the force between the two charges? What is going to be the force between the two charges? So, my dear NEET aspirants, listen carefully. Let's suppose if I say I have got Q charge over here, how much it is? 50%, 20%, 30%. If it was 20%, then I would have mentioned in the question it is 20%. If it is 50%, I would have mentioned in the question. So if it is Q only, it means it is 100%. So you have got 100%. Now, if you are transferring 25%, so how much will be the remaining charge? That will be 75%. 75 plus 25 is 100. So what I can say in this particular case, finally, value of this QA will become 75% of Q. Now 75% we can write 75 divided by 100 of Q, because 25% is 25 by 100, 30% is 30 by 100. So 25 3s are, 25 4s are. So this came out to be 3Q by 4. So when you transfer 25% of the charge from this first charge, how much will be the remaining charge over there? That is going to be 3Q by 4. That is going to be 3Q by 4. Absolutely. Now, when it comes to this one, my dear NEET aspirants, this one, charge on B. Sir, charge on this B in this particular case would be, listen carefully. Charge on this B would be, already it was minus 100% of negative charge. It is negative charge 100%. 100% of negative charge. Then you are adding 25% of positive charge. 25% of positive charge. Now tell me, negative 100%, positive 25%. 100 minus 25, that will be 75. So QB will come out to be minus 75% of Q. Sir, what if this was also positive? In that particular case, I would say, so when you transfer 25%, it was already 100% of Q. You are adding 25%, it would become 125%. So my dear NEET aspirants, in this particular case, you say 1 minus 100%. So means you are adding 25%. So what is going to be the remaining charge? That is minus 75%, negative 75%. So what can I say in this particular case? QB will come out to be minus 75 divided by 100 of Q. Again, 75 by 100 Q. So it will be minus 3Q by 4. QB. Now it says, we are supposed to find the force between these final charges. Now, place this 3Q by 4 over here. At R distance, you are going to place this negative 3Q by 4. Now, what is going to be the force when you transfer 25% here? Finally. So you say, sir, force finally will be F dash. K Q1 Q2 by R square. K means K. Q1 in this particular case is 3Q by 4. Q2 in this particular case is 3Q by 4. Divided by, I would say over here, R square. So what I can say in this particular case, 3 into 3 is 9. Divided by 4 into 4 is 16. Now Q into Q is basically Q square divided by, I would say, R square. And this K. Now KQ square by R square is actually F. So you can simply say F dash will be, that is 9 by 16 of F. 9 by 16 of F. This is the question. And my dear NEET aspirants, in this particular case, they can keep this as positive, keep this also as positive. In that particular case, if you are transferring 125%, this will become 125%, this will become 25% only. So please tell me in the chats if this is clear. Give me the signal in the chats, everybody. Come on, give me the signal in the chats. One more question which I want you guys to explain over here. Give me the signal in the chats if this is crystalline clear. Quick. Smash the like button. Everybody means everybody. Because liking the session is extremely mandatory, boys and girls. That's great. Now let's take a look at this particular question. A particle of mass m carrying charge minus q is moving around plus q2. There is a particle which is having the charge, which is having the mass m carrying charge minus q is moving around q2. There is a charge over here q2. Around this charge, there is one more charge which is revolving around this. Charge. Okay. This one is at center. And there is one more charge which is revolving around. This is minus q1 and its mass is m. It is revolving around this charge. Okay, and it is at, let's suppose, r distance. Now, boys and girls, it says that in a circular path, find the time period. It says if it is revolving around this charge in a circular path, find the time period. Time period means in how much time it is going to complete one circle, one cycle. That's what we call the time period. Now, boys and girls, what I want you to understand in this particular case, listen carefully. Whenever you have this sort of problem, so you do one thing, even similar type of question is asked in the gravitation. Over there, you have two masses. Here you take two charges. In this particular case, what is the force acting on this charge? Force acting on this charge will be electrostatic force. Why? Because you have two charges placed at certain distance, electrostatic force. So force on the two charges, electrostatic force, and that electrostatic force is K Q1 Q2 by R square. Absolutely. And my dear NEET aspirants, since the charge is moving in a circle, okay, whenever an object moves in a circle, we say centripetal force acts on the particle. Whenever the charge moves in a circle, it has got centripetal force acting on it. And that centripetal force is F is equal to mr omega square. Omega is the angular speed with which it is rotating, with which it is basically revolving, angular velocity. Now, my dear NEET aspirants, or you can also say this is mv square by r. Either you say mr omega square or mv square by r. R is the radius of that circle, and m is the mass, omega is this angular frequency you say, angular velocity you say. Now, boys and girls, whenever an object moves in a circle, we say here this electrostatic force becomes, this is actually equal to, I would say, centripetal force. So what I can say, this will be K Q1 Q2 divided by R square. It will be equals to centripetal force, that is mr omega square. We are supposed to find time period. What is the first thing we did? We checked the number of forces acting on the particle. That came out to be K Q1 Q2 by R square. And then mr omega square is the centripetal force. Then balance the two. Now take this r cube over here, m over here. So omega square will come out to be K Q1 Q2 divided by m into r cube. Now, boys and girls, one thing you must understand, this omega is actually equal to 2 pi by t. This is the relation between omega and time period. So you can say over here, this is 2 pi, okay. This is 2 pi divided by t, its whole square. When you take the square over here, it will become under root of K Q1 Q2 divided by mr cube. Now do the reciprocal. So it will become t divided by 2 pi. From this side, it is going to be, that is m into r cube divided by, I would say, K Q1 and Q2. What you need to find out over here is, that is this time period. So take this 2 pi in this case over here. So this 2 pi under root of, I would say, m r cube, then I would say K, and this is Q1 and this is Q2. Guys, tell me in the chats if this is crystal and clear. This is the time period of the charged particle moving in a circle. Please tell me in the chats if this is crystal clear to each and every single student. Come on, boys and girls. Everybody means everybody. And smash the like button. Everybody, oh. Smash the like button and mark your attendance. Now, let's take a look at this. Let's take a look at this. Equilibrium of two suspended charges. Equilibrium of two suspended charges. Boys and girls, listen carefully. Whenever you see the question of this sort, see, let me make you understand, my dear NEET aspirants. Yes, you can remember the formula directly over here. You can remember this formula directly over here. Guys, see, this is very, very important. This is very, very important, this pattern. Let's suppose, my dear NEET aspirants, you have got over here, there is a thread. This is a ceiling. I'm attaching a rope. A rope means thread. This is the thread. This is the thread. Now there is a charge attached to this thread over here. There is a charge attached to this thread over here. Okay, this is the charge attached to this thread. And there is one more thread. Okay, this thread, this thread. Okay, these are the two threads. charges are attached to these two threads. Now, initially, boys and girls, listen carefully. Initially, the two charges would be something like this, close to each other. Close to each other. But since the two charges are having Q and Q plus Q positive charge, so we said these two charges will repel each other. When they repel each other, they will go away, 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 away and stay here. This is the position. This is the position what we call as equilibrium position. Because at this position, these two spheres, these two charges remain at rest. Okay. Okay. So my dear NEET aspirants in this particular case, what I want you to understand, so when the two charges come in equilibrium, so here, these two charges come into equilibrium. So basically two charges are repelling. So at this particular instant, they will come into equilibrium. Now, if somebody asks you what are the forces acting on this charge, listen carefully. Whenever you have to solve this kind of problem, this pattern, simply when you see the word equilibrium, it means net force on the charge is zero. It means upward force is equal to downward force. Right side force is equal to left side force. Now take any charge. Since the charge is in equilibrium at rest, so take any charge. What is the force acting on this charge in the downward direction? I would say mg. What is the force acting over here in this? In the rope, the force acting is tension. Tension is always developed in the rope. And if this is T, this angle is theta. Boys and girls, you must understand this angle is also theta. This would be also theta. So if this is T, this is theta. This component of T would be T cos theta. And this component of T would be T sin theta. Why? Because if angle is made with this axis, then we consider this as cos. This would be sine. And since this charge is applying the force on this charge, that is electrostatic force, that is K Q square, because Q into Q becomes Q square divided by R square. So what is the first thing you guys are supposed to do in this particular case, boys and girls? If you find the charge is in the equilibrium, that means whatever the force acting on the charge in the upward direction will be equals to the force acting in the downward direction. Force acting on the right side will be equals to force acting on the left side. Now, boys and girls, let's suppose if somebody tells you that we are removing the charge from these two spheres, they'll again come back to the original position. Again, if you put the charge on both the two, they will repel. Now, what I want you to understand in this particular case, balance the forces, because equilibrium means balancing the forces. This will be equal to this. T sin theta has to be equals to K Q square divided by R square. Or it is given as x square, so write x square. Because distance between the two is x square. Okay. And T cos theta has to be equals to what? That is mg. Now, boys and girls, I would want you guys to divide the two equations. So T and T will cancel. Sin by cos means tan. So tan theta will be equals to that as kq square divided by x square into mg. So this comes out to be the value of tan theta, my dear NEET aspirants. Now listen to me very carefully. So can we remember this equation directly? 100%. You don't have to do this again and again. You can directly remember this equation. So this is the value of theta. So at what angle it is, what is the angle it is making, this suspended thread is making with the vertical. Now, boys and girls, one thing I must tell you over here. What is that? Listen carefully. Let's suppose length of this thread is given as L. And in 99% questions, you will be given in the question, theta is very small. So the angle made by this suspended charge with the vertical is very small. Listen carefully, this condition. I would want you guys to give me 100% attention over here. If theta is given very small, in that particular case, my dear NEET aspirants, you can say value of tan theta would be equals to sin theta. If theta is very small, in that case, we say sin theta is equal to tan theta. That is equal to theta itself. Now, guys, see, If theta is very small, can I say in that particular case, instead of tan, I can write sine theta will be equals to, that is k q square divided by x square mg. 100% I can say it like that. Now, guys, could you please tell me what is the value of sine theta from this triangle? Sine theta. Sine theta, this is theta. So this side, which is made with the theta over here. So this will be considered as base. This will be perpendicular and this is hypotenuse. Sine theta is perpendicular upon hypotenuse. If this distance is x, how much would be half of this? X by 2. So sine theta is perpendicular, that is x by 2, upon hypotenuse. Hypotenuse is L. So what you can say in this particular case, instead of this sine theta, you can write x divided by 2L will be equals to kq square upon, I would say, x square into mg. Okay. Now this equation. Now could you please tell me, boys and girls, this is the equation which I want you guys to. Okay, take this x over here. This will be x cube is equal to, this would be k q square. Okay, k q square, and this 2L over here divided by, I can say, m into g. Now can you tell me the value of x? X will be 1, this is k q square 2L divided by mg, and it is 1 by 3. Sir, this condition, are we supposed to apply in every question? No. This condition you guys are supposed to apply in that question only in which theta is very small. If theta is very small, then you can say tan theta will be equals to sine theta. And then you can put the value of sine theta, you will be getting the value of x. Okay, now take this equation once again. Take this equation once again. That is x divided by 2L is equal to k q square divided by x square into mg. Now, can you find the value of q square? Take this x cube over here, mg over here, okay, okay, divided by, you have got 2L is equal to kq square, absolutely. Take this, so what will be the value of q? Take this k over here, this will be x cube mg divided by 2L into k, and it's under root. Because square, if you take it over here, it will become root. This is the value of q. So my dear NEET aspirants, this expression exactly was asked in JEE 2021. And this expression, exactly this expression, this was asked in JEE 2021 also, but in another shift. Please tell me if this question is crystalline clear. This method is applied only in that case where theta is very small. In that particular case, you would be saying sine theta is equal to tan theta. Tan theta is equal to sine theta. Tell me, oh, smash the like button if you're not like the session yet. Come on, do it quick. Is this clear? So how many questions we solved in just one question? 3. Value of tan theta, value of q, value of x. Now we have to find the tension. We have to find the tension. Let's find tension. Let's find tension. Let's find tension. Let's find tension. Now see, if you guys have to find the tension, consider any charge. Consider a charge. This is the charge. What is the force acting on this charge? Could you please tell me? Sir, in this direction, it is electrostatic force. In this direction, you have got mg. And in this direction, you have got tension T. Absolutely. Absolutely. Now, my dear NEET aspirants, you have got 2 forces over here. 2 forces over here. Could you please tell me what is the resultant of this and this force and this force? Sir, that is going to be this. This is the resultant, R. And how do you find the resultant of 2 forces? Guys, see, resultant of 2 vectors is under root of a square plus b square plus 2ab cos of theta. Theta means angle between a and b. If you have 2 vectors over here, what is the angle between 2? That is cos 90. Okay, depends on what is the angle between the 2 vectors. Here it is 90. It is actually theta. Now cos 90 is 0. This entire term would be 0. What is the resultant in this particular case? Under root of a square plus b square. Means under root of first vector, second vector, its square. Now what is the resultant here? Under root of, that would be this Fe square, electrostatic square, plus I would say mg square. Yes. Now, since you have mentioned the resultant of this and this, now this is the charge Q. On this charge in this direction, R is mentioned. So on this, in this direction, we say tension is acting. Now, boys and girls, could you please tell me, is the charge in the equilibrium? Absolutely. So I'm mentioning only three forces, okay? Don't say T sine and T cos theta will also act. No. Why? Because when you resolve T, then you can say T cos and T sine is acting. When you consider T only, then you don't have to mention this and this. Either you take these two, like I did over here, or you take T only. Now tell me, if the charge is in the equilibrium, what does it mean? Force acting in the upward direction will be equal to the force acting in the downward direction. Force acting in the left will be equals to the force acting on the right. Force acting in this direction will be equals to the force acting in this direction, because equilibrium will be from all the sides. So this force has to be equal to this force. So what I can say, tension will be equals to R, and this will be equals to under root of electrostatic force square. Then I would say mg square. So this is what we call, my dear NEET aspirants, in this particular case, tension. So 4 questions we solved in just one question. This is just a question in which you have got 4 questions involved. Please tell me in the chats if this is crystalline clear. So this is basically the value of x. This is basically the value of x in this particular case. This is basically the value of x in this particular case. This one. This is the value of tan theta. This is the value of Q, and this is the value of tension. Please tell me, guys, if this is crystalline clear. Please tell me if this is crystalline clear. Come on. Give me the signal in the chats if this is crystalline clear. Clear? Yo. That's great. That's great. Guys, smash the like button. Everybody of you. Smash the like button, boys and girls. Come on. Now, let's take a look at this. Electric field, I would want you guys, see, if in the question theta is given as very small, then you can directly remember these. Okay, so basic equation is this one. You guys are supposed to remember this one, then it is just a matter of seconds you can find those. Now, let's take a look at this particular topic. Electric field due to a point charge. Guys, see, let me make you understand the electric field first. Let's suppose you have got a magnet over here. This is a magnet. Okay. We know, my dear NEET aspirants, if you place a coin over here, it will be attracted. If you place the coin over here, it will be attracted. Over here, it will be attracted. Over here, it will be attracted. So can I say this magnet is creating some sort of field around it? And if in that field, a piece of iron, a piece of coin comes, it experiences force. It will stick to the magnet. So this magnet, this field is what we call the magnetic field. So a magnet creates the magnetic field around it. Similarly, if you keep a charge over here, if you place another charge over here, let's suppose this Q naught, this Q naught will be repelled. Okay. Here, this Q naught will be repelled. Here, this will be repelled. Here, repelled. So can I say this charge also creates some sort of field around it? And if in that field some other charge comes, it also experiences force. So this is what we call electric field. So a charge creates electric field around it, and a magnet creates magnetic field around it. That's the difference between the two. So on this coin, we say magnetic force acts. On this charge, we say electric force or electrostatic force acts. Now, since the charge creates the magnetic field around it, If somebody asks you, what is the electric field due to a point charge? This is a point charge, let's suppose Q. Since it is creating the field around it. If I say you go at r distance, what is going to be the electric field due to this charge? You say electric field at r distance is going to be, that is E is equal to, I would say K Q divided by r square. What is the electric field due to this charge at r distance? Kq by r square. Q is the charge, r is the distance. Yes. Now clearly you can say E and R is having the inverse relation. E is inversely proportional to r square. What does it mean? It means that if you go away from this charge, means if you increase R, E is inversely proportional to r square. Means if R is increased, we say electric field decreases. Obviously, if you are close to Q, then electric field will be large. If you are far from Q, in that particular case, electric field is going to be less. That's what we can say. Yes, I can say it something like that. Now, boys and girls, what I want you to understand in this particular case, that is, if somebody asks you what is the graph between E versus R, so it is going to be this. Okay, a rectangular hyperbola, because E is inversely proportional to r square. So graph will be rectangular hyperbola. This is the electric field due to a point charge at r distance. Now listen to me very carefully. I would want you to understand this. Let's suppose you have got this charge Q and at this point you are placing the charge, another charge, let's suppose Q. If I ask you what is the electric field due to this charge at this point at r distance, you say electric field is K this Q divided by r square. Now, my dear NEET aspirants, what is the force acting on this charge? What is the force acting on this charge? You say, sir, force acting on this charge is F is equal to K, this Q1, this Q2 divided by r square. This is one way to write the force. There is another way also to write this particular force over here in terms of electric field. We say force on Q. Force on Q, this Q. It can be mentioned, it can be written something like this also. F is equal to this charge Q multiplied by the electric field present at this point, that is E. Now, this equation I would want you guys to remember. Now, I can say this F is equal to, this is Q. What is the value of electric field? That is K, Q divided by R square. So, F is equal to K, Q into Q, Q into Q divided by R square. Now, compare this and this. Sir, it is exactly similar. Yes. So, I can say force acting on the charge is like this also. This is in terms of electric field, Q times of E. This is in terms of electric field, that is Q times of E. Okay, now, boys and girls, what I want you to understand in this particular case, listen carefully, listen carefully. I would say, let me show you something like this. Electric field due to a ring on its axis. Electric field due to a ring on its axis. I want you to understand this very, very, very carefully. Let's suppose you have got a ring. You take a ring, okay? A ring. And on this ring, you are distributing the charge. You are placing the charge. How much charge? Q. Radius on this ring, radius of this ring is R. Now, if I say, if there is a charge, will it create electric field? You say, sir, obviously it will create electric field. So if you place that charge onto something, a ring, this pen, will this pen also create electric field? Absolutely. Why? Because charge is occupied onto this, charge is placed onto this. So whenever charge is occupied onto something, it creates electric field. So in our syllabus, we don't have to learn the electric field due to this pen, but we have to learn electric field due to the ring. Now, if I say electric field due to this ring at a distance, I would say X from the ring. This is the distance X from the center. So at X distance, electric field would be, that is K, Q, X. K is the Coulomb's constant, Q is the charge, X is the distance, upon, I would say R square plus X square whole raised power 3 by 2. This is the electric field due to a ring at X distance. Now, boys and girls, what I want you to understand over here, we say, let's suppose if I say at center. at center. Could you please tell me what is the value of x? That is 0. Bro, if you move away from the center, x is going to increase. If you move towards the center, x is going to decrease. Exactly at x, what is the value of, exactly at center, what is the value of x? That is 0. So if you put the value of x 0 over here, entire electric field due to the ring at the center would be 0. Absolutely. Now, case 1. Case 1. Close to the ring. Listen to me very carefully. Close to the ring. Close to the ring. Let's suppose you have got a ring over here. Radius of the ring is r. Close to the ring means if this is a ring, just outside the center, at very small distance. Okay, this point means far from the ring. This point means close to the ring. At close to the ring, very close to the ring, we say this x is much less than r. This x is much less than r. So if this x is very small as compared to r, so we say it means adding a very small quantity to a very large quantity. It is like adding a bucket of water to the ocean. Will it create any difference? No. Why? Because ocean has got billions of liters of water. So adding a bucket of water to the ocean will create no difference. So you can neglect x in this particular case. So when you neglect x, what remains? Electric field will be, that is kqx. Guys, here in multiplication, we don't neglect it. In addition, subtraction. So divided by, I would say over here, this is r square whole raised power 3 by 2. This and this will cancel. So it will be kqx divided by rq. This is the electric field due to a ring at very close point, just outside the center. At center exactly, it is 0. Very far from the ring. Far from the ring. Okay, this is case 2. So if I say electric field due to the ring at very far distance, let's suppose this is a ring and radius of the ring is r. At very far distance, this is x at this point. Now, my dear NEET aspirants, at this point, I would say x, I would say this r is much less than x. If r is much less than x, we need to neglect r. So what will be the electric field? Electric field will be kqx divided by, I would say x square whole raised power 3 by 2. 2 and 2 will cancel. So it will be kqx divided by, I would say x cube. 1x and here it remains x square. So it will be kq divided by x square. Okay. So this is very far from the ring kq by x square. This is very close to the ring kq x upon r cube at center and it is at x distance. Now, my dear NEET aspirants, if I plot the graph, this graph is very important. If I plot the graph between electric field versus x, and here electric field is 0. At center, electric field is 0. At x is equal to 0, electric field is 0. Now, graph would be something like this. Because in this particular case, boys and girls, these are the points. This is the center of the ring. These are the points close to the ring. These are the points far from the ring. See, what is the electric field close to the ring? Directly proportional to x. If it is directly proportional to x, that's why E is directly proportional to x. And far from the ring, it is going to be something like this. And join this with a smooth curve. So this is electric field is inversely proportional to x square. Now see, electric field is inversely proportional to x square. Very far. This is very close. Very close. This is very far. Now guys, this ring creates the electric field on the right. This ring creates the electric field on the left. So on the left side, we take electric field negative. This is E versus X. So similar graph, this one. And my dear NEET aspirants, let me just tell you, this is the point where electric field is maximum. So at X is equal to R divided by root 2, we say electric field is maximum. On the left side, if somebody says, sir, at X is equal to minus R divided by root 2, we say this electric field is going to be maximum. So this is the graph. This is very, very important. Very, very important. So electric field is maximum at R divided by root 2, R divided by root 2. Even this question was asked so many times in JEE. This was asked in JEE 2022, JEE 2024. At what value of X electric field is maximum in case of the ring? R divided by root 2. Over there, value of R was given A root 2. Radius of the ring was given A root 2. Now, could you please tell me what is the value of X? R divided by root 2. That will be A root 2 divided by root 2. This and this will cancel, so at A. Hey, simple, bro. Tell me in the chats, is this clear? Come on. Everyone means everyone. Let me know in the chats. Is this clear? Give me the signal in the chats. No. Negative is just telling you the direction. Don't say it is minimum. It will be maximum from this side also. If I say electric field is maximum from this side, it will be maximum from this side also. So negative sign just tells you the direction of electric field. If electric field is positive, direction is towards right. If electric field is negative, direction is towards left. Okay, this question, very important question. Next level question. Take a look. A thin copper ring of radius A. There is a thin copper ring which is having the radius A. A thin copper ring which is having the radius A is charged with Q units of electricity. It has got the charge Q on it. Its radius is A. Okay. An electron is placed at the center of the ring. So electron is placed at the center of the ring. Electron has got negative charge. If the electron is displaced little, if you displace the electron little, okay, if you displace the electron little by x distance, such that x is very, very small, it will have the frequency. See guys. Listen, no? Listen. This is a positive charge. This electron is the negative charge. It is like this. This is positive charge and this electron is negative charge. If you displace this electron till here, this positively charged ring will attract it back. So when it attracts back, it will reach the center. But since it will not stop at center. Why? Because it has already gained motion. So it will cross the center and will reach here. Again, this positively charged ring will attract. It will go back. It will not stop here. It will go here. So it will basically perform the SHM. It will perform SHM. It is like pendulum. If you displace the pendulum, it will come back. Will it stop at the original position? No. It will go here. It will keep on oscillating. Same is the case over here. So my dear NEET aspirants, if it is oscillating, you have to tell me frequency. Frequency means number of oscillations per second. Take a look. If an object starts from here, it goes till extreme. If it comes back, sir, is this one oscillation? No, this is half of the oscillation. If it goes till left extreme, then comes back, this is one oscillation. How many oscillations it will do in 1 second? That is called frequency. If I say it is doing 10 oscillations in 1 second, so means frequency is 10. Frequency is 10. And what is one oscillation? From mean to extreme, then back to mean, half of the oscillation. Then to the left extreme, then back to the mean. This is complete oscillation. Now, boys and girls, listen, how do we exactly solve this particular question? Could you please tell me, if it is displaced till over here, what is the electric field? When X is much, much less than R. Because it says we displace it very little. So means X is very small as compared to the radius R. In that case, electric field is KQX divided by R cube. In that particular case, we say electric field is KQX divided by R cube when it is displaced very little. Yes. Now, could you please tell me what is the force? Force on the charge. Force on the charge. You'll simply say force on the charge is going to be, guys, see, that is Q times of E. So F is equal to Q. Q is this charge, that is E. E is the charge on an electron. And since radius of this is a, instead of r, I'll be writing a, kqx divided by a cube. So E, charge is basically this E because this is E. Electric field, that is kqx divided by a cube. This is the force on the charge. Now, my dear NEET aspirants, if this is the force, can you find acceleration? Acceleration is force divided by mass. So acceleration is force, that is kqex divided by m into a cube. This is acceleration. Now, boys and girls, I want, since this charge is performing SHM over here, this is the acceleration that we got. And we know the general equation of SHM as we know acceleration of SHM. If an object is performing simple harmonic motion, its acceleration is a is equal to minus omega square of x. Here also you can put minus. Why? Because if the electron is displaced towards left, force is opposite towards, if the electron is displaced towards right, force is left. That's why negative. You can ignore negative. So this is the acceleration that we got here. This is the acceleration of SHM. Now compare a x x. Could you please tell me, this is equation first, this is equation second, from first and second. From first and second. Can I say omega square will be equals to, that is kqe divided by, that will be m into a cube? Absolutely, sir. Now omega, take this root over here. Omega will be under root of kqe divided by ma cube. Now tell me, can I write omega over here 2 pi into f? Guys, we say this omega is also equal to 2 pi into f, which is also equal to 2 pi divided by t. 2 pi divided by t. Even you can find the time period also, in how much time it completes one oscillation, that is the time period. So 2 pi f is equal to under root of kqe divided by ma cube. Now take this 2 pi over here. So frequency will come out to be 1 divided by 2 pi under root of kqe divided by ma cube. I hope this is clear. Even you can find the time period also. Time period will be the opposite of this, the reciprocal of the frequency. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Come on. Quick. Quick. Is this clear? Is this clear, boys and girls? Is this clear, boys and girls? Smash the like button if you're not like the session. Come on, do it quick. Okay, let's move on to the next one. Let's move on to the next one. That is what we call the Gauss law. Okay, that is what we call the Gauss law, or we say electric flux. Now guys, let me make you understand what this electric flux is. Listen to me very carefully. Let's suppose you have got a surface over here. Let's suppose you have got a surface over here. Okay, and you have got this surface. This surface. And let's suppose I place a big charge over here. Because of that charge, electric field is coming out. This is the electric field coming out of the charge. This is the electric field coming out of the charge. Yes. Now, if I ask you, my dear NEET aspirants, this is the electric field and this is the surface 1, this is the surface 2. If I ask you how many number of field lines, so basically this is a charge, from this charge field is coming out. We represent field in terms of electric field lines. And this field is crossing the surface perpendicularly. If I ask you over here, what is the number of field lines crossing this surface? You say 1, 2, 3, 4, 5, 6. So we say flux. 5 means flux. Flux through this first surface is 6. And how many number of field lines are crossing through this? 1, 2, and 3. Flux through the surface 2 is going to be 3. So then how do we define electric flux? It is the number of field lines crossing the surface perpendicularly. Number of field lines crossing the surface perpendicularly is what we call flux. Sir, this is the surface. This is the field line. Is this field line crossing this surface? Yes, flux is being created. Sir, is this field line crossing the surface? No, no flux. Flux is 0. Why? Because it is just touching the surface. So in order to create flux, so field must cross through the surface. Now see, we said this flux is equal to electric field E. More is the electric field, more field lines will cross, more will be flux. Area A, more is the area. You see, this is having the bigger area. More number of field lines are crossing, so more is flux. And then we say cos of theta. Theta is the angle between E and A. This is how do we define electric flux. Theta is the angle between E and A. And we can write it like this also. Like AB cos theta, that is A dot B, dot product of two vectors. EA cos theta, you can simply say that is E vector dot A vector. When you say E vector dot A vector, this is what we call electric field dot area, E dot A cos of theta, E into A cos of theta. Okay, EA cos of theta. Absolutely, absolutely, boys and girls. Okay, yes. Now, Gauss law. What does Gauss law actually say, my dear NEET aspirants? Listen to me very carefully. It says that flux through any closed surface is equal to the charge inside upon epsilon naught. Guys, see. Let's suppose there's a closed surface placed over here, cylinder. So there is a charge placed inside the cylinder. Could you please tell me, will there be field lines coming out of this charge? Yes. These are the field lines coming out of this charge. These are the field lines coming out of the charge. Sir, are these field lines crossing this cylinder? Absolutely. Now, if somebody asks you, could you please find how much is the flux crossing through this cylinder? Gauss said, you don't have to calculate this. Directly remember, flux through any closed surface. It will be whatever is the charge inside, that is Q. If it is 10Q, I would mention 10Q. Divided by epsilon naught. Flux through any closed surface is equal to the charge inside divided by epsilon naught. Like here, what is the flux through this closed surface? Sir, here also it will be Q divided by epsilon. That's it. Okay. Let's suppose if I give you the question over here. There is a sheet and charge is placed at corner of the sheet. Because of this charge, field lines are coming out. These are the field lines coming out of the charge. This is the question of AIPMT 2015. Okay. Sir, are these field lines crossing the sheet? No. So we can say flux through this sheet will be 0. A reason is why? What? No field line is crossing the surface perpendicularly. Now see. If I say the charge is placed at this, we say face of the cube. Imagine there's a cube. Charge is placed at the face of the cube. It is not placed inside. So can we consider this as an enclosed charge, inside charge? No. So my dear NEET aspirants, what I would recommend you guys to do over here is, in order to make that, because when you find flux is equal to Q inside by epsilon naught. So this is not the charge inside. What you do is you attach one more cube from this side, imaginary cube. So if the charge is placed at the cube, sorry, at the face, then you attach how many cubes from? How many cubes? We say one cube. Okay, I would say add one more imaginary cube. Imaginary cube to enclose the charge. Enclose the charge. Enclose the charge. Okay, because this is not the enclosed charge. So my dear NEET aspirants, then can I write, sir, flux through two cubes will be equals to the flux through closed surface? Why? Because then for this charge, closed surface means two cubes. Because of two cubes, this becomes an inside charge and closed charge. And if we talk about this, for this charge, closed surface is just one surface. You can also write it like this, flux through one cube. Either you say flux through one cube or you say flux through closed surface, it is one and the same thing. Here, this is not an enclosed charge. You need to attach one more. So by attaching one more, it means two cubes. Through two cubes, I would say that will be the closed surface for this charge. So flux through closed surface is Q by epsilon naught. If through two cubes, this is the flux. Through one cube, how much it will be? Guys, this is the flux through two cubes. Okay. So can I say flux through one cube? It is going to be, guys, listen to me very carefully. That is Q divided by 2 epsilon naught. Are half of this now? 1 by 2. Yes. Now listen here. Sir, do we have to do this again and again? No, bro. Directly remember this. Directly remember this. Now see. If the charge is present at the edge, is the charge enclosed? No. Here you need to add 3 more cubes. 3 more cubes. Now, if I say what is the flux through? 3 more cubes means total is how many? How many? 4. So total of 4 cubes. So I can say flux through 4 cubes. It will be equals to flux through closed surface, because here closed surface is made up of 4 cubes for this charge. It depends upon where the charge is actually. Okay. So I can say this will be Q divided by epsilon naught. So could you please tell me what is the flux through 1 cube? You say flux through 1 cube will be Q divided by 4 epsilon. If the charge is at corner, in this particular case, I would say add 7 more cubes. So can I say flux through 1 cube? Flux, so 7 more you are adding. So how many total number of cubes will be there? So total 8. So I can say flux through 8 cubes is equal to flux through closed surface is equal to Q divided by epsilon naught. What is the flux through 1 cube? 1 cube. That will be Q divided by 8 epsilon naught. So what you guys are supposed to remember, that is this. If the charge is present at the face, Q by 2 epsilon naught. If the charge is present at the edge, Q divided by 4 epsilon naught. If the charge is present at the corner, Q divided by 8 epsilon naught. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats, everybody out there. Tell me, guys, quick. In the chats, everybody, is this clear? Oh? Is this clear? Is this clear? Come on. Is this clear? Give me the signal in the chats. Is this clear? That's great. Smash the like button if you are not liked the session yet. Now see. There is a question over here. This is also a very important question. If the flux through the curved surface, if the flux through the curved surface is phi naught, if the flux through the curved surface is phi naught, then find the flux, then find the flux through one plane surface. Then find the flux through one plane surface. Flux through curved surface is phi naught. You guys are supposed to tell me what is the flux through one plane surface. Okay? Yes. See guys, this is a cylinder. This cylinder has got how many surfaces? 3. Curved, plane, this plane. So if the charge is placed inside, I can say flux will be created through this plane surface also, through this curved surface also, through this plane surface also, through this curved surface also. Now, can I say, my dear NEET aspirants, in this particular case, if I say flux through the cylinder, okay, this will be flux through the cylinder. Can I say, my dear NEET aspirants, this flux through the cylinder means flux through two plane surfaces plus flux through one curved surface. Arey, flux through the entire cylinder means flux through two plane surfaces plus flux through one curved surface. And this is what we call flux through the closed surface. Because for this charge, this cylinder is a closed surface. Either you call it the cylinder, or you call it closed surface, or you call it two plane surfaces plus one curved surface. Yes. Now tell me, can I write it over here? Flux through two plane surfaces plus flux through one curved surface, it will be equals to flux through closed surface, that is Q divided by epsilon naught. Now what is the flux through curved surface? So can I say flux through two plane surfaces plus flux through one curved surface is phi naught? It will be Q divided by epsilon naught. Absolutely. Now can you take it over here? So you can say flux through two plane surfaces, it will be Q divided by epsilon naught minus, I would say, phi naught. So this is the flux through two plane surfaces. But what we are supposed to find out is flux through one plane surface. So you can say flux through one plane surface, it will be half of this. Through two, it is this much. So through one plane surface, it will be 1/2 of Q divided by epsilon naught minus, I would say, phi naught. This is the flux through one plane surface. Guys, is this question clear? Is this clear? Please tell me in the chats. Absolutely. 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 Okay, one more question I would like to give you over here. Let's suppose if somebody asks you the question, find the flux through the cube. Through the cube. Question is something like this. Question is something like this. This one. This one. There is a rod placed inside. This is a rod. This rod has got the charge density of lambda. This rod has got charge density of lambda, and this side is A. You are supposed to tell me what is the flux through the cube. See, you'll say, sir, flux through the cube is, this is flux through closed surface, that is charge inside divided by epsilon naught. But the problem here is you don't know how much is the charge inside. You have to calculate the charge inside. Listen carefully. Listen carefully. Sir, shall we consider this outside charge also? No. Whenever you say flux through the closed surface, it means charge inside. Let's find charge inside. Sir, how? Sir, there is a formula, lambda is equal to Q by L. Lambda means charge per unit length. Charge per unit length means charge upon length. Okay. So if I say this is a rod, on this rod, how much is the charge present on the unit length? You say, sir, that will be lambda, charge on the unit length. That will be total charge on the rod, Q divided by total length of the rod. So total charge on the rod is Q, total length is L. So lambda means Q by L, charge on the unit length. Okay. Now from here you can say Q is equal to lambda into L. Okay. Now if you have to find Q inside, means you are supposed to take this much length of the rod, because this much is the length of the rod which is placed inside. So can I say this much of the length of the rod is how much? A. So if we consider the total length of the rod, then means you are considering the total charge. If you have to find the charge which is present inside the cube, in that particular case, you are supposed to take that length only, which is present inside the cube, that is A. So this charge inside will be, that is lambda into A. Now put it over here. So flux through the cube or closed surface, it will be Q inside, that is lambda into A divided by epsilon. I hope this question is also clear. Guys, give me the signal in the chats. Is this clear? Come on, quick, 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 quick. Tell me, is this clear? Is this clear? Smash the like button if you're not liked the session, and I would want you guys to do it quick, 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 as soon as possible. Okay, that's great. Let's take a look, my dear NEET aspirants. Let's take a look, my dear NEET aspirants. Electric field due to a hollow sphere. Okay. Either you call it the hollow sphere, you call it the metal sphere, or conducting sphere. Okay. You don't have to be confused whenever they give you any of the names of the question. Now see, you have got a hollow sphere over here. Okay. Listen carefully. Hollow sphere means football, which is hollow from inside. Solid sphere means cricket ball, which is filled from inside. Okay. Now, let's suppose you are distributing the charge on this hollow sphere by any means. So, this is the charge distributed on the hollow sphere. And how much? That is Q. So, we say in case of the hollow sphere, charge is stored on its surface. So, in case of hollow sphere, there is no charge inside. It will be stored only on the surface. And radius of this hollow sphere is, we say, R. You have to tell me what is the electric field due to this hollow sphere outside, on the surface, and inside. First of all, outside. Guys, directly you have to remember. Outside of the hollow sphere, electric field is KQ divided by R square, small r. Small r is the distance from the center to that point, this small r. And if you keep on moving towards the surface, when you reach surface, this is the value of small r, because you measure the small r from the center. So small r becomes equal to the capital R. So at surface, small r is capital R. So instead of small r, you need to mention capital R. So electric field on the surface will be KQ by capital R square. Capital R is the radius. So outside is KQ by small r square. On the surface, it is KQ by capital R square. And my dear NEET aspirants, when we talk inside the sphere, can I say inside the sphere there is no charge? Charge inside the sphere is how much? 0. Charge inside the sphere is how much? 0. So if charge inside the sphere is 0, so electric field inside will be how much? That will be 0, my dear NEET aspirants. Electric field inside the sphere will be 0, my dear NEET aspirants. Is this clear? Please tell me in the chats, everybody of you. I would want you guys to tell me in the chats if this is crystalline clear. If this is crystalline clear. Is this clear? Yes. Now, boys and girls, if I say graph between E versus X in case of a sphere, listen carefully. When I say electric field, first of all, inside, Electric field inside, it is 0. Electric field outside, it is kq divided by r square. So electric field outside is inversely proportional to r square. Inside it is 0. Now E versus R, this is the center where small r is 0. From the center to the surface, can I say electric field is 0? So graph will be here, electric field will be 0. And when you move outside of the surface, this is the sphere, outside we can say electric field is inversely proportional to small r square. This graph is very important. Please remember this graph because this has been asked so many times in the JEE examination. Now, let's move on to the solid sphere. When it comes to the solid sphere, my dear NEET aspirants, electric field in case of a solid sphere, electric field in case of a solid sphere, electric field in case of a, due to a, I would say solid sphere. Okay. Electric field in case of a solid sphere. Now, boys and girls, when I say solid sphere, electric field due to a solid sphere, listen carefully. Guys, solid in case of solid sphere, charge is filled inside the sphere. You see, charge is filled inside the sphere. And how much charge? That is Q. The radius of the sphere is, I would say, R. You have to tell me electric field outside the sphere at what distance? Small r. Okay. So at outside point is what? Small r. And on the surface, capital R. Inside also small r. Sir, small r is variable. For outside point, we say small r is greater than capital R. For inside point, we say small r is less than radius capital R. Array, see, this r is less than capital R. So outside it is going to be same, kq by small r square as it was in the hollow sphere. Inside, my dear NEET aspirants, okay, on the surface, we say small r is equal to capital R, kq by capital R square. So on the surface and outside, it will remain the same as hollow sphere. But when it comes to the inside here it is not 0 because charge is present. Inside it is k, q into small r. Small r is the distance from the center to that point inside, divided by capital R cube. Capital R is the radius. Capital R is the radius. Now guys, tell me, outside E is inversely proportional to small r square. Inside E is directly proportional to small r. Now tell me what is going to be the graph. So can I say in this particular case, electric field outside, it is inversely proportional to small r square. Electric field inside, it is going to be directly proportional to small r. Okay, so electric field inside, guys, this is where r is equal to 0. This is at center. At center, electric field is 0. So from center to surface, my dear NEET aspirant, this is the surface where small r is equal to capital R. From center to surface, I can say electric field is directly proportional to small r. That's why straight line. For directly proportional, we make straight line. And when you move outside, electric field is inversely proportional to small r square. This graph is also extremely important. This is the graph of solid sphere in case of, this is the graph between E versus R in case of a solid sphere. Now take a look at this particular question. This is the question of JEE Advanced 2014, but this is not having that level. What this I want to show you over here. It will just take a minute in explaining this question. Now guys, let's take a look. These are the three solid spheres given over here, solid spheres. Charge on this solid sphere is Q and radius is R by 2. Okay. Charge on this sphere is 2Q and radius of this sphere is R. Charge on this sphere is 4Q and radius of this sphere is 2R. You are supposed to tell me find the electric field. I'll just mention over here. Find the electric field at R distance. Find the electric field at R distance. Now tell me, for in all the three cases, tell me, if this sphere has got radius R by 2, you have to find electric field at R, means double of R by 2. Will that be surface or outside? Obviously, sir, outside. Array, R by 2 is the radius. R will be outside. So for this, I can say, let's suppose I do E1. For this, I will be using the formula. Listen to me very carefully. Outside formula. KQ divided by small r square. Outside. Now, because outside KQ by small r square. So electric field E1 will come out to be K. Charge. What is the charge on this sphere? That is Q divided by small r. Small r is the distance from the center to that point. That is the distance. That will be r square. Okay, for this one, E2. Boys, this one is having the radius of r. So if you have to find the electric field at r, that will lie on the surface because this is having the radius r itself. So for this, I'll use the surface formula. KQ by capital R square, where capital R is the radius. This is the surface. Now tell me, boys and girls, what I want you to understand in this particular case, So you can say E2 will come out to be K, charge. What is the charge of this sphere? That is 2Q. Divided by, what is the radius of the sphere? That is R square. Similarly, in this particular case, my dear NEET aspirants, can I say here? We say, guys, radius of this is 2r. If you have to find the electric field at r distance, don't you think that is going to lie inside? Absolutely, sir. So E3, it is going to be, what is the electric field inside the sphere? That is KQ divided by capital R cube into small r. Now, this is out inside. So what I can say, electric field E3 will come out to be, that is K. Charge. What is the charge of this? That is 4Q divided by R. What is the radius of this? That is 2R. Whole cube. Small r. Small r is the distance from the center to that point. That is R. Now solve this, guys. E3 will come out to be 4KQ divided by 2 cube is 8R cube into this R. R and this will cancel, so it will remain R square over here. 4 1s are 4 2s are. Electric field E3 will come out to be KQ upon 2R square. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everybody out there. Come on, boys and girls, tell me quick. Tell me, oh, is this clear? Is this clear? Give me the signal in the chats. Smash the like button. No? Okay. Yes. Okay. Now, guys, take a look in this particular case. Motion of a charged particle in a uniform electric field. Listen carefully. Please listen carefully. This is the electric field over here. Sir, where does this electric field come from? Maybe there is a big charge placed over here. Because of that big charge, it has placed a strong electric field. This E. Okay. Now in this electric field, you are placing another charge which is having the charge Q and its mass is M. Charge Q and its mass is M. Okay. Now, boys and girls, if I say what is the force acting on this charge? Force acting on this charge is Q times of E. Whenever the charge is placed in the external electric field, okay, what is the force acting on the charge? That is Q times of E. If the charge is positive, force will be in the same direction as electric field. If the charge is negative, force will be in the opposite direction of electric field. Okay. And how much is going to be the force in this particular case, boys and girls? That is Q times of E. This is the force acting on the charge. Now, if I say there force is acting on the charge, it will have acceleration, F is equal to ma. Acceleration of the charge will be QE by m. Q is the charge, E is the electric field, m is the mass of the charge. This is the acceleration. Displacement in time t. Now, guys, okay, velocity after time t. Let's suppose, boys and girls, this charge moves. Array, you are applying force on this charge, not you. Electric field is applying force on this charge. Don't you think that because of that force it is going to move? Obviously, sir. It will gain some velocity. What is the velocity of this charge after time t? So this is the velocity of the charge after time t. Okay. And if somebody asks you, what is the graph between velocity versus t? Guys, t, q e t divided by m. Q is charge, is electric field, m is mass, t is time t. What is the graph between v versus t? Sir, v is directly proportional to t. In this particular case, graph is going to be the straight line. Now, if I say, since the charge is moving, it gains velocity, it will cover certain displacement. What is the displacement of the charge after time t? So displacement in time t, that is 1 by 2 q e by m into t square. So if somebody asks you what is the relation between s and t square, you can say this one. So whenever this is s and t, if the power is present on this t square, it is y is proportional to x square. So then it is going to be upward parabola. If it is directly proportional like this, linearly proportional, then it will be the straight line. Okay. Momentum after time t. Guys, we say whenever there is mass, it has velocity. It will have momentum. Momentum is mass into velocity. Now, since this charge, my dear NEET aspirants, it has mass, it has velocity. So we say it has momentum. Momentum of the charge after time t. That is q e into t. Q is the charge, e is electric field, t is time. So we can say momentum is directly proportional to time. If somebody asks you what is the graph between momentum and time, so it is going to be straight line. So this is momentum versus time. And then kinetic energy after time t. Guys, since this charge is in motion, it has kinetic energy. Kinetic energy after time t. Okay, this is kinetic energy after time t. After time t, what is the kinetic energy? You'll say, sir, that is q square e square t square divided by 2m. So what is the relation between kinetic energy and time? It is direct relation, but it is square. If somebody asks you what is going to be the graph between kinetic energy and time, it will be upward parabola again. Yes. Now, velocity after displacement x. This is velocity after displacement, right? S, displacement S. Like, guys. If the charge started from this point, it has covered displacement S. I'm saying after displacement S, what is the velocity? Sir, what was this? This is the velocity after time t. After time t, let's suppose after 10 seconds, what is the velocity of the charge? That is one question. After 10 meters, what is the velocity of the charge? That is different. So it is v square is equal to QES by m. So you can say from here, v will be under root of 2QE into S divided by, I would say, m. If I say what is the relation between v and S, v is directly proportional to root S. Now, if I say, you can write it like this also, v square is proportional to S. Now, if I say what is going to be the graph, guys, listen to me very carefully. If it is k is proportional to t square, if square is present on this, then it will be upward parabola. If square is present on this is v and s, then it is going to be downward parabola. This was asked in JEE 2026. Literally, this was asked in JEE 2026 recently. That's why I'm making the graphs. What is the relation between, what is the graph between v versus s in case of a charged particle in electric field? This is the graph. Literally, this was asked. Is this clear? Give me the signal in the chats. Is this clear? Come on, no. Tell me. Smash the like button if you're not like the session yet. Come on, do it quick. Do it quick. Like button if you're not like this. Okay. Now, guys, find the time of fall of electron in comparison to the time of fall of proton in a gravity-free space. Listen to me very carefully. Listen to me very carefully. See, you have got an electron over here. Okay. You have got an electron over here. And my dear NEET aspirants, you have got a proton over here. Okay. And this electron is released from certain height. Mass of electron is, I would say, ME. Time of this electron is TE. And this is the electric field, and this is the height H. Height of the electric field is H. And direction is upward. Now, since electron has got negative charge, force on this electron will be in the downward direction. It's a gravity-free space. Mg is not acting over here. Yeah, I'll give you the break. Wait, na. You have to finish 12 chapters. What are you guys asking? Now, see, if you release this electron, because of this electric field, it will pull it down. Why? Because force on the negative charge is always opposite to the direction of electric field. If electric field is upward, force on the negative charge will be downward. Cool? So it falls down. It will take time TE. Cool? Now you have proton. Proton has got positive charge. So here direction of electric field is downward. In case of positive charge, we say force on this electron will be acting in the same direction of electric field. Same direction. This is also height H. Now, my dear NEET aspirants, this force will attract this proton, not electron. Sorry, this proton. So force on this proton will be downward. So it will fall down. It will take time of fall of proton. You have to compare which is going to take more time, which one is going to take less time. Now see. Guys, use this equation. S is equal to ut plus 1 by 2 at square. Okay. Initial velocity is 0 because initially it was at rest. So S is equal to 1 divided by 2 acceleration, or directly, my dear NEET aspirants, you can use this particular equation. Which one? Displacement. This one. What is the displacement of the charge? 1 by 2 QE by M into T square. You can directly use this particular equation. We can say as displacement, since it is falling down, that is also falling down. S is equal to 1 divided by 2 QE divided by M into T square. Now, boys and girls, listen to me very carefully. In this particular case, how much this charge is coming down? That is H. Displacement is H. In both the cases, H. 1 by 2 is common in both the cases. Electric field, how much is the electric field? E. Here also it is E. Direction is opposite, but magnitude wise it is same. Okay. Charge on this electron, guys, see. Charge on the electron is 1.6 into 10 raised power minus 19 Coulomb, negative. On this, it has got similar charge, but positive. So magnitude is also same. So what I can say, this displacement, this charge, okay, charge, this electric field, it is same. So if it is same in both the cases, so we have to eliminate those things which are constant, which are same. So remove these. So we can say T square will be only dependent upon mass. Take this mass over here. So we can say T is proportional to root of M. So the one which has got large mass will be taking more time in falling. Now we know that mass of proton is much greater than mass of electron. So time of fall of proton is much greater than time of fall of electron. So electron is going to take less time in falling. Don't say, sir, proton is heavy, it will take less time in falling. It's a gravity-free space. So time of fall of proton is greater than time of fall of electron. Guys, is this clear? Please tell me in the chats, everybody out there. Come on. Come on. Tell me. Is this clear? Give me the signal in the chats. Now take a look. You have got electric dipole. Electric dipole. You have got electric dipole. Listen carefully. Is this clear? When it comes to the electric dipole, it means when a positive charge and negative charge is placed, when equal and opposite charges are placed at certain distance, this is what we call the electric dipole. And this is called electric dipole. When equal and opposite charges are placed at certain distance, this is what we call the electric dipole. And if I ask you, this electric dipole has got the dipole moment, I would say P. P is the dipole moment. And if somebody asks you, what is the value of this dipole moment? Dipole moment means magnitude of charge. If it is Q, so magnitude will be Q. And separation between the charge, it is D. This is the dipole moment. And the direction of dipole moment is always from negative to positive. Okay. So what is electric dipole? When two equivalent opposite charges are placed at certain distance, that is what we call the electric dipole. Sir, can we consider this minus 2q and plus 2q as a dipole? Absolutely, two equivalent opposite charges. So what is the dipole moment here? Magnitude of charge, that will be 2q, and separation between the charge is D. This will be the dipole. Now see, electric field at an angle theta from the ideal dipole. Listen to me very carefully. This is the dipole over here. This is the negative charge. This is the positive charge. This is the dipole moment. Now, my dear NEET aspirants, does this dipole have charge in it? Obviously, sir, negative, positive. So whenever there is charge, we say there is electric field. So if this has negative and positive charge, it is going to create the electric field. First, you have to find the electric field at this point. This is called arbitrary point. Arbitrary point. Arbitrary point means general point, any point. And this point is at a distance of x from the dipole. At what angle? At an angle theta with respect to the dipole moment. So at this point, if somebody asks you, what is going to be the dipole moment? Listen, K, P means the dipole, sorry, electric field at this point. K, P means the dipole moment, x cube. X is the distance from the center to this particular point. Then under root of 3 cos square of theta plus 1. Theta is the angle between dipole moment and this x. Under root of 3 cos square theta plus 1. Now, boys and girls, if let's suppose you move to this particular point, this is what we call axial point. Listen carefully. So, axial point is that point which lies on the same line upon which dipole is present. If I draw a line over here, this dipole is present on this line. So axial point is that point upon which this dipole is present. Same line. That's what we call the axial point. Now, my dear NEET aspirants, if you decrease the value of theta at axial point, what will be the value of theta? 0. Array, if you keep on decreasing at axial point, theta is 0. If you put theta is equal to 0, put it 0 over here, electric field will come out to be Kp divided by x cube under root of 3 cos square of 0. Cos 0 is 1. So it will be 3 plus 1. This will be 4. Root 4 is 2. Electric field will be 2 Kp divided by x cube. Now. If you move to this particular point, this is called equatorial point. At equatorial point, listen to me very carefully. We say at equatorial point, what is the value of theta? Theta is equal to 90 degrees. Theta is this much angle. At equatorial point, it is 90. So put the value of 90 over here. So cos 90 is 0. So this will become 0. It will become root 1. So electric field will come out to be Kp divided by x cube, then root of 1. Because this term will become 0. So 0 plus 1 is 1. So root 1 is 1. So electric field will be Kp divided by x cube. One thing I would want you to remember. When it comes to the axial point, direction of electric field at axial point will be in the same direction of dipole moment. At axial point, electric field is in the same direction as the direction of dipole moment. At equatorial point, direction of electric field will be opposite to the direction of dipole moment. That's why we call it minus Kp by x cube. I hope this is crystalline clear. Guys, give me the signal in the chats if this is crystalline clear. Come on, quick. Give me the signal in the chats. Find the electric field at A, B, and C. This is A, B, and this is C. Come on, guys, tell me. Is this clear? Give me the signal in the chats. Give me the signal in the chats if this is clear. Smash the like button if you're not like the session yet. Come on, do it. Now, guys, see. Let's suppose if we have to find the electric field at this point B, you have to find electric field at point A at C. Sir, this is the dipole placed over here. Sir, my logic says that A point is the arbitrary point, B point is the actual point, and this is the equatorial point. This because this is making the angle of 90. So let's first talk about at point A. At point A. If you have to find the electric field at point A, so what I can say, I'll use the general formula, that is Kp divided by x cube, then under root of 3 cos square of theta plus 1. So electric field will come out to be Kp divided by x cube. X cube means distance from this point to this point. If this is L, how much will be this? This is root 2L. So that will be a root 2L whole cube. Okay. And this would be under root of 3 cos square of 45 plus, I would say 1. Cos 45 is 1 by root 2. Now solve this, guys, from your end. It will, I guess, come out to be root 5 by 4 Kp divided by L cube. This must be the answer over here at A point. Let's talk about at point B. At point B. When it comes to the point B, my dear NEET aspirants, this is the actual point. So at actual point, electric field is Kp divided by x cube, 2 Kp by x cube. So you can say this will be 2 Kp divided by x cube. X is the distance from here to here. That is L cube. And if I say at point C, so when it comes to the electric field, you can say, sir, that is Kp by x cube. Are equatorial point na? Kp by x cube. And x is the distance from this point to that is L also. So this is going to be Kp divided by L cube. I believe this is crystalline clear. Okay, this is the question that we have over here. Let's take a look at this question. Find the electric field at point A. This is the point A in the given figure. You have two dipoles. Listen carefully. Guys, you have to tell me electric field at point A due to this dipole and due to this dipole. Listen. Sir, my logic says that for this dipole, this point is the actual point. Why? Because this point lies on the same line upon which this dipole is placed. And with respect to this dipole, first one, this point is the equatorial point because this angle is 90 over here. You have to check the angle when it is, which it is making. So can I say, boys and girls, in this particular case, because of this dipole, electric field at this point will be in the same direction. Because I have told you, electric field due to a dipole at actual point will be in the same direction. And how much? 2 Kp by x cube. And at equatorial point, it will be in the opposite direction. How much? Kp by x cube. So due to this dipole, at this point, electric field is, that is 2 Kp divided by distance from here to here, that is r cube. Yes. Now, because of this dipole, my dear NEET aspirants, if the direction of dipole moment is upward, at this point, direction of electric field will be downward. Because at equatorial point, direction of electric field is opposite to the direction of dipole moment. And how much? This electric field will be 2, not 2, Kp by x cube, K, but instead of P, I'll be using 8P because it has 8P, divided by x cube. X means distance between this and this, that is r plus r, that is 2r, 2r whole cube. Here I am using the actual formula. Here I am using the equatorial formula. Nothing else. Now tell me, guys, this one, electric field, this electric field, let's suppose this is E1, this is E2. How much will be this? This is 8 Kp divided by 2 cube. 2 cube is 8r cube. 8 and 8 will cancel. So this is Kp divided by r cube. So One vector is 2 kp by r cube, another vector is kp by r cube, and this angle is over here 90. Now tell me, I have told you that if you have two vectors at an angle of 90 degrees, what is going to be the net electric field? Guys, under root of. If this was similar to this, if this is x, resultant will be root 2x. If this is y, resultant will be root 2y. But this is kp by r cube, and this is 2 kp by r cube. These are not similar. In this case, it will be under root of E1 square plus E2 square. The under root of E1 square plus E2 square plus 2 times of E1, E2 cos 90. That cos 90 term will become 0. Already I have shown you, na? Now tell me, what is going to be the net electric field over here? Under root of E1. E1 is 2 kp divided by r cube, its whole square, plus E2 square. That is kp divided by r cube whole square. Now, can I write 2 square is how much? 4. 4 kp divided by r cube whole square. I'm doing square of this 2 only. Plus kp divided by r cube whole square. Now tell me, this is 4 times kp by r cube whole square. This is 1 times. 4 plus 1 is 5. This is 5 kp divided by r cube whole square. Now square and root will cancel. But for 5, root will remain. For this term only, square and root will cancel. So it will be root 5 kp divided by r cube. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Come on, guys. Give me the signal in the chats if this is clear. Come on, quick. Quick. Is this clear? Smash the like button if you are not like the session yet. Come on. Electrostatic potential. Electrostatic potential. Tantre Shahid, tomorrow on Unacademy J&K will be having the class. Okay, it is already scheduled on the channel. You can check it. Electrostatic potential energy. Now, boys and girls, what I want you to understand over here, listen, I'll make you understand this. Let's suppose you have electrostatic potential energy. Listen carefully. Let's suppose you have a charge over here that is Q1. Okay, there's a charge over here that is Q1. And there is one more charge over here that is Q2, which is at infinity. If I say, my dear NEET aspirants, you bring this charge from infinity close to this charge. That is Q2. Who is going to bring it? Who is going to bring it? Sir, me. Who am I? I am the external agent. So external agent has to bring this charge from infinity to r distance. And at infinity, we assume it has got no energy, potential energy or energy is 0. When you bring the charge from infinity to r distance, you did the work done. Now, because of that work done, we say its potential energy got stored. Here it is potential energy UR. Listen, sir, you applied the force, you are using your own energy to bring the charge till over here. So your work, which you actually did, will not be wasted. That will be stored in the form of potential energy. So due to this external work done, we say potential energy will change over here. What was the potential energy here? U in 0. What is the potential energy over here? UR. How does the work done, how does the potential energy change over here? Because of the work done. So we say work done is equal change in potential energy. So this you can also write it like this. Work done is equal to U final minus U initial, change in potential energy. And if somebody says, since you did the work done by bringing the charge at r distance, how much will be the potential energy at r distance that is stored because of this work done? You say K Q1 Q2 divided by r. If somebody asks you from now onwards, what is the potential energy between the two charges at r distance, K Q1 Q2 by r? How does this potential energy store in this charge? You say because of the work done when you did the work by bringing the charge to r distance. So this is work done by external agent. If somebody says work done by electrostatic force or conservative force, it is negative of change in potential energy. You directly remember this particular equation over here. Okay, so work done by external agent is change in potential energy. Work done by conservative force is negative of change in potential energy. Now, potential energy between the two charges, sir, at r distance, K Q1 Q2 by r. How does this potential energy come? When there was a charge at infinity, you bring that charge to r distance. So because of that, work is stored in the form of potential energy. Simply, guys, between the two charges, how much is the potential energy? K Q1 Q2 by r. Directly remember. And due to the work done, potential energy is changed. That's it. This is what you guys are supposed to remember. Now take a look at this particular question over here. We say 6 charges plus Q minus Q plus Q minus Q plus Q minus Q are fixed at the corners of a hexagon of side D. These are fixed at the corners. The work done in bringing a charge to the center of the hexagon from infinity. Guys, see. There is a charge which is at infinity, and that is over here Q naught. If I say you have to bring this charge from infinity to the center, the work done in bringing the charge Q naught to the center of the hexagon from infinity. How much work you need to do? Work done by the external agent in bringing the charge Q naught to the center. What did I tell you? Have to find the work done. You say work done is equal to change in potential energy. Direct. So if they ask you to find the work done only, it means work done by external agent. If they say find the work done by electric force, conservative force, then minus negative of change in potential energy. So this will be final potential energy minus initial potential energy. Now, boys and girls, tell me one thing. Initially it was here. What is initial potential energy? 0. Because initial potential energy is potential energy at infinity, that will be 0. Finally, it is at this particular point, my dear NEET aspirants. Listen to me very carefully. Listen to me very carefully. Listen to me very carefully. I need to tell you something. Just a second. Let's suppose you have got a triangle over here. There is a charge Q, there is a charge Q, there is a charge Q. If somebody asks you what is the potential energy in this triangle side is A, you'll say, sir, potential energy between the two charges is K Q1 Q2 by R. So between these two charges, potential energy is K Q1, Q into Q becomes Q square divided by side is A, because this is A, this is A. Between these two charges, potential energy is K Q square divided by A. Between these two charges, potential energy is K Q square divided by A. So it is 3 times of K Q square divided by A. This is how we find the potential energy of this system. So whenever you see the pair of charges, you can define potential energy K Q square by A. Now, boys and girls. So this is the initial potential energy. Finally, charges here. Now you have to write the final potential energy. Listen carefully. Could you please tell me in this particular case, guys, finally charges here. Finally, potential energy will be between this and this, 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 this and this. And at this side, this is D. If this side is D, this is also D. This is D, this is D. Tell me, what is the potential energy between this and this? So you will be saying, sir, K, Q1, Q2. So Q1 is Q naught, Q2 is minus Q. I'll write that minus over here. Okay, that is Q divided by. How much is the distance, bro? That is D. Now, what is the potential energy between these two? Sir, I think it will come out to be same. Array, yes, K, Q, Q naught by D. Between these two, this -1. Sir, it will come out to be same. So we say it is 3 times. Then plus. Could you please tell me what is the potential energy between this and this, positive and this? Sir, it is K Q naught Q divided by D. Sir, between these two positives, same K Q naught Q by D. Sir, between these positives, K Q naught by D, so this is also 3 times. Arey, sir, it is easy. So can I say this and this will cancel? So final potential energy is also how much? 0. So can I write in this particular case, work done is final minus initial, that comes out to be 0. So this is how do we find the work done in this particular case. Is this clear? Oh, tell me in the chats. This question was very important. Is this clear? Okay. Now take a look, boys and girls, in this particular case over here. We'll take the break exactly at 1 o'clock. At 1 p.m. we are going to take the break. Now see. Electric potential. Electric potential is simply, guys, listen. Let's suppose you have got a charge over here, Q. Okay. And there is one more charge over here. This is Q, but its value is 1 Coulomb. We know potential energy at infinity is 0. So it is at infinity. Now, if I say you bring this charge from infinity to R distance. Okay. So you place it over here. Now, when you brought this charge from infinity to R distance, we say you did work done. That work done will be stored in the form of potential energy. And that potential energy is K, Q divided by R. Yes or no? Yes. Now, what is the value of this Q? Q is actually 1. So you can say U is equal to K, Q divided by R. Because value of Q is 1. This potential energy in bringing 1 Coulomb charge from infinity to R distance, this is what we call potential. So what is potential? Sir, potential is potential energy only. Yes. But in bringing how much charge? In bringing which charge? 1 Coulomb charge. When you bring 1 Coulomb charge from infinity to R distance, the work you did is stored in the form of potential energy. That is this potential energy. Now this potential energy, when you put Q is equal to 1, so it will be KQ by R. So this potential energy, I'll write this potential energy of 1 Coulomb charge is called potential. Even we write it like this also, boys and girls. This potential is basically potential energy per unit charge. Now potential energy is how much? K, Q, small q divided by R. Divided by charge is Q. This and this will cancel. So it is simply, that is KQ divided by R. I can say it something like this. Absolutely, sir. So simply, when you define electric potential, you define electric potential something like this. KQ by R. That's it. So what is the actual logic? Actual logic, it is a potential energy in bringing 1 Coulomb charge from infinity to R distance. So simply, potential is nothing but potential of a charge is KQ by R. Potential energy between the charges, KQ1, Q2 by R. Now, if I say, what is the potential, net potential at the origin? You have to tell me what is the net potential at the origin. Listen. When it comes to the net potential at the origin, guys, see, you will simply say potential due to this. Sir, KQ divided by, what is the potential due to a charge? KQ by R. So R is what? 1. KQ by 1 plus. What is the potential due to this charge? KQ by R. R is how much? 2 plus. What is the potential due to this charge? KQ by R. R is how much? 4. If from here to here it is 4 plus KQ by next charge, that is 8, and so on. Now in this particular case, you can take KQ common. So what remains over here? 1 plus 1 by 2 plus 1 by 4 plus 1 by 8, and so on. This is what we call GP series. So basically you have to add all of these and you'll get the net potential. Now, this is up to infinity, my dear NEET aspirants. How do you add all of these? There is a formula to add. Formula is sum is equal to A upon 1 minus R. So you can say sum is equal to A means first term. What is the first term over here? 1 upon 1 minus R. R is common ratio. Let me show you how do we find common ratio. Take any term, R is, take any term, let's suppose 1 by 4, divide it with the term which comes before it, that is 1 by 2. Take any term, divide it with the previous term, 1 by 2. 2 ones are 2, 2s are 4, R is 1 by 2. This is common ratio. So 1 divided by 2. So 1 upon 2 into 1 is 2. This will become 1 by 2. So this will go in numerator, it will become 2. So sum of all of this came out to be 2. So you can say net potential in this particular case, KQ. Instead of all of this, it came out to be 2. Even you can say, what is the value of K? 1 by 4 pi epsilon naught, and it is 2Q. 2 ones are 2, 2s are. So it came out to be Q upon 2 pi epsilon. Is this clear, boys and girls? Is this clear? Tell me, is this clear? Is this clear? Is this clear, or give me the signal in the chats, everybody out there? Come on, tell me, tell me, tell me. This is a question from JE 2026. Take a look. 5 positive charges, each is having the charge Q, are placed at the vertices of a pentagon. There is a pentagon. Pentagon means which has got 5 sides. This is the pentagon, you can say. And in this particular case, it says it has got 5 charges at the vertices. Okay. Okay. The potential at the vertices of the pentagon. The potential and the electric field at the center of the pentagon. Guys, see. If identical charges are present at any figure, listen carefully. If this is a square, this is a triangle, this is a hexagon. If identical charges are present at every corner, similar charges, then net electric field at the center will be 0. The net electric field at the center will be 0. So in this particular case, we say net electric field is 0. What is the logic? If identical charges are present at the corners. And let's suppose this distance is R. We say when it comes to the net potential in this particular case, you can simply say potential due to this, potential due to this, potential due to this, potential due to this, potential due to this. Is this clear, boys and girls? This is the question of JEE Mains 2026. Is this clear? Is this clear? So what is the potential due to this? KQ by R. Due to this, KQ by this distance R, KQ by R, KQ by R. So simple logic over here. Net electric field is 0 and net potential will be the potential of all of these. Add those. It's simple, bro. Okay. Okay. Yes. Let's move on to this one. Okay, one more important thing. That is a relation between electric field and potential. V means potential. Guys, please directly remember this particular relation over here. From this relation, you can expect a question. E is equal to minus dV by dr. Please directly remember this particular question. What is E? E is the electric field, V is potential. In JEE 2026, I'll tell you what was the question asked. 26 or 2025? Potential at a point was given. V is equal to 6x square. Find the electric field at x is equal to 4 meters. Something like this question was given. So potential at a point is given. You are supposed to find electric field. This is the relation. What will you say? Sir, E is equal to minus dV divided by dr. Instead of dr, it is given in terms of x. So you will be mentioning over here dx. Array, one and the same thing. Depends. X is distance, r is distance. So minus d divided by dV by dr. dV by dr means differentiation of potential with respect to x. Now, what is the differentiation of this? 6 2s are 12x. So electric field came out to be minus 12x. You have to tell me the electric field at x is equal to 4. At x is equal to 4. Put here. So E will come out to be minus 12 into, I would say, 4. So it will be minus 36 Newton per Coulomb. This was the electric field. 48. Sorry. Yes or no? So this is the relation which you need to remember in this particular case. Relation between electric field and potential. Yes. Okay, now take a look. Potential due to a hollow sphere. Potential due to a hollow and solid sphere. First of all, let's talk about potential due to a hollow sphere. Potential due to a hollow sphere. Hollow, or we also call it what? Hollow slash conducting slash metal sphere. Guys, I recently told you in case of a hollow sphere, we say charge is stored on the surface. Let's suppose this is a potential charge. This is a sphere. Charge is present on the surface, and how much charge? Q. Radius is r. You have to tell me potential outside, on the surface, and inside at r distance. When it comes to the potential outside, it will be this kq by small r. Whatever is the potential due to a point charge, that will be due to this outside. Q is the charge, small r is the distance from the center to that point. On the surface, we say value of small r is capital R. So on the surface, potential is going to be kq by capital R. And when it comes to inside, right now inside potential is not zero. It will be same as potential on the surface. Same as potential on the surface. So we say here, whatever is the potential on surface, that is going to be inside. And that is kq divided by capital R. Capital R is the radius. Okay. Now, if somebody asks you what is the graph, guys, see V versus R. When it comes to the inside from center to surface, listen to me very carefully. Inside to surface, center to surface, guys, K is constant, Q is constant, charge on this is constant, radius of this sphere is constant, so this entire potential is constant. If potential inside is constant from center to surface, center is where R is equal to 0, from center to surface, we say it is going to be constant. Inside, we say potential is constant. And boys and girls, when you move outside, we say V is inversely proportional to R. This is going to be the potential outside. V is inversely proportional to R. Okay, so this is constant inside. This is potential, graph between V versus R. This is not the graph between E versus R. No. This is graph between, that was graph between E versus R. Graph between V versus R. Potential versus R. Now, potential due to a solid sphere. Solid sphere also means non-conducting. Non-conducting. Now see, in case of a solid sphere, I have already told you, my dear NEET aspirants, that charge is present inside. So here, when it comes to the potential outside, it will be, no, this is on the surface, potential outside. kq by small r, same. On the surface, kq by capital R, same. And when it comes to inside at r distance, this is the potential inside. This is the potential inside. Now see, how do you remember this? kq upon 2r cube. Guys, sir, how do we remember it is 2 and then it is 3? which comes first? 2 or 3? 2. So we'll be first writing 2. Then 3, 2r cube. Then, my dear NEET aspirants, interchange the position. Take this 3 down, take this 2 up. So it will be 3r square. KQ upon 2r cube. How do you know it is 2 first? Because when you compare 2 and 3, 2 comes first. So 2r cube. Then interchange the position of 2 and 3. So it becomes 3r square minus small r square. Small r is the distance at this. And if somebody says, what is the potential exactly at r distance? So potential exactly at r distance. This at center. This is at center. At center. What is the value of r at center? That will be 0. So in case of solid sphere, outside potential is kq by small r. On the surface, kq by capital R. Inside, at any point, this one, exactly at center, that is 3 by 2 kq by r. Now guys, 3 by 2 means 1.5 kq by r. This is potential at center. And when you see this is potential at surface, kq by r, this is 1 times of kq by r. This is 1.5 times of kq by r. Which one is more? Which one is bigger? So obviously potential at center is greater than potential at surface. Why? Because 1.5 is greater than 1. So when you make the graph, my dear NEET aspirants, so this is here, value of, this is, in this particular case, here, I would say r is equal to 0. That means center. At center, potential is maximum 3 by 2 kq by r. This is V naught. Then graph decreases. So this is the potential at surface. At surface, value of small r is capital R. And at surface, this is the potential. That is potential at surface, kq by small r. kq by capital R. So this is inside. Guys, large potential you have on the surface. It decreases, then it goes to the surface. So large potential is at the center, then on surface, then outside. What is the potential outside? kq divided by small r. V is inversely proportional to small r. So graph will be rectangular hyperbola. Very, very important graph. This graph between potential versus r in case of a solid sphere. In case of a solid sphere. In case of a solid sphere. Now, this is the question here. Question is, find the potential. Find the potential at P and Q. P and Q. Find the potential at P and Q. Guys, tell me, is this clear till over here? Come on, give me the signal in the chats. Is this clear till over here? Is this clear till over here? Come on, quick. Is this clear? Is this clear? See, you have to tell me potential at this point and you have to tell me potential at this point. These are the concentric shells, hollow spheres. Hollow spheres. So if these are the hollow spheres, my dear NEET aspirants, listen carefully. We say these are concentric shells, means one hollow sphere. Inside of this hollow sphere, you have got one more. And exactly at the center, I would say value of R is 0. Exactly at the center, value of R is 0. Yes. Now, my dear NEET aspirants, when we talk about the point Q, at point Q is the outside of both the spheres. What is the potential outside? KQ by small r. What is the potential on the surface? KQ by capital R. What is the potential inside of the hollow sphere? That is also KQ by capital R. Now, when we talk about outside, guys, we say potential at Q. Now, due to this bigger sphere, potential outside will be KQ by small r. K. What is the charge on this? That is 3Q divided by. What is the distance from the center to that point? Small r is the distance from the center to that point. That will be 2r plus. Due to this point is also outside. So K, charge on this is Q. because charge on this is q, divided by distance from here to here, its center. Both have got the same centers. That will be 2r. Now, guys, this is 3 times of kq by 2r. This is 1 times of kq by 2r. 3 plus 1 is 4. 4kq divided by 2r. 2 ones are 2 twos are. So this is 2kq divided by r at point P. If you have to find the potential at point P at this, so I can say point P is the inside of this sphere, bigger sphere, and outside of smaller sphere. Now, if I say inside the sphere, how much is the potential? Kq by r. R is the radius. So, what is the potential of this sphere inside? K charges on this divided by radius of this. Will be saying, sir, potential at point P. K charge of this is 3q divided by r. R is the radius. What is the radius of this? That is b. Plus potential at point P due to this sphere. For this sphere, this is outside. Outside is kq by small r. K charge on this is q divided by small r. Small r is the distance from this point to this point. That is r. Now here you can take common. What? kq you can take common. 3 divided by b plus 1. kq by r. No, not r. 3 divided by b upon 1 divided by r. This comes out to be the answer. Is this question clear? Tell me, is this question clear? Is this question clear? Is this question clear? Come on, tell me. Is this question clear? Arey, it is simple, bro. See, point Q is outside of both the spheres. Okay? And when we talk about point P is, listen, point P is, this is the point P. This point P lies inside of this bigger sphere, outside of the smaller sphere. Okay? Inside of this, outside of this. So for this bigger sphere, we will be using the inside formula. Inside formula is kq by small r, kq by capital R. K, charge on this is 3q. R, radius r. What is the radius of this? That is b. That's why I'm mentioning b. Plus, for this sphere, this point is outside. So we'll use outside formula, kq by small r. So that is k, charge is q, small r. Small r is the distance from the center to that point. That is r. That's why. Okay. Electric potential due to a ring. This is a ring. Okay. This is a ring. This is a ring, my dear NEET aspirants, in this particular case. Okay. This is a ring. This ring has got how much charge on it? This ring has got charge q on it. And its radius is r. You have to tell me what is the potential at x. So you'll be directly saying at x distance, potential is kq upon under root of r square plus x square. This is the potential due to a ring at x distance, kq upon under root of r square plus x square. Yes. Now, my dear NEET aspirants, if I say at center, what is the value of x? Sir, value of x is 0 at center. If at center value of x is 0, put it 0 over here. Potential will come out to be kq upon, this will be 0 under root of r square. This and this will cancel. So potential at the center is kq divided by r. Now, if you take a look at this, k is constant, q is constant, r is constant. R is the radius of the ring. So this is constant. Then comes again two cases very close to the ring. very close to the ring, very far from the ring. This is case 1. Very close to the ring means if this is the ring, its radius is r, just outside of the ring. This is x. So here x is much, much less than r. This is very close to the ring when x is much, much, much less than r. Now, if x is much, much, much less than r, adding a very, very, very small quantity to a very, very, very large quantity, is it going to create any sort of difference? Will it create any sort of difference? No, it will not create any sort of difference. So I can say you can neglect x, you can write potential will be kq divided by root of r square. This and this will cancel. So potential will be kq divided by r. Again, this is constant. So means whatever is the potential at the center of a ring, that is kq by r, same will be just outside the ring. Yes. Then boys and girls, if I say case 2, case 2, very far from the ring. Very far from the ring means if this is the ring, this is radius r, this x. So here x is much, here r is much, much less than x, very far from the ring. Now tell me, my dear NEET aspirants, in this particular case. So if r is much, much less than x, so adding a very small quantity to a very large quantity, will it create any difference? No. So potential will be kq upon under root of x square. Square and root will cancel, so it will be kq divided by x. Now, take a look. Take a look. If I say electric field, guys, let's suppose if I make the graph between this is potential, graph between potential V versus R. Graph between potential versus R in case of a ring. Listen carefully. I can say it would be like this. It would be like this. Listen, guys. V versus R. Let's suppose if I place a ring over here. This is the center. At center, potential is constant. It is not zero. At center, potential is constant. KQ by R. Close to the ring also potential is constant. So what I can say, graph is going to be something like this. Okay, graph is going to be something like this. So this is center at x is equal to 0. So this is close to the ring. Okay, very close. Very close. I would say potential is constant. And when you move very far from the ring, it will be inversely proportional because very far. Okay. It is V versus X. Not small r. X. Sorry. V versus X. So I can say V is inversely proportional to X when you go very far. That's why this graph close to the ring, it is constant. Is this graph clear? Please tell me in the chats. Is this graph clear? Tell me. Is this graph clear? Smash the like button if you're not liked the session yet. Come on, do it quick. Let's take a look. Find the potential difference between A and B. You guys are supposed to tell me what is the potential difference between A and B. What is the potential difference between A and B? This is a ring and this is the ring. Okay. This A is the center of this and B is the center of this. A is the center of this and B is the center of this. Charge on this is Q and charge on this is minus Q. Okay. Yes. You are supposed to tell me what is the potential difference between A and B. Potential difference means VA minus VB. Guys, see. Let's first find the potential at A, at point A. Let's first find the potential at point A. Okay, let's first find the potential at A. Now, boys and girls, when it comes to the point A is the center of this, and with respect to this ring, it is at a very far distance because x, distance between the two, x is much greater than r is the radius. Now tell me, what is the potential at the center, kq by r, what is the potential at very far from the ring, kq by x? Okay, now guys, for this ring, it is the center. So what is the potential at the center, kq by r? So due to this ring, potential will be k, charge is q, radius is r. Okay, k, charge on this ring is q, radius is r. Then my dear NEET aspirants, due to this ring, it will be minus. Why minus? Because charge on this is negative, k, q divided by. At what distance it is? It is x. Are you getting me? Because with respect to this ring, this point is at very far distance. With respect to this ring, it is the center. And if I say at point B, point B is the center of this ring. For this ring, I'll use the center formula, that is VB is equal to KQ divided by, what is the radius of this? That is R. Yes or no? And minus. Why minus? Because charge on this is negative, minus Q. And my dear NEET aspirants, due to this ring, it is at far distance, it will be plus KQ divided by X. Now you have to tell me VA minus VB. So we say VA minus VB. What is the value of VA? That is KQ divided by R minus KQ divided by X. Okay, this is VA minus VB. VB is this. That is KQ divided by R. KQ divided by R. Okay, this is minus. Plus I would say KQ divided by X. KQ divided by R plus KQ divided by X. Now what I can say over here, VA minus VB will come out to be KQ divided by R. Okay. Okay. Minus KQ divided by X. Minus into minus is plus KQ divided by R. Minus into plus is minus KQ divided by X. Now see, KQ by R plus KQ by R, 2 times of KQ by R. So this is 2 times of KQ divided by R. Minus minus is minus 2 times of KQ divided by X. So I can say 2 KQ will come out because this is common. So 1 divided by R minus 1 divided by X. Please tell me how many of you understood this. Give me the signal in the chats. Come on, quick. Tell me. Is this clear? Is this clear? Tell me, oh. Is this clear? Okay. So make sure you are using these brackets over here. Otherwise, it will give you the wrong answer. Now you have chapter 2, that is capacitors. Now you have the chapter 2, that is capacitors. Okay. Yes. You have chapter 2, that is capacitors. Okay. Now let's take a look, my dear NEET aspirants. Let's take a look, my dear NEET aspirants. I'll give you the break at 1 o'clock. Okay, 1. 1 means 1, which comes before 2, which comes after 0. Now take a look. Capacitor. Let's suppose, my dear NEET aspirants, I say, what is this? What is this? Sir, bucket. Why? For what we use this bucket? For what purpose we use this bucket? Sir, to store liquid, to store water. Okay. To store water, we use this bucket. Similarly, you have capacitor. We say this capacitor is a device which is used to store electrical energy, or we say charge. If you want to store charge in a device, you'll be using you'll be using what device? Capacitor. You'll not be using the bucket. So bucket is something which uses, which stores the water, which stores the fluid. And when it comes to the capacitor, it stores electrical energy in the form of charge, or it stores electrical charge. Now, we said this bucket has got the capacity. So its capacity is 10 liters. So means it can store 10 liters of water. It can store 50 liters. That is the capacity. Similarly, my dear NEET aspirants, if I say this is a capacitor over here, this is a capacitor over here. Okay. And this capacitor, on this capacitor, we are storing the charge Q. You can consider this as a sphere. Sphere is also capacitor. How much charge is stored? Q. How much is the radius R? And due to the charge Q, we say potential is developed on the surface. Okay, how much is the potential developed? V. Because on the sphere, hollow sphere you recently studied, if the charge is placed on the surface, we say potential V is developed on the surface. Now, my dear NEET aspirants, in this particular case, we say Q is directly proportional to V. V is equal to KQ divided by R. If large charge is stored, we say more will be the potential. So, if you store Q charge on the surface, V is the potential developed. So, can I say Q is directly proportional to V? Yes. So, replace this proportionality with a constant. We say Q is equal to CV. And what is the C? C is called the where C is constant, and C is the capacitance of the capacitor. Capacitance of the capacitor. Okay. Capacitance means capacity. What is the capacity of the capacitor to store? Ability of the capacitor to store the charge. So direct, and you can say, sir, this capacitance is Q divided by V. C is equal to Q by V. C is equal to Q by V, and Q is equal to C into V. So what is a capacitor? Capacitor is a device which is used to store charge in the form of electrical energy in the form of charge. And we say Q is equal to C into V. Q is the charge on the capacitor. V is the potential of the capacitor. C is the capacitance of the capacitor. Capacity of a capacitor to store charge. Now, capacitance of a spherical capacitor. If you have a spherical capacitor, hollow sphere, how much will be its capacitance? You directly remember it. I'll not derive it. 4 pi epsilon naught R, where R is the radius. This is the exact formula of capacity of a capacitor. Capacitance. Okay? Yes. Now, there is a question over here. Very, very important. Very, very important. Take a look. The question is something like this. You have got these small capacitors. Small capacitors. How many small capacitors? N capacitors. N. Now, these N capacitors are combined to form a big capacitor. These N capacitors, they are joined to form a big capacitor. Okay. And what is the charge of small capacitor? Q. What is the potential of small capacitor? Charge of small capacitor Q. Potential Q, potential V. And capacitance C. And radius of these small capacitors is R, small r. Now, my dear NEET aspirants, when you convert it by melting, whatever the process it is, or in some questions it will be mentioned drops, to form a big capacitor. Now you have to tell me what is the charge of big capacitor, capital Q, capacitance of big capacitor C dash, potential of big capacitor V dash, radius of big capacitor R. So we say Q, R, C dash, V dash. Okay. Now, my dear NEET aspirants, this is the small capacitor, charge Q, potential V, capacitance C, radius R. So charge of this will be N times of Q. N raised power 1 by 3 into R. Capacitance is N raised power 1 by 3 into C. C is the capacitance of small capacitor. R is the radius of small capacitor. V dash potential N raised power 2 by 3 into V. Now let's take a look at the question. This is the question which was asked in NEET 2021. 27 small drops or small capacitors are combined to form a big drop. 27 small drops of same size at 220 volts. So potential of this is given as 220 volts. And what is the value of N? N is 27. Then they calculate the potential of big drop. It says, what is the potential of big drop? Array, sir, it is very simple. What is the potential of big drop? Potential will be N raised power 2 by 3 into V. So V dash will be N. What is the value of N? That is 27 raised power 2 by 3 into V. V, potential of small drop is 220. So N, we can say N is 3 cube. Right, 3 into 3 is 27. Raised power 2 by 3. 3 and 3 will cancel. 220. V is equal to 3 cube is 9. 9 into 220. So potential will be 1980. And even in the same question, if somebody asks you what is the capacitance of the big drop, so N raised power 1 by 3 into C. So N is 27 raised power 1 by 3 into C. So this will be again 3 square. So it will be 9C. Sorry. So this will be 3 cube raised power 1 by 3 into C. This and this. So it will be 3C. Oh, yes or no in the chats? JEE 2026 question. See, what does the question say? See, what does the question say? See, what does the question say? 3 small identical bubbles of water. 1, 2, and 3. Having same charge on each to form a bigger bubble, then the ratio of the potential on the initial bubble to the ratio of that of the resultant bigger bubble. Okay, 3 bubbles are joined to form a bigger bubble. You guys are supposed to find the ratio of the potential of initial to final. Okay, now see, potential of this bubble, what is the value of N? 3. Potential of this bubble is V. Potential of this, let's suppose V1. V1 is equal to V. Potential of this bubble V2 is equal to V dash. Okay. This you need to calculate. And tell me, this V2, that is V dash, it will be N raised power 2 by 3 into V. So we can say this V2 will be equals to N. What is the value of N? 3 raised power 2 by 3 into V. Now it says ratio of this divided by this. So V1 divided by V2. V1 is how much? V1 is how much? That is V upon. V2 is how much? 3 raised power 2 by 3 into V. This and this will cancel. 1 upon 3 raised power 2 by 3. Initial to final. Parallel plate capacitor. Guys, this capacitor which you studied, this is a spherical capacitor. It is not a good capacitor because charge is stored on the surface of this capacitor. So there is a leakage of charge. There is a chance of leakage of charge. Charge can leak. So energy can leak over here. But parallel plate capacitor. What is parallel plate capacitor? You take a plate, you take another plate. You place these 2 plates parallel to each other at certain distance. Let's suppose that is D. Area of the 2 plates is A. This is what becomes the parallel plate capacitor. This is called parallel plate capacitor. And on one of the plates, positive charge is placed, stored. On another, negative charge is stored. So here electric field is set up in between the 2, from positive to negative. So this combination is called a parallel plate capacitor. And in case of parallel plate capacitors, capacitance is between, I would say charge energy is stored between the plates. And if somebody says, what is the capacitance of this capacitor? Each capacitor has capacitance, ability to store the charge. How much amount of charge this capacitor can store, that is the capacitance. Okay, so in this case, capacitance is epsilon naught A divided by D. This is the capacitance of this particular capacitor, epsilon naught A divided by D. A is the area, D is the separation between the plates. Now guys, there was a question which was asked in NEET 2022. The capacitance of a parallel plate capacitor if the area becomes A by 2 and separation becomes 2D. You have got a parallel plate capacitor. Okay. This separation is D, area is A. What will be the capacitance? Epsilon naught A divided by D. Finally, it says if the area becomes A by 2, okay, and separation becomes 2D, what is the new capacitance? C dash is equal to epsilon naught. Instead of area, I can write A by 2. Instead of separation, I can write 2D. So this will be epsilon naught A divided by 4D. Now, what is epsilon naught A by D? That is C. So it becomes C divided by 4. Capacitance will become C by 4. Capacitance will become C by 4. Is this clear, boys and girls? Is this clear? Dielectrics and capacitors. Dielectrics and capacitors. Dielectrics and capacitors. Take a look. This is very, very important. This is very, very important. I would want you guys to focus exactly over here in this particular case. Listen. You have got over here a parallel plate capacitor. Okay. Now you are placing a dielectric in between. Okay. Dielectric is a material. Guys, please listen carefully. Let's suppose this is a parallel plate capacitor. Charge on this plate is positive, charge on this plate is negative. So don't you think that these two plates are having the equal and opposite charge? They are having opposite charge. So they will attract each other. They will apply force on each other. Now, when they attract to each other, there is a chance they will stick to each other. When they stick to each other, we said distance between them will become 0. So if the distance between them becomes 0, it will no longer remain a capacitor, because we define parallel plate capacitor, two plates separated by certain distance. If distance is no longer there, we say it will not remain capacitor. It will not be a capacitor. So to overcome this problem, we place a dielectric material in between, and every dielectric has a dielectric constant like this K. So to overcome this problem, so that this plate should not attract this plate, we use what? We use dielectric. So this is a material. Now what happens in this case, from this positive to negative charge, we say electric field is set up. Now see what happens. So basically, this positive plate attracts, when it comes to the dielectric, it has got positive charge as well as negative charge. So positive charge of the plate will attract the negative charge of the dielectric. Right? Because positive attracts negative. No? And negative plate of the capacitor attracts the positive charge of the dielectric. So afterwards, what happens? Negative charge is occupied on this wall, positive charge is occupied onto this wall. Now, my dear NEET aspirants, what happens afterwards is, we say, this is the charge, what we call QI. This is called induced charge on the walls of dielectric. This induced charge. And if somebody asks you, how much is this induced charge induced on the walls of dielectric? It is QI is equal to Q. Q is basically charge on the plates, 1 minus 1 by K. This is the charge, okay, induced on the walls of dielectric. Charge induced on the walls of dielectric. On the walls of dielectric. Okay, yes. And this one, if somebody says, what is the charge density? How much density is there? How much is the charge on the unit area of the walls of dielectric? This is the charge density on the walls of dielectric. Okay. So this is sigma I is equal to sigma into 1 minus 1 divided by K. This is the induced charge density. How much is the charge on unit area? That is called induced charge density. Guys, can I ask you just one thing? I have got 5 pages. In next 5 pages, we'll be finishing this chapter. Can we take break after that? And next 5 pages, it will take me 10 minutes, 10 to 15 minutes. Is that okay if I take 10 to 15 minutes? Because then after the break, we'll start the new chapter, current electricity. Just 15 minutes. Is that okay for you? Let me know in the chats. Is that okay for you? Just 10 to 15 minutes, we'll finish this chapter. Then after, we'll take a break of 50 minutes. After the 50-minute break, we'll start once again with the new chapter. Yes, that's great. That's great. Amazing, people. Now, series combination of. So, whenever a dielectric is placed in between the plates, we say charge is induced on the walls of dielectric. This is the charge. And this was, by the way, asked in JEE 2021. This is the induced charge density, charge on the unit area. Now, take a look. Series combination of dielectrics. Listen to me very carefully. Wait for this. This is not the series combination. Series combination is the next one. Okay. Now see. Dielectric of width T. Listen carefully. Listen carefully. My dear NEET aspirants, let's suppose you have got a plate over here. Please listen to me very carefully. You have got a plate over here. This is a positive plate, this is a negative plate. Separation between the plates is D. Okay, area is A. Could you please tell me what is the capacitance of this? You say, sir, epsilon naught A by D. Now, let's suppose, my dear NEET aspirants, you are placing the dielectric in between the plates. Dielectric, this is having the dielectric constant K. Whenever we place a dielectric in between the plates, its capacitance changes. Its capacitance after the dielectric becomes C dash, and that capacitance is K times of C. Please do remember this directly. But make sure the width of the dielectric is D. It is placed between the plates. So this becomes C dash is equal to K times of epsilon naught A divided by D. This one. What if I say you have got the plates, separation between the plates is D, but you are placing the dielectric over here that is having the width T, and dielectric constant is K. Sir, is it in the entire width? No, this is in the entire width. This is having the width D. In that case, K times of C. In this particular case, my dear NEET aspirants, if you ask me what is the dielectric, what is the Datta Bani, bro, I'll block you from this channel, okay? If you keep on spamming like this, break, I'll block you right away. So stop spamming. If you are a serious NEET aspirant, then learn. Okay, don't keep on spamming. I told you, I have just 5 to 6 slides. I'll finish these and I'll give you the break of 50 minutes. 50 to 55 minutes, long break. Okay. Take a look. So here in this particular case, we say capacitance is epsilon naught A. A is the area of the plates. Then D minus T upon T by K. D is the width. T is the width of the dielectric, and T divided by K. K is the dielectric constant. This is what you guys are supposed to remember directly. Now, boys and girls, let's suppose if conductor is used as dielectric. If conductor is used as dielectric, listen to me very carefully. This between the plates, this width is D, and the dielectric which you are using in between width T, it is a conductor. For conductor, K is infinity. So my dear NEET aspirants, in this particular case, capacitance will be epsilon naught A upon D minus T plus T divided by infinity. Arey, D minus T plus T by K na? For K, for conductor, we say it is infinity. So anything, this by infinity, this will become 0. So this will become epsilon naught A upon D minus T. This is the capacitance of a capacitor in which dielectric is used as conductor is used as dielectric. Now see, this is called a series combination of dielectrics. Series combination of dielectrics. This is called series combination of dielectrics. Series combination of dielectrics simply means if you have multiple dielectrics placed in between the plates, one dielectric, second, third, fourth, and these are in series. Now, what is the width of this dielectric? Over here, it is D1. What is the width of this dielectric? It is D2. Width of this dielectric D3. Width of this dielectric D4. Dielectric constant K1, K2, K3, K4. If somebody asks you what is the equivalent capacitance after these dielectrics, directly, epsilon naught A, D1 by K1, D2 by K2, D3 by K4, D4 by K4. I hope this is crystal and clear. And if somebody asks you also, K equivalent, guys, whenever you have resistors placed in series, you find equivalent resistance, R1 plus R2 plus R3 and so on. Similarly, if you have dielectrics placed in series and they want you to find the equivalent dielectric constant, this is called equivalent dielectric constant. Equivalent dielectric constant. So when it comes to the equivalent dielectric constant, my dear NEET aspirants, listen to me very carefully. Equivalent dielectric constant will be over here. That will be D upon D1 by K1 plus D2 by K2 plus D3 by K3. Okay, please keep this in your mind directly. Sir, what is this? Bro, this is the capacitance of this capacitor after placing these dielectrics. Sir, what if we remove these dielectrics? There will be only air. Then it is epsilon naught A by D. When you place these dielectrics, then capacitance becomes this. And equivalent dielectric constant of these dielectrics, that will be this. A question which was asked in JEE 2021. Take a look. These are the capacitors. You have to find equivalent. You have to find the capacitance. What? Epsilon naught A by D, D1 by K1, D2 by K2 plus D3 by K3. Now tell me, epsilon naught A upon D1 is D, K1 is K, D divided by K plus 2D by 3K plus 3D by 5K. Now what I can say, C dash is equal to, this is epsilon naught A upon, what can I take common over here? D divided by K. In the first one it is 1 plus 2 divided by 3. 2 divided by 3 plus 3 divided by 5. Okay. Now solve this, guys. It will come out to be epsilon naught A upon, this will be, in this particular case, D divided by K, and this will come out to be 34 divided by 15. And you solve this, it will be 34 by 15. Take this in the numerator, it will be 15 epsilon naught A divided by, and this K also, 34D. Okay, the question which was asked in JEE 2026. Question which was asked in JEE 2026. JEE 2026. Take a look. A parallel plate capacitor of capacitance C. Okay. When there is a vacuum within the plates, okay, there is a parallel plate capacitor. It is having the capacitance C. When there is a vacuum between the parallel plates, means, guys, when there is a vacuum means when there is nothing. In that case, capacitance is C. And this C will be epsilon naught A by D. Guys, when there is nothing between the plates, no dielectric, in that case, capacitance is epsilon naught A by D. A sheet having thickness 1/3. Let's suppose if this is D. You are placing a dielectric in this particular case. 1/3, that is D by 3. Of separation between the plates, and relative permittivity means dielectric constant is K. A dielectric is placed having width D by 3 and dielectric constant K. The new capacitance of the system is, guys, if this is D by 3, this is D, how much will be this? 2D by 3. because 2D plus D is 3D by 3. 3 will cancel, it will be D. Array, if you add this and this, it will be D. And this will be over here air. Array, sir, not air, consider vacuum, air, whatever you say. Yes. So you are placing a dielectric which is having width D by 3 and dielectric constant K. So remaining is air, na? So in this particular case, for air, we say dielectric constant is 1. Sir, can we use in this particular case series formula? 100%. Consider this one dielectric, consider this another dielectric. What will be the capacitance? Epsilon naught A upon D1 by K1 plus D2 by K2. Tell me, epsilon naught A, you will be saying epsilon naught A upon D1 by K1. What is the value of D1? D by 3. D divided by 3 into K. Into K. Array, D1 by K1. Na? What is the width of this one? 2D by 3. Divided by 3 into K. K is 1. K is 1. So I'll be mentioning 1 over here. That will remain the same. Now guys, tell me what I can do over here is, so this will be epsilon naught A upon D divided by 3, we can take common. So it will be 1 divided by K plus 2. Epsilon naught A upon D divided by 3. Now do the cross. This will be 2K plus 1. 2K plus 1 divided by K. Can you take this in the numerator 3K? So 3K epsilon naught A upon D into 2K plus 1. Now epsilon naught A by D, this is C. So this is C dash. So C dash will come out to be 3KC upon 2K plus 1. 3KC upon 2K plus 1. Option D. Option D. Parallel combination of dielectrics. Listen carefully, guys. If let's suppose you have got a plate over here. This is a plate. This is a plate. This is another plate. This is another plate. Okay, this plate is having the positive charge. This is the parallel plate. This plate has got the negative charge. This has got negative charge. And in between the two plates, you are placing the dielectrics in parallel. Something like this, K1, K2, K3. And width of this dielectric has got the width A1. This dielectric has got the width A2. This dielectric has got the width A3. Width. Now, when dielectrics are placed in parallel, in that case, if somebody asks you what is the capacitance, this will be C is equal to C dash is equal to epsilon naught by D, A1, K1, width of this, dielectric of this, A2, K2, A3, K3. Even also, this is the capacitance after placing dielectrics in parallel. Also, equivalent dielectric constant. Equivalent dielectric constant. Equivalent dielectric constant. Guys, see, when it comes to the equivalent dielectric constant, you'll be simply saying, when in parallel combination, you have to find the resultant of these dielectric constants, net of these dielectric constants. Okay, you'll be simply saying, that is, here you'll be placing epsilon naught A by D, epsilon naught by D will be common. That is, I would say, A1 K1 plus A2 K2 plus A3 K3 divided by, I would say, A. Yes, it will be epsilon naught D, K times of epsilon naught D, epsilon naught A divided by D. This and these two will be cancelled. Yes, this will be the equivalent dielectric constant. So this is, what is A? A is the area. And A1 K1 plus A2 K2 plus A3 K3 upon A. Now let's take a look at the question. Okay, this is the question over here. This is the previous year question. You have got the plates over here. This is a positive plate of the capacitor. This one is the negative plate of the capacitor. Okay. Now you have got two dielectrics. This is air over here. This is dielectric constant K, A by 2, A by 2. You have to tell me what is the capacitance. What is the capacitance? Sir, capacitance C dash will be epsilon naught by D, A1 K1 plus A2 K2. Because when dielectrics are placed in parallel, in that case, you use this formula. So C dash will be epsilon naught divided by D, A1 K1. What is the value of A1? That is A divided by 2. And what is the value of K1? It is air. So for this, it will be 1 plus A2 K2. A2 means A by 2. And K2 is K. Now, what can I write over here? C dash is equal to epsilon naught divided by D. From these two, you can take A by 2 common. What remains? 1 plus K. Now, epsilon naught A by D, this is the capacitance of a capacitor without dielectric. So, C dash will be C divided by 2, 1 plus K. 1 plus K. C divided by 2, 1 plus K. This one. Okay. Is this clear? Or tell me in the chats. Is this clear? Tell me in the chats, everybody out there. Is this clear? That's great. Smash the like button if you're not like the session yet. Okay. Smash the like button if you're not like the session yet. Okay. Let's take a break. This is a long break. Get done. Okay. Break till 2:15. Okay. Get done with your lunch because then we'll be having more 3 hours. 3 hours more. Okay. 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 Next chapter after the break. Okay, guys, let's start. Okay. Smash the like button if you're not like the session yet. Let's move on to the current electricity. Okay. Now, guys, see. The very first thing that we need to understand over here is the first thing, that is electric current. Electric current. Okay. Yes. See, guys, when it comes to the electric current, let's suppose this is a conductor. Conductor means this is a wire in which current is flowing. We say this wire carries the huge amount of free electrons. A conductor contains the huge number of free electrons. If these electrons move in a proper direction, in unit direction, we say current is produced. We say current is produced. Okay. So whenever electrons flow in a conductor, we say flow of these electrons, flow of electrons in a proper direction. This is what we call current. This is what we call current. Okay. And everybody knows that basic formula. So current is simply, that is dq by dt. Instantaneous current is dq by dt, and average current is simply delta q by delta t. Okay, how much charge is flown in time t. So whenever electrons flow in a conductor, we say current is produced. Now I need to show you something. What is that? Take a look at this particular example over here. See, that is a relation between drift velocity and current. A relation between drift velocity and current. Let's suppose, my dear NEET aspirants, you have got over here a conductor. This is a conductor over here. And in this conductor, we say these are the electrons which are flowing in the conductor. These are the electrons which are flowing in the conductor. The velocity with which these electrons flow, okay, that is what we call the drift velocity, Vd. So here electrons are being drifted due to the drift velocity. So whenever electrons flow in a conductor, we say it is because of drift velocity. And my dear NEET aspirants, current is being produced. Because whenever electrons flow with drift velocity, we say in that particular case, current is being produced. Now, if somebody says, what is the value of that current? Listen to me very carefully. Value of that current will be NEAVD. And A is the area of cross section, my dear NEET aspirants. So I can say in this particular case, boys and girls, this N is number of free electrons per unit volume. Per unit volume. So what are the number of, how many number of free electrons are present in the unit volume? That is what we call the N. E is the charge on an electron. A is the area of cross section. A is the area of cross section. And Vd is the drift velocity. So my dear NEET aspirants, whenever electrons flow in a conductor with drift velocity, current is being produced. That current is equal to NEAVD. Now see the type of question which I have over here. Listen to me very carefully. Listen to me very carefully. A wire carries a current of 1.6 ampere. There is a wire which carries a current of 1.6 ampere. If number of free electrons per meter are this, okay? So number of free electrons per meter, what does it mean? It means N divided by L. Number of free electrons per meter. This is given as 2 into 10 raised power 24. Calculate the drift velocity. Calculate the drift velocity. You are supposed to find the value of drift velocity in this particular case. Guys, see, you simply say when it comes to the current, I is equal to NEAVD. So this drift velocity Vd will be equals to I upon Ne into A. Now guys, this drift velocity will be, when it comes to this N means number of free electrons per unit volume. That means total number of electrons divided by volume. And how do you find volume in case of a wire, in case of a cylinder? So that will be N divided by volume is area into length. Whatever is the area of cross section multiplied by length, that is going to be the volume, my dear NEET aspirants. Now, if you put it over here, so current will come up, Vd will come out to be, this is N divided by A into L, E into A. This A and A will cancel. So drift velocity comes out to be I upon, I can say Ne into A. I upon Ne into A. So boys and girls, in this particular case, this is the drift velocity. Wait. N divided by L into E. So this is the drift velocity in this particular case. Guys, this is the normal formula. This you will be using when you are given number of free electrons per unit volume. Let's suppose if I say in the same question, number of free electrons per meter cube are given as this much. Then you'll be using this. When per meter cube is given, it means the value of M. When per meter is given, it means value of N divided by L. Value of N divided by L. This N divided by L. Okay. So N divided by L over here is given. It is not per meter cube, it is per meter. I hope you got the difference between the two. So what you can say in this particular case, drift velocity will be equals to, that is current. Current is given as 1.6 upon N divided by L. What is the value of N divided by L? 2 into 10 raised power 24. 2 into 10 raised power 24. Then E. E means charge on an electron. Charge on one electron is 1.6 into 10 raised power minus 19 Coulomb. So my dear NEET aspirants, solve this and get the answer. So if, let's suppose, sir, here question was 2 into 10 raised power 24 per meter cube, then directly put the value of this over here. In that case, cross-section area will be given also. Is this point clear? Please tell me in the chats. Is this point clear? Please tell me in the chats, guys. Is this point clear? Please tell me in the chats. Come on, guys. Tell me. Okay, that's great. Now, take a look. Take a look. Listen carefully. Resistance. Guys, listen to me very carefully. Let's suppose this is a conductor. And in this conductor, we said these are the electrons which are flowing in the conductor. So whenever electrons flow in a conductor, they face different number of collisions with the ions, atoms, molecules. So basically, this is the hindrance created by the this conductor. So in this particular case, this hindrance created to the flow of electrons, this is called a resistance. When electrons flow in a conductor, they face so many number of collisions. So these collisions, this is what we call resistance. And if I say this resistance is equal to R is equal to, I would say rho L divided by A. This is the value of resistance in this particular case. Now guys, one more important thing I just want to tell you in this particular case. Listen, this is also the formula of resistance. That is R is equal to rho L square M divided by M into, I would say, this D. This is the, where D is the density, okay? And this rho is what we call resistivity. So my dear NEET aspirants, when you say resistance of a conductor is rho L by A, L is the length, A is the area of cross section, rho is rho is what we call resistivity. Like resistivity depends upon the material. Resistivity tells you the capability of a material to produce the resistance. Some materials may be having the large resistivity, so it will create. So it will create in this particular case. So it will create in this particular case resistivity accordingly. Okay, it will create the resistance accordingly. Now, boys and girls, what I want you to understand in this particular case, when we say resistance, resistance is rho L square D divided by M. So this rho means resistivity, D means density, L means length, M means mass. So this is the resistance in terms of L and M. Now, boys and girls, we can say if the density and if the density and resistivity are constant, in that particular case, this and this are constant, resistance is proportional to L square divided by M. Very important. I'll show you the questions also. Resistance in terms of mass and area also. So basically, this is the resistance in terms of mass and area. This is the resistance in terms of mass and area. And if I say density and resistivity are constant, then resistance will be proportional to mass divided by area square. This is the relation. Like. Let's take a look at this particular question. Masses of 3 wires are in the ratio of 1:3:5. This is the mass of 3 wires. And the length ratio is 5:3:1. The ratio of the resistance will be. And what is given in this particular question? Wires are made of same material. Now, boys and girls, I have put up this question deliberately over here. I want you to understand. Sir, I think in this particular case, if wires are made of same material, what does that mean? You have 3 wires. So that means resistivity and density is constant, is same. When resistivity and density is constant, my dear NEET aspirants, can I say in that particular case, this and this is constant, resistance will be proportional to L square divided by M. And a resistance will be proportional to M square divided by M divided by A square. Yes. Now in this particular question, what is given? We say mass ratio is given, length ratio is given. So we can say R will be proportional to L square divided by M. I'll be using the first ratio. In this particular question, you have to find the resistance of 3 wires. We said this and this is constant. So we'll be saying R is proportional to L square by M. Now tell me, can I say in this particular case, resistance of first is to resistance of second is to resistance of third? 3 wires you have. This is mass ratio, this is length ratio. Now L square by M. What is the length of first? 5. So it will be 5 square divided by M. What is the mass of first? 1. Is to. What is the length of second? 3. So it will be 3 square. Mass of second, that is 3, is to. What is the length of third? 1 square divided by mass of third. That is going to be 5. Now, what can I say over here? This will be 25 is to 3 square is 9 divided by 3 is to 1 divided by 5. 3 ones are 3, 3s are 9. Now 5 into 25 is 125 is to 5 into 3 is 15 is to, I would say 1. This is going to be the ratio. Please tell me if this is clear. Please tell me if this is clear. Come on. Quick. Let me know in the chats if this is crystalline clear. Everybody. If this is crystalline clear, come on. If this is crystalline clear. Now, find the resistance. Find a resistance. Here in this particular case, you are supposed to find the resistance. In this particular case, you are supposed to find the resistance. See guys, this is the cylinder over here. And this cylinder is, I would say, hollow from the inside. This cylinder is actually hollow from the inside. It is filled from this side. This is the portion through which current flows. Okay, this portion. This portion. Now, boys and girls, what I want you to understand in this particular case, guys, see, radius of this inner one is r and radius of this outer one is this. It is like this. It is like this, boys and girls. Please understand this very carefully. So a radius of this is given as r, radius of this is given as r, and radius of this is given as 3r. So basically this is the hollow portion. So current is flowing from this portion only, this portion. This is the current from which it is flowing. You can understand it like this. So basically it is a cylinder. Current is flowing from this one, from this portion, solid portion. So inside it is hollow. So current inside will be 0. Now tell me, you have to find the resistance in this particular case. Can I say, sir, if this is current inside is 0, can I say there will be no resistance? Array, if current is flowing from this portion only, so only this portion is going to create the resistance now? Yes. Current is flowing through this portion. It is only going to produce the resistance. Now, what will be the value of resistance? Resistance is rho L divided by area A. Now, what is the area which is going to produce the resistance? Listen carefully. Listen carefully. What is the area which is going to produce the resistance? We say area will be, guys, this much of area. This much of area. Please listen to this very carefully. This much of area is going to produce the resistance. This much of area. And how do we find this area? What is the total area, guys? Total radius is 3r. So we say pi into 3r whole square. Area of this plane disk cylinder plane surface, pi r square. So entire radius is 3r. Minus, how much is this radius? This is r. So you can say pi into r square. So total area minus this inner area means we'll be getting this much of area. So total area minus this inner area. So total area minus inner area, you'll be getting this area. So that will be 9 pi r square minus pi r square. So this will be 8 pi r square. So basically this 8 pi r square is the portion of the cylinder which is going to produce the resistance. So if somebody asks you what is going to be the resistance in this particular case, you'll be saying rho, length is L, and area will be 8 pi r square. So make sure you don't write the entire area over here, that is 9 pi r square. No. So we say only that portion of the conductor is going to create the resistance through which current is flowing. So current is flowing through this portion only. I hope this is crystal and clear. Okay, like you have this. This is a cubical resistor or cubical conductor. Inside current is 0 because current cannot flow through the air. Current needs some medium to flow. It flows through the wire, material. Now see, this is the current flowing in this particular case. Okay, this is the current flowing in this particular case. This side is having the length A, this breadth is B, and this height is C. If I say what is going to be the resistance created over here, you say resistance is simply rho L divided by area is A. Rho L divided by area is A. Now, boys and girls, this resistance will be rho L, rho. Now, length. If, tell me, sir, current in this particular case is flowing along the side A. So, if it is flowing along the side A, then A you will be considering as length. It depends upon the flow of current along which side. If it is flowing along side A, you'll be taking side A. Area means area of this. What is the area of this? That means this length into this breadth. So area will be this C into B. I would say C into this B. This is going to be the resistance. Rho A divided by C into B. A in this particular case is the length, and area you guys are supposed to take that side. We say this side because in this particular case current is crossing this side. That's why I'm taking area of this, that is B into C. I hope this is clear. Okay, Let's suppose if I give you this one. Okay, in the same question, if I say current is flowing something like this, what will be the resistance in that case? R is equal to rho. Length in that case will be considering C, and area of this, that will be A into B. A into B. This is what you guys are supposed to do. This is what you guys are supposed to do. I hope this question is also crystalline clear. I hope. So basically, this slide is more important when it comes to the resistance portion. When it comes to the resistance portion. Yes. Yes. Okay. One more important thing. Listen to me very carefully. That is midpoint potential. Guys, see. This is the point. This is the point. Okay. There is a resistor over here. This is the symbol of a resistor. Okay. This is the symbol of the resistor. This one. There is a resistor over here. This is R1, and potential of this point is V1. There is a resistor over here. This is R3. Potential of this point is V3. And there is a resistor over here, R2. Potential of this point is V2. And my dear NEET aspirant, this is the common end of all the three resistors. Common point, midpoint. If somebody says, what is the potential of this midpoint? You'll be simply saying V1 by R1. Potential of this end divided by resistance of this end. V2 by R2. V2 by R2. Then plus V3 by R3 upon 1 by R1, 1 by R2, 1 by R3. This is going to be the midpoint potential. Now, one more important thing. One more important thing. Guys, see, battery. Battery. I want you to understand this very carefully. Let's suppose, my dear NEET aspirants, you have got a battery over here. It is having the potential difference delta V as 20 volts. 20 volt battery is there. And potential of this is A and potential of this is B. Always remember this is what we call positive terminal, higher potential. This is called negative terminal, lower potential. Always remember this point A is connected to higher potential. This point B is connected to lower potential. Always remember, we say this higher potential minus lower potential is actually equals to delta V. Higher potential minus lower potential is equal to delta V. Now, boys and girls, listen. So in this particular case, I'll be telling you the current density also. Wait. In this particular case, we say higher potential minus lower potential is equal to delta V. So VA minus VB will be equals to 20 volts in this case. Let's suppose if I say the question is something like this. This is 20 volts. Potential of this point is 0. What is the potential of this point? What do we say? We say this higher potential minus lower potential, V minus this 0 must be equal to this potential difference 20. So V will be equals to 20 volts. V will be equals to 20 volts. V will be equals to 20 volts. Okay. One more important thing. Guys, if let's suppose you have got this is 20 volts. Potential of this is minus 10 volts. What is the potential of this end? What will you say? Higher minus lower. That is V minus lower potential is, I would say, minus 10 is equal to 20 volts. So take it out, minus into minus is plus. So V plus 10 will be equals to 20. So V 20 minus 10 is 10 volts. So potential of this is 10. I hope this is clear. Now take a look. You have a question over here. You have to tell me this. Find current I. Find current I. I want you to understand this very, very, very carefully. I want you to understand this very, very, very carefully. Whenever you have a circuit of this sort, you do one thing. Assume the potential to be 0 at a point. Assume the potential to be 0 at a point. Let's suppose we are assuming 0 volt at this point. Sir, is it going to create any sort of difference in the circuit? No, it will not create any difference in the circuit. What we are doing is that we are assuming potential at this point as 0. If potential at this point is 0, could you please tell me what is the potential at this point? Guys, we say higher potential minus lower potential, because see, this is positive, this is negative. Higher minus lower must be equal to 20. Potential of this is V, minus lower is 0, is equal to this 20. So V is equal to 20. So this will be plus 20 volts. Now, if this is 0, this is 10 volt. You say this higher minus lower. So higher is higher. This is V. Minus lower is 0, must be equal to 10. So V will be equals to 10 volts plus 10. Okay. So you have to assume the potential at a point is 0. I assumed here. So it came out to be how much? 20. That came out to be 10. If this is 20, it's a wire only from here to here. From this point to this point, it is wire only. There is no battery, no resistor in between. So here also potential will be same. So if it is a simple wire, then potential at every point will remain the same. If it is 10, potential at this point is 10 volts. Absolutely, sir. Absolutely, sir. Now, boys and girls, what I want you to understand in this particular case, I would say redraw. Redraw the circuit. When you redraw, you'll be making this. Okay, this is the resistor 10 ohms. This is 20 volts over here. This is the resistor over here 5 ohms. This is 0 volts over here. Okay, and this is the resistor over here 20 ohms. And this is over here, I would say 10 volts. Okay, and this is the potential VM. This is the potential VM. Guys, is this clear till over here? Is there any sort of doubt in this particular case? Please tell me in the chats. Everybody out there, please tell me in the chats, is there any sort of doubt in this particular case? Come on. Is there any sort of doubt? Is this clear? Is this clear? Give me the signal in the chats. Quick, 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 quick. Is this clear? Simple, you guys are supposed to basically assume the potential at a point 0. Then you can basically use that one. Okay. Now, guys, take a look. Now, you find the potential. See, this is first resistor, second, and this is third. You have to find midpoint potential. Can I say Vm will be V1 by R1? V1 by R1, that is 20 divided by 10 plus V2 by R2. V2 is 10 divided by 20 plus V3 by R3, that is 0 divided by 5 upon 1 by R1, that is 1 by 10, 1 by 20, 1 divided by 10 plus 1 divided by 20 plus 1 divided by 5. Okay. Now, when you solve this, it will come out to be 50 divided by 7. It will come out to be 50 by 7. So potential of this point came out to be 50 by 7. Now see, whenever they ask you to find the current in a circuit of this sort, you find potential of every point. First you assume 0 here. Then if it is 0, this is 20, this will be plus 20. If it is 0, this is 10, this will be plus 10. Take it over here, this will be 10. Here also 10. Now potential of this point you got with the help of midpoint potential formula, that is 50 by 7. Now this potential is 50 by 7. Now, once you get the potential of every point, now it is very simple to find the current. Consider you are supposed to find the current here. Okay, no problem. Okay, current in 20 ohms. Listen carefully. Take this 20 ohm resistance. This is 20. What is the potential of this? 50 divided by 7. What is the potential of this? 10 volts. Now you have to find the current over here. So current is I is equal to, guys, Ohm's law, basic thing. Everybody knows that V is equal to I into R. This is the Ohm's law. So if you have a resistor, which has resistance R, in which current is flowing I, if I say what is the potential difference across the two, so that will be V. V is equal to I into R. This is Ohm's law. Nothing else, nothing else, nothing else. So we can say, sir, I is equal to, instead of V, it is actually delta V divided by R, potential difference, because we say V is equal to I into R. It is delta V is equal to I into R. I will be equals to delta V divided by R. Now tell me, I will be equals to delta V. Delta V is the potential difference. Guys, that is this potential minus this, higher minus lower. So 10 is greater than 50 by 7. So 10 minus 50 divided by 7. 10 minus 50 divided by 7. R is basically 20. Now this is 70 minus 50. That is 20 by 7. 20 divided by 7 into this 20. This and this will cancel. It will come out to be 1 by 7 ampere. Is this clear? Oh, give me the signal in the chats. Is this clear? Is this clear? 1 by 7. Now, if somebody says, sir, what is the current in this in this one? What is the current in this one? Okay, you'll be simply saying, sir, current here, I is equal to delta V by R. Current in this one. Now, delta V means higher minus lower. Potential of this is 20 minus potential of this midpoint. You recently got 50 by 7. Or resistance is, I would say, 10. Solve this, you will get the current in this one. Is this clear? Give me the signal in the chats. So basically, the point is you have to find the potential of every point. Once you get the potential of every point, then you can say delta V by R. That's it. That's it. That's it. Like here, 70. This is 7 into 20 minus 50 divided by 10 into 7. I hope this is crystal and clear. This is crystal and clear. Okay. There is a question from JEE 2019 on the same concept. Listen to me very carefully. Listen to me very carefully. Find the potential difference between A and B. This is the point A, this is point A, and this is point B. Listen, guys, very carefully. We redraw this particular circuit. We redraw. See, this, and this. These can be considered as series. These can be considered in the series. Now see why. Guys, if let's suppose this has this resistor, this resistor, this resistor. Are these three resistors in series or parallel? Series. You can make it like this also. You can make it like this also. It is one and the same thing, bro. If I say current I is flowing, same current will flow through this resistor, and this resistor. It is one and the same thing. Now that's what I'm saying over here. That's what I'm saying over here. This resistor, and this battery, they are connected in series. And when the resistors are connected in series, we add them. This plus this. Equivalent of this and this will be, these two are not in parallel, okay? Please keep that thing in your mind. These two are not in parallel. But sir, we have seen parallel combination is like this only. In that case, this is having the potential B, this end. This is having the potential A. In that particular case, both the resistors are having the same potential across both the ends. Here it is different. So this and this will be in the series, not in parallel. So if this and this is in the series, listen carefully. So 10 plus 10 is 20. So I can make this 20 over here. And this battery, something like this, 2 volts. Then this middle branch, a resistor, and this battery, boys and girls. Then this one, guys, this one and this one will be also considered as series. 20 plus 10 is 30. You can make it like this. This will be 30 ohms. And this middle is 20 ohms. This is 2 volts. This is 4 volts. This is 4 volts. Now. You have to find the potential difference. Okay, that's not a problem. That is VA minus VB you are supposed to find. Assume the potential at a point 0. 0 volt, I would say let. If you assume the potential 0 over here, so can I say potential at this point would be also 0? Why? Because it's a wire only. So here also it would be 0. Now, if it is 0, this is 2. What will be the potential of this point? Plus 2 volts. Array, 2 minus 0 is 2. If this is 0, this is 4. What is the potential of this point? Plus 4 volts. Because 4 minus 0 is 4. If this is 0, this is 4. What is the potential of this point? Plus 4 volts. Absolutely, sir. We can write it like this. Now redraw. Once again redraw. Okay. So this is, I would say, potential, 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 potential. So this is 2 volts, this is 4 volts, this is 4 volts. Resistance, 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 20 ohms, 20 ohms, 30 ohms. And this is what we call midpoint. Array, sir, this midpoint is basically A. This is point A. So what I can say in this particular case, potential of A, that is V1 by R1, V1 by R1 plus V2 by R2 plus V3 by R3. That is 2 divided by 20 plus 2 divided by 20 plus 4 divided by 20 plus 4 divided by 30. V1 by R1, V2 by R2, V3 by R3 upon 1 by R1. 1 divided by 20 plus 1 divided by 20 plus 1 divided by 30. Oh, yes or no? Please tell me in the chats. This will come out to be how much? Please tell me in the chats if this is clear. Let me know the answer, how much it will come out to be. Solve this and let me know the answer. What is the potential of point A? What is the potential of point A? Solve this, it will come out to be 3.12 volts. So potential of point A comes out to be 3.12 volts. Now see, VA comes out to be 3.12. Can I write it like this? VA minus 0 is equal to 3.12 volts. Right? VA minus 0 is VA. Now what is 0 actually? 0 we assume potential of B. So basically it is VA minus VB is equal to 3.12 volts. So that is what we were supposed to calculate. Is this clear? Oh, give me the signal in the chats. Give me the signal in the chats. Sir, now can we find the current in any branch over here? 100%. What is the current over here? If this is potential, how much? 3.12. What will be the potential of this point? 3.12. Now, can you find the current? That is delta V by R. That is 3.12 minus 2 divided by R. R is 20. Oh. Okay. Can you find the current in this one? Yes. Delta V by R. That is 4 minus 3.12 divided by R. R is 20. Tell me in the chat, so. Tell me in the chats. This one I'll give you as homework. Do solve this from your end. It is simple. It is simple. Is this clear? Is this clear? Smash the like button if you are not liked the session yet. Okay. Now take a look, boys and girls. Listen to me very carefully. This is I am giving you as homework. See. No current will flow in this. So remove this branch. What you are going to do is, because current does not flow in the open circuit, remove this, remove this. If you remove this and this, now this point becomes A and this point becomes B. Assume the potential of this point as 0. Let. If this is 0, this point would be 0. This point would be 0. If this is 0, this is 3. What is the potential of this? This would be 3 volts plus 3. If this is 0, what is the potential of this? Plus 2 volts. If this is 0, what is the potential of this? This is 1 plus 1. Now, this is midpoint, because this point is mid. Now, can you tell me what is the potential of A? V1 by R1, V2 by R2, V3 by R3 upon 1 by R1, 1 by R2, 1 by R3. Done and dusted. You can solve this from your end. You can solve this from your end. Okay, this question I will show you. Find current I. You guys are supposed to tell me what is the current I. Listen. I want you guys to understand one thing if you have to find the current. Always remember, put the batteries on one side and resistors on another side. See, this resistor and this battery are in series. You can interchange their position. You can take it over here, you can take it over there. So I can make it like this. I can make it like this. Guys, see, it would be something like this. How do you find the current in a resistor? Delta V by R. You should first know the potential difference. Now, take a look. This battery has a potential difference 20 volts, 20, and this is a 5 ohm resistor. This battery is 10-volt battery, and this is 4 ohm resistor. And this is 8-volt battery over here. What we are supposed to do is we'll assume potential as 0 at a point. We are assuming 0 over here. If you assume 0 here, it would be 0 at this point. It would be 0 at this point. Now, if it is 0 here, what is the potential of this point? Plus 20. Why? Because 20 minus 0, it will be 20. If it is 0 at this point, what is the potential of this point? Now, this is very important. In this particular case, we always say higher minus lower. Higher is 0 because it is connected to the higher potential, positive terminal. Higher minus lower. So it will be 0 minus 10. Higher minus lower has to be equal to this. What is this is 10-volt battery. It will be equals to 10. Higher potential minus lower potential. Okay. Okay, lower we don't know is in this case. Okay. Higher potential. Okay. Minus lower potential. So 0 minus V, let's suppose potential of this is V, is equal to this 10. Now take this minus over here, V will be equals to minus 10. So this is minus 10. This is minus 10. Okay. Now guys, if this is 0, this is 8, what is the potential of this plus 8? Because 8 higher minus lower, 8 minus 0 is 8. If this is 8, what is the potential of this? 8. What is the potential of this? 8. Okay. Now, boys and girls, tell me one thing. Tell me one thing. You have to find the current in this. We say current. Take this 5 ohm resistance. 5 ohm. What is the potential over here? This is 8 volts. What is the potential over here? This is 20 volts. What will be the current? Let's suppose I1 is the current. And this is higher, this is lower. So this will be the direction of current. Current always flow from higher to lower. So this is I1. I1 is equal to delta V divided by R. Delta V is higher minus lower. That is 20 minus 8 divided by R is 5. So that will be 12 by 5 ampere. Oh. Amazing, sir. Sir, can you tell me the current in this one also? Just a fraction of seconds. Okay, this is 4 ohms, 8 volts minus 10 volts. Tell me, could you please tell me in this case, what is the direction of current? Higher to lower. This is I2. This is delta V by R. Delta V is higher minus lower. 8 minus of minus 10 divided by R. R is 4. This is 18 divided by 4. That is 9 by 2 ampere. Tell me, is this clear? Is this clear? Come on, quick. Tell me in the chats if this is crystalline clear. Is this clear? Tell me. Sir, please do coordination D and F block. Yes, next will be coordination D and F block. Just it will take us 5 to 10 minutes. Then we will start coordination D and F block. No, in this particular case, midpoint potential, we don't have to calculate. Why? Because we got the potential of every single point without the midpoint potential formula. Okay. Midpoint potential you'll be using only in that particular question where you cannot find the potential of a point. Like. Here. Sir, if it is zero potential of this point, I got how much? 3. What is the potential of this point? I don't know. If it is zero, potential of this point is 2. What is the potential of this point? I don't know. Can I find it? No. That's why here I am using midpoint potential formula. So in this particular case, I don't have to use it. Why? Because I got the potential of every single point without that formula. Without that formula. Okay. Yes. Now, let's take a look at a bulb. See, guys, bulb means which you use in your home. This is the bulb. This is the bulb. Okay. Now, this bulb has got a power. If I say this power of the bulb is, we say 200 volts. And it would be mentioned, this is what we call PR, power rated. This is what we call VR. Voltage rated is 220 volts. So in India, voltage supplied by the government is 220 volts. This is called voltage rated. What does it mean? It means that if you have a bulb, it is mentioned 200 watts and 220 volts. It means that if you give a supply of 220 volts to this bulb, it will give you the power of 200 volts. So at 220 volts, it is going to give you 200 watt supply. Sir, what if you supply less than 220 volts? Then it will not supply the 200 watt power. This bulb, if I say this is a 50 watt bulb used, 50 watt bulb means if you supply 220 volts to this 50 watt bulb, it will give you the power of what? 50 watts. If you have 200 watt bulb, if you supply 220 volts potential difference voltage, then only it will give you the power of 200 watts. That is the meaning. Now see, you have got series combination of bulb and parallel combination of bulb. If you have got series combination of bulbs, in this particular case, guys, power of first is P1, power of second is P2, power of third is P3. If you have these bulbs connected in series, listen to me very carefully. And if they ask you, like this is 50 watt, 20 watt, 30 watt, if they ask you how much will be the net power consumption, listen carefully. When these bulbs glow, guys, listen, when these bulbs glow, how do the bulbs glow? When you send the potential difference, when you send the energy. Now, how much is the power consumption? How much is the energy? Arey bhai, if you have a bulb in your room, if I say this bulb is providing you the energy, how? When you send the current to the bulb, that current itself is energy. That current is itself the power consumed by the bulb. So when bulb consumes the power, then only it supplies you the power. It supplies you the brightness, that energy. So when power is consumed, then only power is supplied. The amount of power it consumes, the amount of energy it supplies. Now see, how much is the power consumed by the bulb in series combination? See, we say 1 upon power consumed. It will be 1 by P1 plus 1 by P2 plus 1 by P3. This is how to find the net power consumption in the series combination. When bulbs are connected in series, they consume electricity, they consume power, they consume energy. And then that energy is converted into the brightness which you receive. So let's suppose if you have two bulbs in series, we can say 1 upon power consumption will be equals to 1 by P1 plus 1 by P2. Now do the cross multiply. This will be 1 upon power consumption is P2 plus P1 upon P1 plus P2. Now, P1 into P2. Now do the reciprocal. So power consumption will be P1 P2 upon, I would say, P1 plus P2 upon P1 plus P2 upon P1 plus P2. Okay, yes. When it comes to the parallel combination, if you have bulbs connected in parallel, How do we find the power consumption? That is P1, simply P1 plus P2 plus P3 and so on up to Pn. If these are 3 bulbs only, then this. Yes. Now take a look at the question, guys. Six similar bulbs are connected as shown in the figure. 1, 2, 3, 4, 5, 6. Okay. The ratio of power consumption by the bulbs when all are glowing, it says when all the 6 bulbs are glowing, these are the identical bulbs, so power of each bulb is same. When all the 6 bulbs are glowing, you have to find the power in that case. Consider that P1. When 2 bulbs from section A are glowing and 1 from section B is glowing, in that case you have to find the power. See, guys. Case first. Wait for me. First, when all are glowing, this. Now, this is P, 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 identical bulbs. Now, can you tell me these 3 are separately in parallel? These 3 are separately in parallel. How do you find the power consumption parallel combination? P1 plus P2 plus P3. 3P, 3P. It will look something like this. So this is 3P and this is 3P. Net power of this, net power of this. Yes. Now, can you find, sure, power equivalent? Sir, when 2 bulbs are in series, how do you find the equivalent power consumption? P1, P2 upon P1 plus P2. So we'll be simply saying P1, P2, 3P into 3P upon P1 plus P2, 3P plus 3P. 3 into 3 is 9P square. 3 plus 3 is 6P. P and square will cancel. 3 2s are 6, 3 3s are 9. So P1 will come out to be 3P divided by 2. Second, when 2 from section A, 1 from section B is glowing. When 2 from section A and 1 from section B is glowing, 2 means P plus P, that is 2P, and this is P. In this particular case, what is the net power consumption? P1, P2, 2P into P divided by 2P plus P, that is 3P. Now this will be, P and P will cancel, so this will be 2P divided by 3. Now you have to find the ratio, P1 divided by P2. What is P1? 3P divided by 2. What is P2? 2P by 3. When you do the reciprocal, it will be 3 divided by 2P. P will cancel. 3 3s are 9 divided by 4 is the ratio. Is this question clear? Is this question clear? Tell me. Is this question clear? Tell me, guys. Okay. Take a look at this question. This is one more from the bulbs. Very important. A filament bulb of 500 watts, 100 volt battery. This is a bulb. It is 500 watts and 100 volts. It is mentioned. What does it mean? What does it mean? It means that, my dear NEET aspirants, if you give 100 watt voltage to this bulb, it will give you how much power? 500 watt power. If you give 100 volts to this bulb, it will give you 500 watt power. Okay. Is to be used in a 230 volt supply. We are using this in a 230 volt supply. 230 volt battery we are applying over here. When a resistance R is connected in series, a resistance of R is connected in series. Okay, it works perfectly fine. It works perfectly fine. The value of R is, you are supposed to find the value of R. Listen carefully, my dear NEET aspirants. See, let's find the current in the circuit. See. We say there is a formula, that is what we call P is equal to V into I. Power is equal to voltage into current. Directly remember this. If you have to find the power, if you have to find the current in the bulb, you check how much is the power of this bulb, that is 500, is equal to V. V is the voltage. Guys, this is 230 volt. What is the maximum voltage this bulb can take? 100 watts, 100 volts. Sir, if we give more than 100 volts, it is going to burn the bulb. So 100 volts is the maximum voltage it can take. So if this battery is sending 230 volts, 100 volt this will take, 130 volt this will take. 130 plus 100 is 230. So how much is the voltage consumed by the bulb? 100 into I. This and this will cancel. So current came out to be 5 ampere. So what I'm trying to say is that in this particular case, current 5 ampere is flowing. This and this in series. So same current will flow through this resistance also. Why? Because in case of series combination, current always remains the same. So now here, V is equal to I into R. We'll be using the Ohm's law here. Now, what is the potential difference of this? 130. Current. What is the current? That is 5 and resistance is R. So R will be 130 divided by 5. That will be 26 ohms. One more important concept I will tell you over here. Guys, in this particular case, what is the maximum capability that this bulb can take? What is the maximum voltage that the bulb can take? 100 volts. If you give more than 100, it is going to burn the bulb. That's why we are using a resistance in series. So because 230 volt you are supplying, this can only take 100. Rest will go into the resistance. So if you don't use the resistance over here, bulb will fuse. Okay, it is going to burn the bulb. Now see, take a look at this particular question over here. 3 identical bulbs are connected as shown in the figure. Okay, 1, 2, and 3. When the switch is open, power consumed by the bulb is P. When switch is open, power consumed by this bulb is P. Okay, first I'll write over here. When switch is open, when switch is open, means this bulb is not connected to this circuit. Guys, listen. When switch is open means this is not connected to the circuit. So current cannot flow in this, so you can remove this. In that particular case, this circuit will look something like this. This. And this bulb has got resistance R, this bulb has got resistance R. Okay? Yes. Okay? Yes. Yes. Now, my dear NEET aspirants, what I want you guys to understand, is, or you can say in this particular case, listen to me very carefully. Sir, this is having the power P and this is having the power P. And these two bulbs are in we say parallel or in series. What will be the power consumption over here? P1. Okay, P1 will be P into P. That is P square divided by 2P. Okay, guys, when this is open, so means this bulb and this bulb will be only present in the circuit. No current will flow through this bulb. Why? Because circuit is open. Current does not flow through the open circuit. Current always flow in a loop. So this and this will cancel. So P1 will be equals to P divided by 2. Okay? Yes. Yes. Okay. You are supposed to find the power consumption by this bulb. Do one thing. Don't use this because we don't have to find the P1 and P2. I'll tell you what will you do. Wait. See, guys. Now in this particular, this is a very good question. Next level question. See. What I'm trying to say in this particular case, sir, when this is disconnected, this is not connected, this and this will have the resistance R. Now, when you have equal resistances in series, this potential difference of the battery will be divided equally. So, E by 2 will go here and E by 2 will go here. If this is a 100-volt battery, it will give the potential difference 50 to this, 50 to this. Tell me, what is the power of this bulb B? Sir, power of this bulb B, P1. That is, power is, guys, listen carefully. We say there are three formulas of power. V into I, V square divided by R, P is equal to I square into R. This is in terms of voltage and current, in terms of voltage and resistance, in terms of current and resistance. Now see, we say, sir, can you tell me what is the power consumption by this bulb? V by R. How much is the potential difference of this? E by 2. V square by R. So E square divided by E by 2 whole square, that is E square by 4. R is this. Now take it over here. So this will be 4. And what is the value of P1? When the switch is open, the power consumption by the bulb is P. Power consumption by the bulb B is P. So this is P actually. That is E square by 4R. Take it over here. So this will be 4P will be equals to E square divided by R. Then the second part. What will be the power consumption by the same bulb? When switch is closed. Now see, second. When switch is closed. When switch is closed. Okay. When, my dear NEET aspirants, switch is closed, in that particular case, what I'm going to do is, we say, now this bulb is also connected to the circuit, and this and this. I'll make it something like this. Okay. Now this is R, and this is R. Now tell me, when you have two resistors in parallel, their equivalent resistance, guys, two resistors in parallel. See, when you have two resistors in series, R and this R, and if I say what is the R equivalent in this particular case, you will say, sir, 2R. When you have two resistors in parallel, this R and this R, if I say what is R equivalent, you'll be saying R1, R2 upon, here you'll be simply saying R1 plus R2. In this case, R1, R2 upon R1 plus R2. So that will be R into R becomes R square divided by R plus R is 2R. R and this will cancel, so it will come out to be R by 2. Now see, their equivalent resistance is R by 2. Now I'll make it like this. Remove this, I'll make one only. So I'll make it like this. This resistance, this is R by 2, and this is R, and this is E. Now see. When you have equal resistors in series, then the potential difference will be distributed equally, E by 2 and E by 2. When in this particular case, my dear NEET aspirants, this is R and this is R by 2. In this particular case, what I can do is, we say some portion of the potential difference will go here. Let's suppose X. Some portion will go here. Since these are not equal, so I can say X. Now, if a resistance is less, potential difference received by that resistance will be less. Here X, now this is 2 times of this, because this is R by 2, this is R. So here it will go 2X. Bro, when these two are equal, then X and X. When these two are not equal, so to the less resistance, less potential difference will go. To more resistance, more potential difference will go. Now see, so basically this E is divided into X plus 2X. So E will be equals to 3X. So X will be equals to E divided by 3. So this is going to receive the potential difference of E by 3. Now tell me, what is the power consumption by the bulb? P2. That is V square by R. That is E square divided by 9. Because E by 3 whole square I am saying. So that is E square by 9. And resistance, what is the resistance of this Guys. Please don't get confused here. I got the potential difference. I got the potential difference as x over here. So same x will be here. Same x will be here because in parallel combination, potential difference is same. So E square divided by R. Please don't say it is R by 2 over here. It is R only. I'm supposed to write R only. Now tell me, guys, E square by R is actually 4p. So this P2 will be equals to, this is 4p divided by 9. This is the answer. If you are getting any sort of confusion in this question, what I can recommend you over here is to watch this later on once again. Is this clear? Tell me in the chats, bro. Is this clear? Is this clear? Let's move on to the next question. Galvanometer. Galvanometer. Let's take a look at galvanometer. Let's take a look at galvanometer. See, guys, when it comes to the galvanometer, it is a device which is used to detect the current. Let's suppose in a circuit you have to detect the current. In a circuit you have to detect the current. You will be using basically this galvanometer. It also measures the small range of currents. If there are small currents in the circuit, then you can use galvanometer to find that current. If the current is large, then you cannot use galvanometer to measure the large currents because that is going to burn the current. So, in order to measure the large currents, we do conversion of galvanometer into an ammeter. Galvanometer is a device which is used to measure the small currents. Let's suppose you have a large current in the circuit. In that particular case, you will be making a new device. You will be converting this galvanometer into an ammeter. Okay, so then it can measure the large current. Now see, this is a galvanometer. Okay, let's suppose this is a current which is a large, huge current coming in. Now, this galvanometer can only measure Ig. Ig is the maximum current galvanometer can measure. It can flow through the galvanometer. Now, if this is I, large current, through this galvanometer, only Ig will go. The rest of the current is I minus Ig, which goes into this. Now, see. Listen carefully. This is the galvanometer. You want to convert this galvanometer into an ammeter, which measures the large current. You connect a shunt resistance in parallel. You connect a resistance that is what we call shunt in parallel. This device is what we call ammeter. Sir, what is the problem of galvanometer? Problem of galvanometer is it does not measure the large currents. It measures the small currents only. Okay. So you apply a shunt resistance in parallel, it becomes an ammeter. So ammeter is a device which measures the large currents. And this shunt is equal to how much is the value of shunt resistance? Ig into G. Ig is the current which can flow through the galvanometer. G is the resistance of the galvanometer. I minus Ig. I is the current. Guys, this I is the current which is coming in. Ig is the current which flows through the galvanometer. I minus Ig is the current which flows through shunt. And G is the resistance of the galvanometer. This is the value of shunt. Directly remember. If you convert a galvanometer into an ammeter, okay, then you apply the shunt resistance in parallel. The value of that shunt resistance is this. Let's take a look. A galvanometer of resistance 100 ohms is used to measure 10 ampere current. There is a galvanometer. It has a resistance of 100 ohms. It's used to measure 10 ampere current. Okay. Find the value of shunt resistance connected in parallel. There is a galvanometer. It has a resistance of 100 ohms. Is used to measure 10 ampere current. So means current through the galvanometer can only flow. Value of Ig is 10 ampere. Find the value of a shunt resistance connected in parallel. We have connected a shunt resistance in parallel. Okay. So that it can measure the current, so that its range becomes 50 ampere, so that it can measure the current of I is equal to 50 ampere. Guys, 50 ampere current you are sending. Only 10 ampere can flow through the gal. What is the value of shunt resistance in parallel? That's what we are supposed to find out. How do you find the shunt? S is equal to Ig into G upon I minus Ig. Ig is 10. G, resistance of galvanometer is 100. I minus Ig. I is 50, Ig is 10, so this will be 40. This and this will cancel. 100 by 4 is 25 ohms. So means if you apply a shunt of 25 ohms, it becomes an ammeter which can measure the current up to 50 ampere. This is the answer to the question. AIPMT 2014. In an ammeter, 0.2% of the main current passes through the galvanometer. This is an ammeter. Okay, this is an ammeter. Galvanometer per shunt. 0.2% current passes through the galvanometer. 0.2%. That is 0.2 I. From I, 0.2% passes through the galvanometer. This is the value of Ig. So what is the remaining current? Remaining current flows through the shunt. That is 99.8 I. Because 99.8 plus 0.2, it is going to be 100%. This is the value of I minus Ig. If the resistance of the galvanometer is G, resistance of the galvanometer is G, then the resistance of ammeter is. Guys, it is not asking us to find the shunt. It is asking us to find the resistance of the entire ammeter. Now see, before finding the resistance of whole ammeter, you must find the resistance shunt. Guys, see, what is the value of shunt? Ig into G upon I minus Ig. S is equal to Ig is 0.2I into G upon I minus Ig is 99.8I. So this I and I will cancel. You can write it like this. 0.2 means 2 by 10. G upon 99.8 means 998 divided by 10, because after the decimal point you have one digit, that's why divided by 10. This and this will cancel. 2 ones are 2 499s are G divided by 499. Shunt came out to be G by 499. Now see, you have got galvanometer resistance as G. You have got shunt resistance as G divided by 499. This whole is an ammeter. You have to find the net resistance of the ammeter. How do you find? Guys, two resistors are in parallel. How do you find the resistance of ammeter? R1, R2. In parallel, R1, R2 upon R1 plus R2. R1, R2. That is G into G divided by 499 upon G plus G divided by 499. So what will be? This will be G square divided by 499 upon 499G plus G. This will be 500G divided by 499. This and this will cancel. G and square will cancel. So answer is G by 500. So G by 500 is the resistance of ammeter. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. Everybody out there. Come on, quick. Smash the like button if you're not liked the session yet. Is this clear? That's great. Now see, galvanometer is also a device which measures potential difference. Potential difference. But the problem with the galvanometer is it has got less range, low range, okay, and it produces large error. So what we do is we convert this galvanometer into a voltmeter. Like galvanometer was able to measure the current also, but we say range was less, it was able to measure the less currents. So that's why boys and girls in this particular case, we connected the shunt resistance in parallel and we converted this into an ammeter. Now here, galvanometer can be converted into the voltmeter also. Voltmeter is a device which measures potential difference, and ammeter is the device which measures current, which measures potential difference. Now see, in order to convert the galvanometer, not gold meter, galvanometer into an ammeter, we connect the shunt resistance in parallel. Here we connect shunt resistance in series. And if somebody asks you what is the value of the shunt, directly, V divided by Ig. V is the potential difference across voltmeter, across both galvanometer and shunt. Ig is the current flowing through galvanometer, minus G is the resistance of the galvanometer. Let's take a look at this. A galvanometer has a coil of resistance 100 ohms. Okay, yes. Galvanometer has got a coil of resistance 100 ohms. Gives a full scale deflection of 30 milliampere. What does it mean? It means current flowing through the galvanometer is 30 milliampere. If it is to work as a voltmeter, if you have to convert this into a voltmeter, you need to connect the shunt in parallel. Sorry, in series. Of 30 volt range means potential difference. Voltage of this voltmeter is 30 volts. The resistance required to be added will be, what is the value of shunt that we need to add over here? So what I can say, this shunt will be, that is V divided by Ig minus G. Okay, V divided by Ig minus G. Now, S is equal to, what is the potential difference of this, that is 30 volt divided by, what is the current in the galvanometer? 30 milliampere. 30 milliampere is 30 into 10 raised power minus 3 minus G. G is the resistance of galvanometer, that is 100. So 30 and 30 will cancel. So this shunt will be, take this in the numerator, 10 raised power 3 means 1000 minus 100. It will come out to be 900 ohms. 900 ohms. Is this clear? Oh? Now comes the meter bridge. Now comes the meter bridge. Okay, now comes the meter bridge. Okay. Okay, that's great. Now see, we say meter bridge. Meter bridge basically is an instrument used to measure the resistance, unknown resistance. An instrument used to measure unknown resistance. Okay. It's based on the concept of Wheatstone bridge. Let me tell you what is the concept of Wheatstone bridge. See, This question is on, this is your homework, this question, okay? Please do read it from your end very carefully. Its answer is potential difference across A will be potential difference across B will be equals to potential difference across C. This is the answer to the question. Please do this from your end, okay? It is very important. Now see, concept of Wheatstone bridge. Wheatstone bridge. Take a look. See, let's suppose, my dear NEET aspirants, you have got a resistance over here. You have got one more resistance over here. You have got one more resistance over here. You have got one more resistance over here. And there is this resistance in between also. Okay? Yes. This is R1, this is R2, this is R3, this is R4, and this is R5. If, my dear NEET aspirants, we say R1 by R2, if ratio of R1 divided by R2 is equal to ratio of R3 by R4, resistance of this divided by resistance of this is equal to resistance of this divided by resistance of this, then current through R5 is 0. This is the concept of Wheatstone bridge. If resistance of this by this is equal to resistance of this by this, then no current flowing through will be 0. No current flows through this, because then we say potential difference across this R5 will be same. Now what I'm trying to say in this particular case, my dear NEET aspirants, you can think you can think like this also. If current flowing through the R5 is 0, if current flowing through R5 is 0, then R1 by R2 will be equals to R3 by R4. Similar concept is used over here. See, meter bridge is an instrument used to measure the unknown resistance. Okay. If I say you have got a, see, this is a construction of meter bridge. You take a known resistance. Known means its value you know already. Okay. This is unknown. This is what you are supposed to find. And then you connect a 100 meter, 1 meter wire, 1 meter, 100 centimeter wire. That means 1 meter wire. And you connect a galvanometer over here. This is a galvanometer connected. And this is a jockey connected over here. Cool. Now guys, listen carefully. In this particular case, what we say is that we keep on, see, current flow, this is a battery connected. Current will flow through this, okay? We keep on sliding the jockey on this wire until galvanometer, current through the galvanometer becomes 0. Okay. We keep on sliding the jockey on this wire until no current flows through this galvanometer. Yes. Sir, if we put the jockey over here, then we check the galvanometer reading, current is still flowing. Then we take it over here, still flowing. Then we take it over here, still flowing. Then we take it over here, still flowing. We put it over here. Now it is not flowing. So means this is the point when current through the galvanometer is 0. This point is what we call balance point. So here, what we are supposed to do, we have to find the balance point. When we get the balance point, we say then no current flows through the galvanometer. Let's suppose this balance point is at L1 distance. So this will be how much? I can say 100 minus L1. Now, if you have to find the resistance of this portion of the wire, you simply say lambda into L1. Resistance of this portion will be lambda into 100 minus L1. What is this lambda? Lambda is what we call resistance per unit length. Resistance per unit length. Per unit length. Guys, understand this point very carefully. In case of a meter bridge, you have a known resistance, unknown resistance, and a wire, and a galvanometer and jockey. You keep on sliding this jockey on this wire until you get the balance point. Balance point means when no current flows through the galvanometer. Okay, let's suppose you get the balance point at L1. So means resistance of this portion will be lambda into L1. Lambda means resistance per unit length. Resistance of this portion will be lambda in 100 minus L1 into lambda. Okay. Now Now, don't you think that this behaves like a Wheatstone bridge? Let me show you. It is like this. It is like this. This is R1. R1 is P. This is R2. That is Q. Or this is R2. That is lambda L1. This is galvanometer. Okay, current in the galvanometer is 0. And this is lambda into 100 minus L1. Now, my dear NEET aspirants, if I say current in the fifth resistor, this galvanometer is 0, fifth resistor, then this by this will be equals to this divided by this. So lambda and lambda will cancel. So we say P divided by this Q will be L divided by 100 minus L1 divided by 100 minus L1. Please tell me in the chats, this is the equation. This is the equation of meter bridge. By this equation, you can basically find what? See guys, the unknown resistance. See, this is a meter bridge. In this particular case, it says that current in the galvanometer is basically 0 when L is 20 centimeters. So basically you are getting the balance point at what? 20 centimeters. Can you tell me what is the value of this unknown resistance? Sir, P divided by Q will be equals to L divided by 100 minus L. Now P, what is the value of P? 5. What is the value of Q? X is equal to L. How much is L? 20. 100 minus L, this will be 80. This and this will cancel. 2 ones are 2 fours are. X will be equals to 20 ohms. Oh. Guys, tell me in the chats, is this clear? Is this clear? Tell me in the chats, everyone. Let's suppose you have this question. Let's suppose you have this question. In the following circuit, a meter bridge is shown in a balanced state. The meter bridge wire has a resistance of 1 ohm per centimeter. Then 1 ohm centimeter. The value of, calculate the value of unknown resistance X. You have to tell me value of unknown resistance X. And the current drawn from the battery to the negligible internal resistance. Guys, see. Could you please tell me what is the value of, guys, see, listen carefully. We say this is in a balanced Wheatstone meter bridge, in a balanced state. Means balancing length is L1. So we can say P divided by Q is equal to L divided by 100 minus L. What is the value of P? X. What is the value of Q? 6 is equal. L. L is how much? 40. 100 divided by L. Sorry, 100 minus L. 100 minus L. This will be 60. This and this will cancel. 2 2s are 4. 6 and 6 will cancel. 6 and 6 will cancel. So X will come out to be 4. So this portion of this is done. Now guys, if it says that this wire has the resistance of 1 ohm centimeter. Now how much will be the resistance of this portion? Guys, it is actually lambda into L na? And this is 100 minus lambda into L. 100 minus L into lambda. So this is the value of lambda actually. So lambda is 1, L is 40, so this will be 40 ohms. 100 minus L is 60, into lambda is 1, so this will be 60 ohms. Now it says the current drawn from the battery. What is the current in the circuit? Now let's redraw the circuit. So this resistance X, you got 4 ohms. This is 6 ohms. This is 40 ohms because this is 40 ohms. This is 60 ohms. And this is the battery. Now, battery is 6 volts. When you have to find the current, you always say V divided by R. R means what? The net resistance of this. Now tell me, this and this are in series. So their equivalent is 10. Their equivalent is 100. Now can you tell me R equivalent? Final. Guys, see, 6 plus 4 is 10. 60 plus 40 is 100. Now 10 and 100 are now in parallel. So what is the equivalent of 10 and 100? In parallel, R1, R2 upon R1 plus R2. 10 into 100 upon 100 plus 10. Okay, so that will be 110. Na? 10 into 100 upon 100 plus 10 is 110. 0 and 0 will cancel. So this will be 100 divided by 11. Now, what will be the current? I is equal to V by R. V is 6 upon R is 100 divided by 11. Take this in the numerator. It will be 66 divided by 100. Is this clear? Oh? Tell me in the chats. Is this clear? Tell me in the chats, everybody out there. Come on. Quick. Magnetic effects of current. Chapter 4. Chapter 4. Now, guys, take a look exactly over here. I would want you guys to focus on this particular chapter. Let's finish this chapter in next 1 hour. Okay. Now, guys, magnetic effects of current basically says, see, first is magnetic field due to a finite wire. Okay. See, let's suppose you have a wire over here, and in this wire, current I is flowing. Whenever current flows in a wire, always remember it produces the magnetic field around it. Okay. Whenever current flows through the wire, it produces magnetic field around it. So if in this wire current I is flowing, if I say what is the magnetic field at point P? What is the magnetic field at point P? Now, guys, join this point P with one end of the wire. This angle over here is θ1. Join this point with another end of the wire. This angle over here is, we say, θ2. And this is at R distance. This point is at R distance actually. Now, if I say magnetic field created due to this wire at point P, it will be B is equal to, listen carefully, direct. We say mu naught I divided by 4 pi R. Then I can say sine of θ1 plus I would say sine of θ2. sine of theta 2. This is the magnetic field produced by a wire at r distance, at r distance. Okay, so how do you define theta 1? Join this point with one end of the wire, join this point with another end of the wire. This is theta 1, this is theta 2. Yes. Let's suppose you have an infinite wire. This wire is going till infinity, this wire is going till infinity. Now see, you want to join this point with one end of the wire. That is not here, that is at infinity. So you have to make this line something like this. We assume this line will meet its end at infinity. So here we say theta 1 is 90 and theta 2 is 90. Directly remember. In case of an infinite wire, theta 1 is 90 and theta 2 is 90. What is going to be the magnetic field? Mu naught I divided by 4 pi r. Then sine of 90 plus I would say sine of 90 because theta 1 and theta 2 here is 90. Sine 90 is 1. Sine 90 is 1. 1 plus 1 is 2. So that 2 with this 2. So magnetic field will come out to be mu naught I divided by 2 pi r. Directly you have to remember this, my dear NEET aspirants, very important. Let's find the direction. How do you find the direction? Directly remember. Place your thumb along the direction of current. Curl your fingers at that point. If curling my fingers is showing inwards, the direction of curling the fingers is inwards, then the direction of magnetic field is inwards. Inward means cross. Inward means cross. From this side, curl your fingers, it will show outside. So outward means dot. Outward means dot. Magnetic field is inversely proportional to R. So graph will be rectangular hyperbola. Okay. In case of a semi-infinite wire, semi-infinite wire means in which case one side is going till infinity, another side is finite. Now see, here, join this with one end of the wire which is at infinity. So theta 1 is 90. Theta 2. Join this point with another end of the wire. Now between this white line and this R, what is the angle? 0 because they are parallel. So theta 2 is 0. If I say magnetic field, mu naught I divided by 4 pi r, sine of theta 1, 90 plus sine of theta 2, that is 0. Sine 0 is 0, sine 90 is 1. So magnetic field, B means magnetic field, by the way, it is mu naught I divided by 4 pi r and direction is inward. Magnetic field due to a square loop at the center. Guys, see, this square loop is made up of 4 wires. Listen carefully. You can directly remember the expression of this. No need to derive. See, magnetic field due to a square loop is 2 root 2 mu naught I divided by pi into L. Let me derive also. Guys, let's find the magnetic field due to this wire. See, join this point. This is the radius R. If this side is L, this will be L by 2. This and this. Total angle is 90. So this is 45. This is 45. Okay. So the logic here is you find the magnetic field due to this wire, then multiply it with 4. You will get this answer. Better is to directly remember this because it will be wastage of time. Okay. The logic is you find the magnetic field due to one wire, then multiply it with 4. Okay. Then multiply it with 4. You'll get this one. Okay. And how do you find the magnetic field due to one wire? Mu naught I divided by 4 pi r. Instead of r, you'll be writing L by 2. Then sine of theta 1 is 45 plus sine of theta 2, that is 45. Now, whatever the answer you get over here, multiply that with 4, you will eventually land onto this. Take a look at this. Let's suppose, my dear NEET aspirants, is this clear till over here? Tell me in the chats quick. Tell me in the chats, is this clear? Now take a look. Magnetic field due to a loop, circular loop. Okay. Magnetic field due to a circular current carrying loop. See guys, this is a current carrying loop. You are supposed to tell me what is the magnetic field. What is the magnetic field due to this current carrying loop at x distance? Whenever the current flows through a wire, it produces magnetic field. Okay. If it is flowing in a circular loop, you have to tell me what is the magnetic field at x distance. See guys, whenever you have to find the magnetic field at x distance, you'll be simply remembering at x distance from the center, this magnetic field is, I would say, mu naught I into r square divided by 2 into r square plus x square whole raised power 3 by 2. Mu naught is the permeability of free space, like you have epsilon naught, permittivity of free space in electrostatics. I into I is the current. I is the current. Okay. R is the radius of the ring. X is the distance at which you have to find the magnetic field. Let's suppose if I say at center, if at center, what is the value of x? 0. We know value of x at center is what? 0. If at center value of x is 0, put 0 over here, magnetic field will come out to be mu naught I into r square upon 2 into r square plus 0. So this will be r square whole raised power 3 by 2. So I think 2 and 2 will cancel. R square and cube will cancel. So magnetic field at the center is mu naught I divided by 2r. This is the magnetic field at the center. Okay. This is the magnetic field due to a ring at the center. Now take a look. Magnetic field due to a segment of ring. Segment of ring means arc. Arc. See guys, listen. This is a complete ring. If I say break this ring into 2 equal parts, this is called a semicircular ring. This is called a semicircular ring. I say break this ring into 4 equal parts. This is called chord, 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 chord. So in one complete ring, you have got 4 chords. Yes. Now, if I say cut some portion of the ring from here to here, this is called segment of ring. Okay, join this with center, join this with center. This is what we call radius. This is what we call theta. Now, this portion of the ring I am placing over here. This is the center. Join this with one end. This is radius r. Join this with another ring, another end. This is radius r. Angle between the two is theta. And how much current is flowing over here? That is I. And if somebody asks you, what is the magnetic field due to this at center? Mu naught I divided by 2r, theta by 2 pi. I is current, r is radius, theta is this angle. Now guys, take a look. Let's suppose if you have a semicircular wire. What is the angle in case of semicircular wire? Join the center with one end, this is r. Join this with another end, this is r. Angle is 180. So you'll be saying magnetic field is, what is the general formula? Mu naught I by 2r, theta by 2 pi. So that is mu naught I divided by 2r, theta by 2 pi. Theta, 180 means pi. Theta is pi divided by 2 pi. This and this will cancel. So magnetic field will be 2 into is 4. Mu naught I divided by 4r. Okay, mu naught I by 4r. And how do you find the direction? See, in case of a straight wire, how do you find the direction of magnetic field? Place your thumb along the direction of current, curl your fingers. That gives the direction of magnetic field. Here you have reverse. Curl your fingers along the direction of current. Okay. Thumb is pointing outwards. Thumb gives the direction of magnetic field. So outward means dot. How do you find the direction? Curl your fingers along direction of current, thumb is pointing upwards. If this is the direction of current, then it is inwards. Now, let's suppose you have a chord. This is radius r, this is radius r, theta is 90, 90 means pi by 2. How do you find the magnetic field? Mu naught I divided by 2r, theta by 2 pi. Theta is how much? Pi by 2 into 2 pi. Theta by 2 pi. Now tell me, boys and girls, this pi and pi will cancel. 2 into is 4, 4 into is 8. Magnetic field will be mu naught I divided by 8r. This is the magnetic field. Take a look at this. Take a look at this. Find the magnetic field at the center of the ring at this point. Now, guys, see, this entire structure is made up of 1, 2, 3, and 4 parts. Always remember, boys and girls, if you have a wire, okay, you have to find the magnetic field at a point which lies on the same line, as the wire. This point is on the same line, okay, as this wire. Okay, so magnetic field at this point will be 0. Now, I can say magnetic, see, since this is the current flow is like this, flows like this. So I can say magnetic field due to 3 is equal to magnetic field due to 4. Just a second, guys, just a second. मैं को sorry system बंद समझना मैंने में यार Can you hear me? Oh, Just a second, guys. Just a second. Just a second. What happened to the slides? Slides. Okay. Okay. Let's take a look at this chord. So we say magnetic field is mu naught I divided by 2r theta divided by 2 pi. Okay. Yes. So in this particular case, what is the value of theta? That is pi by 2 because 90 means pi by 2. So we say magnetic field is going to be mu naught I divided by 2r, and this would be pi by 2 into, I would say, 2 pi. Pi and pi will cancel, 2 2s are 4, 4 2s are 8. So mu naught I divided by 8r. Okay, so due to this mu naught I divided by 8r. Guys, four things you need to remember. Magnetic field due to an infinite wire, mu naught I divided by 2 pi into r. Magnetic field due to semi-infinite, it is mu naught I divided by 4 pi r. Magnetic field due to semicircle, mu naught I divided by 4r. Okay. Magnetic field due to chord, mu naught I divided by 8r. And magnetic field due to segment, that is mu naught I divided by 2r theta by 2 pi. That's it. All the questions will be based on these. Okay. Yes. Take a look. Take a look, boys and girls, in this particular case. Listen carefully. Find the magnetic field at the center. This is a ring, okay? You are supposed to tell me what is the magnetic field at the center. Listen carefully. We say this is a semicircle, this is a straight wire, this is a straight wire, this is 3 and this is 4. In this particular case, my dear NEET aspirants, we say magnetic field due to 3 will be equals to magnetic field due to 4, it will be 0. Why? Because this point lies on the same axis as this wire and this wire. Okay? Now, you have to find the magnetic field due to this and magnetic field due to this. So, when it comes to the net magnetic field, it will be magnetic field due to first and magnetic field due to second. Now, the question in this particular case is, listen to me very carefully. Sir, magnetic field due to this. What is the direction of magnetic field? How do you find that? Curl your fingers along the direction of current. Thumb is pointing inwards. So magnetic field due to this is inwards. So B1 is inwards. Okay, what about this? Curl your fingers along the direction of current. Thumb is also pointing inwards. So this is also inwards. So you need to say B1 plus B2. If both the magnetic fields are in the same direction, then you have to add B1 plus B2. So what I can say in this particular case, net magnetic field will be, due to the semicircle, what is the magnetic field? Mu naught I by 4R. So you can say this is mu naught I divided by 4R. R of this, radius of this is 2R. So 4 into, instead of radius, I'll be writing 2R. Why? Because R means the radius of this is 2R. Then plus. What is the magnetic field due to this? Mu naught I divided by, this is also semicircle, 4R. Now solve this and get the answer. A simple mu naught I by 4R is common. So mu naught I divided by 4R you can take common. So here it will be 1 divided by 2. I would say plus 1. Because it is 1. Here it is 1 by 2. Okay. So 2 plus 1 is, 2 into 1 is 2. 2 plus, that is 3 by 2. 3 by 8. Mu naught I divided by R. Let's take a look at this. Find the magnetic field at point O. Okay? At point O. Now, due to this semicircular wire and this semicircle. So I can say net magnetic field at point O will be due to magnetic field due to 1, magnetic field due to 2, magnetic field due to 3. Now see. What is the direction of magnetic field due to this wire? Place your thumb along direction of current, curl your fingers. Due to this, it is inward. So this is inward. What is the direction of magnetic field due to this wire? Curl your fingers along direction of current, thumb is inward. This is also inward. What is the direction of magnetic field due to this wire? It is also inward. So we say this plus this plus this. Now, what is the magnetic field due to semicircular wire? Mu naught I divided by 4 pi R. And this is the R distance. Plus, due to the semicircle, mu naught I divided by 4R. The difference is you have pi here, you don't have pi here. Plus, what is the magnetic field due to the semicircular wire? Mu naught I divided by 4 pi R. Now you can solve further. This and this becomes twice, then plus this. Magnetic force. Magnetic force. Take a look, boys and girls. Listen carefully. When it comes to the magnetic force, see, if a charge is placed in a magnetic field and is given some velocity v, force acts on it, and that force is what we call the magnetic force. Let's suppose you have got a magnetic field over here. This is the magnetic field B. And in this magnetic field B, this charge Q enters and it is moving with the velocity v. Whenever a charge moving with certain velocity v enters the magnetic field, we say magnetic force acts on it. that magnetic force will be Q into V cross B. This is the force, magnetic force acting on the particle. Okay, you can write it like this also. V cross B means VB sine theta. So magnetic force will be like Q, V, B, then we say sine of theta. This is the magnetic force acting on the charged particle. Where theta is the angle between velocity and magnetic field. Let's suppose if somebody says, sir, what if the charge is at rest? So velocity is rest, meant magnetic force will be zero. So magnetic force only acts on the charged particle when it is moving with certain velocity. When it is moving with certain velocity. Is that clear? When it is moving with certain velocity, in that particular case, we say magnetic force acts. Guys, smash the like button if you're not liked the session yet. Okay. Now, what I want you to understand over here is, so this magnetic force is basically, this magnetic force is basically Q into V cross B, QVB sine theta. Let's suppose if the charged particle, this is magnetic field, this is the velocity. If the charged particle moves along the direction of this, in that case, theta is 0. So sine 0 is 0, magnetic force will be 0. Okay. If let's suppose this magnetic field is acting in the backward direction, this charge is moving in the forward direction. So what is the angle between V and B? 180. So magnetic force will be QVB sine of 180. Sine 180 is also 0. So magnetic force is 0. Okay, magnetic force is 0. Now take a look. A charged particle of specific charge, charge per unit mass, 0.2 Coulomb. There is a charged particle, its Q divided by M is 0.2 Coulomb per kg. So value of Q by M is given, charge per unit mass. So basically on 1 kg charge, on 1 kg mass, how much charge is present? 0.2 Coulomb. 0.2 Coulomb is present on 1 kg. Has a velocity of 2I minus 3j. This charged particle has a velocity of 2I minus 3j meter per second. At some instant in a magnetic field, so magnetic field is also given, that is 5I plus 2j Tesla. Find the acceleration of the charged particle. We are supposed to find acceleration. Guys, see, we say acceleration is force upon mass. Acceleration, value of acceleration is what? Force by mass. Now, acceleration will be force. Whenever the charge is placed in a magnetic field moving with certain velocity, what is the force? Q into V cross B. Divided by, I would say, M. Now, value of Q by M, you already know 0.2. V cross B, you have to find out. Now, see, how do we find the V cross B? We say V vector cross B vector. Cross product of two vectors. How do we basically do the cross product of two vectors? See, we make a determinant. Then we write over here I cap, J cap, and K cap. First, we write the coefficients of V. Why? Because you are doing V cross B, not B cross V. So first, we'll write the coefficients of V. That is 2, minus 3, and 0. What is the coefficient of I over here? 2. Here minus 3, and for K it is 0. Now tell me in this 5. This is 2 and this is 0. Once you got done with the coefficients, then you can write. Now guys, take a look. First you solve it for I. You write over here I. Listen carefully. You need to hide that column and that row in which I is present. So remaining you have to cross. So for the remaining, you have to do the cross multiply. 3 into 0 is 0. 2 into 0 is 0. Then minus J. In front of J, you need to put minus. Now do one thing. Hide that column and that row in which J is present. Now 2 into 0, 5 into 0. This will also become 0. Then plus solve it for K. Now hide that column in which K is present, that row in which K is present. For the remaining, you have to do the cross. 2 into 2 is 4 minus 5 into 3 minus 3 is minus 15. So this is B cross B. So this is 0, this is 0. So minus into minus is plus. 15 plus 4 is 19. So this will be 19 K cap. That is V vector cross B vector. V vector cross B vector is 19 K cap. Now, my dear NEET aspirants, what I want you to understand in this particular case, V cross B is how much? 19 K cap. V cross B is 19 K cap. Now tell me, acceleration will be Q by M. What is the value of Q by M? 0.2 into 19 K cap. Now this acceleration 0.2 into 19, this will be 3.8 K cap meter per second square. This is the answer. Tell me, oh, is this clear? Is this clear? Absolutely. Is this clear? Yes. Yes, yes, yes. Take a look. Take a look, boys and girls. See. Take a look. I told you two cases. This is case 1. When the value of theta is how much? 0. Magnetic field and velocity are in the same direction. Then I told you case 2, in which magnetic field and velocity are opposite. That is theta is 180. In this case also magnetic force is 0. Now, I am telling you the value of case 3. I am telling you the value of case 3. Case 3 is when theta is equal to 90 degrees. Theta is equal to 90 degrees. What does that mean? That means magnetic field is inward. This charged particle is entering the magnetic field. This is the velocity of the charged particle. This is the magnetic field, inward. What is the angle? 90. When theta is 90 between V and B. In this particular case, my dear NEET aspirants, the charged particle moves in a circular path. Whenever the charged particle enters the magnetic field perpendicularly, the charged particle will move in a circular path having radius r. The charged particle will move in a circular path having what radius? R. Okay? Yes. Now, boys and girls, if it is having the radius r, if somebody asks you what is the value of that radius of that circular path, mv by qb. M is the mass of the charged particle, v is the velocity, q is the charge, b is the magnetic field. Okay, this radius in terms of kinetic energy, under root of 2mke divided by qb. Okay, and if somebody says what is the velocity of this charged particle, this will be the velocity of the charged particle, qbr divided by m. And if somebody says what is the time period, all of these expressions are important, like how much time it is going to take in completing one cycle. That is 2 pi m. M is the mass of the charged particle divided by qb. Q is the charge, b is the magnetic field. Okay, absolutely, sir. Absolutely, sir. Take a look, my dear NEET aspirants. I need to show you one thing over here. I need to show you one thing over here. Okay, listen. See, that is this. That is this. A proton and an alpha particle accelerated through same potential difference. Okay. In a region of uniform magnetic field. Basically, there is a region of uniform magnetic field. This. Okay. An alpha particle and proton. This is the alpha particle which enters, it will move in a circular path, because whenever a charged particle enters perpendicularly, it will move in a circular path. This will be having the radius of alpha. This circular path has radius of alpha. And this is a proton. This will also move in a circular path. This will be having the radius of proton. Okay. And when it comes to this, guys, when it comes, this is proton. This is alpha particle. Charge of proton is E. This is having 2E, 2 times charge of proton. Mass of proton is M. This is having 4 times mass of proton. Okay. Now it says having same potential difference in a uniform electric field, their velocity is perpendicular to the field. Compare the radii. You are supposed to find radii of proton divided by radii of alpha particle. First of all, you tell me which formula should I use. See guys, we say R is equal to under root of 2m into kinetic energy divided by QB. Listen guys, listen. Kinetic energy, we also say this is the value of kinetic energy, that is Q delta V. You can directly put it over here. So R will be equals to under root of 2m Q delta V. Directly remember, this is the value of kinetic energy. Kinetic energy is also equal to Q charge, delta V is the potential difference divided by QB. Now, my dear NEET aspirants, we say here, for these two, what is constant? We say they are entering in the same magnetic field, so magnetic field is constant. Potential difference for both is same. Potential difference is same. 2 is also same. So we can say delta V magnetic field, this is same for both. So can I say whatever is constant or same, we eliminate that from the equation? Yes. So this radius will only depend upon under root of m into q divided by q. Mass and charge, because mass and charge both have got different. Now do one thing, make it simple. Multiply with root q, divide with root q. Let's make it a bit simple. So root q into root q becomes q. That q cancels with this q. So this r will be proportional to, in the numerator you have got root m, in the denominator you have got root q. Q divided by m divided by q. Now tell me, what is the radius of proton? Listen guys. Now the radius of proton divided by radius of alpha particle. M divided by q. So mass of this is m, charge is E. M divided by E upon mass of this is, for alpha, mass of this is 2e divided by 4m. 4m divided by 2e. So you can write it like this, a root of m divided by e into. So this will be under root of 2e divided by 4m. Now what you can say in this particular case, m and m will cancel, this and this will cancel. Okay. 2 ones are 2, 2s are 4. 1 divided by root 2. Is this clear? Please do check this from your end. Please do check this from your end. Okay. Now, force on a wire placed in the external magnetic field. Guys, tell me, is this clear? Come on. Now, guys, take a look. Force on a wire placed in a uniform magnetic field. Listen carefully. Let's suppose this is a magnetic field over here in which you have a wire placed, in which current is flowing as I. Length of the wire is L. Now you have to tell me what is the force acting on this wire placed in the magnetic field. Listen carefully. Force will be I into L cross B. L is the length, I is the current, B is magnetic field. L cross B, A cross B is AB sine theta, L cross B will be LB sine theta, where theta is the angle between L and B. This is the force created on the wire placed in the magnetic field. Now see, let's suppose, my dear NEET aspirants, if this is the magnetic field and the wire is placed something like this, how much is the angle between length and magnetic field? 0. If magnetic field and length and 0 angle, then force will be 0 because ILB sine 0, this will be 0. Okay, yes, yes. Now guys, listen to me very, very, very carefully. I need to show you, okay, let's suppose if I ask you what is the direction of the magnetic force. Let's suppose if I ask you what is the direction of the magnetic force. Take a look. When it comes to the direction of magnetic force, boys and girls, listen carefully. When it comes to the direction of magnetic force, we say place your fingers along the direction of magnetic field. Place your fingers along the direction of magnetic field. Okay. So I'm placing my fingers along the direction of magnetic field and thumb along the direction of current. Thumb along the direction of current. And this palm, it is facing towards left. So this gives you the direction of magnetic force. Place your fingers along the direction of magnetic field and thumb along the direction of current. Palm gives you the direction of magnetic force. Take a look. Take a look. See guys. See guys, force on a wire placed in a uniform magnetic field. Force on a wire placed in a uniform, okay, this is what I have studied. Okay, take a look at this question. You have got two diagrams over here. In this particular case, my dear NEET aspirants, you have to tell me what is the force in each case. See. When it comes to the force in each case, I want you to understand this very carefully. Guys, listen carefully. Listen carefully. I want you to understand this very carefully. Okay? Okay? Now guys, see, take a look. Take a look. In this particular case, guys, see, you have to tell me what is the force on this loop and what is the force on this loop. This loop is placed in the magnetic field. This loop is also placed in the magnetic field. Directly remember. If the direction of the current in the entire loop is 1, like this is the direction, this is clockwise. So here net force on the loop will be 0. Directly remember. I can prove it also, but directly remember. In this case, direction is here clockwise and direction here is anti-clockwise. So here net force cannot be 0. Now listen, how can we find the net force? See. In this particular case, my dear NEET aspirants, we say force is F is equal to I L B sine of theta. Theta is 90 over here. Why? Okay, let's write theta initially. Now in this particular case, we'll find the force on this segment and this segment. Let's consider the upper part. Force on this portion. Now my dear NEET aspirants, current is flowing in this segment. Could you please tell me, sir, what is the effective length of the segment? Effective length is join initial point with final point. This is effective length. Now, if this is R, this is R. What is L effective in this particular case? That will be 2R. Now, This is the direction of the current in the L effective, because see, direction of current is like this from A to B. If this is A, this is B, from A to B. Here also you need to make from A to B. So in this particular case, what I can say over here is, listen carefully, what I can say over here is force will be, that is I, L. L in this particular case is 2R. And then, my dear NEET aspirants, magnetic field is B. And then we say sine of 90. Why? Because this effective length and magnetic field is inward. This is forward. They are having the angle 90. That's why sine 90. So force will be I, 2, B, R. Let's find the direction of force. How do we find the direction of force? Place your fingers along the direction of magnetic field. Thumb along the direction of current. Palm is facing upwards, so force on this will be upward. So means force on this portion will be upwards. Okay, absolutely, sir. Let's find the force on this portion of the wire. This portion of the wire. And what is the length of this portion? In this particular case, length itself is, that is 2R. So force on this portion will be, again, 2IB into R. That is sine 90. Because this length. Now, what is the direction? Again, place your fingers along direction of magnetic field, thumb along direction of current, palm is facing upwards. On this portion also force will be upwards. Could you please tell me what is the net force on this one? That is 2 times of F. 2 times of, what is the value of F? That is 2IBR. So this will be 2 into, what is the value of I? Current in this case is given as 2 ampere. Magnetic field is 1. Radius is 1. So this is 2. This magnetic field is 1. Radius is given as 1. So this is 1. Now tell me 2 into 2 is 4. 4 into 2 is 8. So it is going to be 8 Newton. Is this clear? Oh? So when the direction of the current is like this, that is clockwise only or anti-clockwise only, in that case net force will be 0. Here net force is not 0. Very important question. This one. This is a very important question. Very important question. Okay. Yes. Take a look at this. Take a look at this. Now guys, listen carefully. The magnetic field existing in a region is given by, this is the magnetic field existing in a region. And this magnetic field is varying with X, okay? A square loop of edge L is carrying current I. This is a square loop, okay? Find the net magnetic force experienced by the square loop. You have to find the net magnetic force experienced by the square loop. Now, if there is a student saying, sir, direction of the current is unique over here. It is anti-clockwise only. So can we consider the magnetic force 0? No. Why? Because magnetic field here is variable. That is only true in which case where magnetic field is constant. Here magnetic field is constant. In this particular question, magnetic field is not constant. Okay. First of all, let's find the magnetic field here. What is the value of X here? 0. So we say at X is equal to 0. What is the value of magnetic field? Sir, magnetic field will be, this is B naught. Put X is equal to 0. 0 by 0, 0 by 0. This entire term is 0. So 0 into this, it will be 0. So magnetic field is 0. If magnetic field is 0, what is the force on AB portion of the wire? What is the force on this? Because here magnetic field is 0. Magnetic field is variable. So what is the force on this portion? That will be 0. Force on this AB wire is 0. Okay. Let's find the force on this wire. Listen. Let's find the direction first. Place your fingers along the direction of, magnetic field. Okay. Okay. Yes. So place your fingers along the direction of magnetic field. Thumb along the direction of current. Okay. Palm is facing downwards. Okay. In this particular case, place your fingers along the direction of current. Listen carefully. Let's find the force here. Place your fingers. Magnetic field is outward. Place your fingers along direction of magnetic field. Thumb along the direction of current. Palm is facing downwards. So force on this will be downward. Let's find the force on this. Place your fingers along direction of magnetic field. And thumb along the direction of current. Palm is facing upward, so force on this is upward. Now, the amount of force acting on this will be the same amount of force acting on this. So this force will be cancelled with this force. So force on these two net will be 0. So this will be cancelled with this. Now, at x is equal to L. Now this from here to here distance is what? L, because it is mentioned L. What is the magnetic field? B naught L by L plus L square by L square. This 1 plus 1 is 2. So this will be 2 times of B naught. So at this distance, magnetic field is 2 B naught. So what is the force on CD wire? So force on CD wire, my dear NEET aspirants, will be, that is I L B sine theta. Sine is 90 because angle between this L and magnetic field, that is 90. So this will be I L. Instead of B, I can write 2 times of B naught. So this will be force on CD. Now guys, this is going to be the net force. Why? Because force on this portion of the wire is 0. Force on this portion of the wire is cancelling with the force on this portion of the wire. So only the remaining portion is this. So force on this portion is 2L IL 2B naught. That will be the net force. Please tell me, is this question clear? Please tell me if this question is clear. Come on guys, tell me quickly tell me in the chats if this is clear. Tell me guys if this is clear. Smash the like button if you're not like this session. Come on, do it quick. Okay, this is also called force between two parallel wires. See guys, let's suppose this is having a wire infinitely long. Current in this is I1. This is another wire, its length is L. It is finite. Its current in this is I2. Distance between the two is R. If I say, will the two wires apply force on each other? Yes. If the direction of the current is here I1, here I2, we say the two wires attract each other with a force. Now, what is the force on this wire? Sorry, what is the force due to this wire on this wire? Mu naught I1 I2 divided by 2 pi R into L. This is the force due to this wire, infinite, on this entire wire. Okay. What is important here is force per unit length. Force due to this wire on the unit length of this wire. That will be F divided by L. That will be mu naught I1 I2 divided by 2 pi R L divided by L. That is force. This is the total. Guys, this is the total force acting on the second wire due to the first wire. If I say what is the force on the unit length, that is mu naught I1 I2 divided by 2 pi R. Listen carefully. Listen carefully. I'll make you understand. Let's suppose this is a wire. I1 current is flowing. This is a wire. I2 current is flowing. Directly remember. The two wires attract each other with a force. Okay. And if distance is, let's suppose D. If somebody says what is the force per unit length between the two, that is how much force this wire is applying on its unit length, how much force this wire is applying on its unit length. So that will be F is equal to mu naught I1 I2 divided by 2 pi into D. Sir, is this the force on the entire length of this wire? No. This is the force on the unit length of this wire. This is the force on the unit length of this wire. Keep that thing in your mind. Okay. Sir, if they ask us to find the force on the entire wire, in that particular case, my dear NEET aspirants, I would say one wire has to be infinite, another wire has to be finite, then the force on the second wire due to first will be this mu naught I1 I2 divided by 2 pi r into L. Into L. Take a look. There is a question which was given. This is the question which was given in NEET 2017. See, you have got three wires. Let me make it over here. This is B. This is C. This is A. So basically, this is the wire coming out of the board. This is the wire coming out of the board. This is the wire coming out of the board. Sure. Current flowing in this wire is I. In this wire is I. In this wire is I. This is distance D. This is distance D. Now, I can say, you have to tell me in this particular question, what is the magnitude of force per unit length on the middle wire? On this wire, what is the force per unit length due to other two? Guys, see. Whenever you have two parallel wires, they attract each other with a force. So this is going to apply the force on this in this direction, that is F. This wire is going to apply the force on this, that is F. The resultant of this and this will be something like this, that is a root 2 of F. Resultant of this and this is going to be root 2 of F. Now, my dear NEET aspirants, what I want you to understand, so in this particular case, net force will be root 2F. Now see, in the question also they are asking us force per unit length, not the entire force. Now tell me, this root 2 will be, root 2 into F, F will be force between the two, mu naught, I1, I2. What is the current here? I and I. This is I square divided by 2 pi into, what is the distance between the two? That is D. That is D. Now do one thing. Multiply with root 2 and divide with root 2. Root 2 into root 2 is 2. So this 2 will be cancelled with this 2. So answer is mu naught I square divided by a root 2 pi into D. Mu naught I square divided by root 2 pi into D. Option A is matching. Okay, yes. Now you have moving coil galvanometer. Okay. Is this clear till over here? Tell me. Is this clear? Is this clear? Tell me, boys and girls, is this clear? Moving coil galvanometer. What does moving coil galvanometer actually do? Now see. Galvanometer is basically, see. Galvanometer is basically a device which is used to measure the current. How does it actually measures the current? That is what we are supposed to see over here. See guys, listen carefully. This is the construction of a galvanometer. You have got over here a magnet. You have got another magnet over here. And you place a coil here. You place a coil over here. Okay. And there is a jockey attached to this magnet. There is a jockey attached to this magnet. Yes. Now, my dear NEET aspirants, what I want you to understand in this particular case, directly. We say when the current flows through the coil, okay, when the current flows through the coil, listen to me very carefully. When the current flows through the coil, then my dear NEET aspirants, this coil which is placed between these two magnets means this coil is placed in a magnetic field. When the current flows through this coil, which is placed in the magnetic field, so this coil rotates due to the current. Listen carefully. What I'm trying to say is that I will tell you how does galvanometer measure the current. When this is a galvanometer, this galvanometer is made up of a magnet, north pole, south pole, bar magnet it is. In between these two magnets, you have got a coil placed and there is a spring connected to this coil and a jockey. Jockey shows the reading 10 ampere, 15 ampere, 30 ampere. Now what I'm trying to say is that when current flows through the coil, due to that current, it will rotate the coil. Okay, when coil rotates, due to that rotation of the coil, this jockey is connected, this jockey also rotates. Now, my dear NEET aspirants, if you send more current through the coil, we say more it is going to rotate, more torque will be produced, it will rotate more. It is going to rotate the jockey more, it will show you large reading. Obviously, if current is more, rotation in the coil will be more. Rotation in the coil will be more, jockey will rotate more, it will show you more reading. So, my dear NEET aspirants, listen to me very carefully. We say this is the equation that you need to remember over here. This is what we call the equation of moving coil galvanometer. Directly see. C is the helical spring constant, this torsional constant. Listen carefully. This is a spring over here. I will show you. Guys. See. When the current flows through the coil, due to that current, this coil will rotate and a torque is produced in the coil. Torque in the coil will be NIAB. Due to this torque only, it is going to rotate the jockey. Because when there is torque, there will be rotation. N means number of turns in the coil. Okay, number of turns in the coil. I means current. A means over here area. And this B, I can say in this particular case, this is magnetic field. This is magnetic field. Okay, this is the magnetic field. Now, my dear NEET aspirants, due to this torque, now see, if the current is large, torque will be large. So this is going to rotate more. Now, when the jockey rotates, then the helical spring is basically used over here. This when the jockey rotates, it shows you the 10 ampere reading. Now, if the current is removed, the jockey should come back to the original position. No? So how is the jockey going to come back to the original position? Because you have used the helical spring. This helical spring is going to create restoring torque. So this is the torque restoring. And this restoring torque is equal to C theta. See, due to this torque, it is going to show the reading. It is going to take the jockey forward. Due to this restoring torque, it is going to bring the jockey back. So C is what we call helical spring constant. C defines the stiffness of the spring. If the spring is having large C, means it is very difficult to rotate the spring. Strong spring. If C is less, it is easy. We can easily rotate the spring. Theta means how much deviation is done. So now, guys, let's suppose due to this torque NIAB, the jockey moves forward. Let's suppose its value is 10. Now, if you want to bring the jockey back, then the value of this restoring torque must be also 10. If you keep it 9, do you think it is going to bring it back? No, it has to be equal to 10. So that's why we say restoring torque has to be equal to this NIAB. This is called equation of moving coil galvanometer. Is this clear? Oh, is this clear? So basically, when current flows through the coil, torque is produced in the coil. How much? NIAB. Large is the current, large will be torque. It shows you more reading. Now, to bring the jockey back, we use this helical spring. It creates restoring torque, that is C theta. Okay. Now, we define two things over here. Current sensitivity and galvanometer sensitivity. Listen carefully. How do we define current sensitivity and galvanometer sensitivity? Current sensitivity and voltage sensitivity. See. We say current sensitivity. SI, it will be equals to theta divided by I. Now we say as C theta is equal to NIAB. Could you please tell me theta will be equals to NIAB divided by C? Put it over here. So SI will be equals to, instead of theta, I can write NIAB divided by C into I and I will cancel. So galvanometer sensitivity will be NAB divided by C. So basically, sensitivity of the galvanometer means how much sensitive the galvanometer is. Means even if you send very small currents, it can still measure those currents. That is what we call sensitivity. It is very sensitive. It has got very large sensitivity. It can even measure very small currents. We say this person is very sensitive. What does that mean? So we cannot play with that person because he gets angry on small things. We cannot crack a joke with him. Similarly, sensitivity is large means this galvanometer is a good galvanometer. It can measure even very small currents. Now see, in this particular case, this sensitivity is directly proportional to number of turns, area, magnetic field, inversely proportional to the C. Now, one more important thing we discuss over here, voltage sensitivity. Voltage sensitivity of galvanometer is, it is theta divided by V. Okay. So we say C theta is equal to NIAB. Okay. Now from here, what is the value of current? Could you please tell me? This is C theta divided by NAB. Now can you tell me V is equal to I into R? You can say V is equal to, what is the value of I? C theta, and then we say R divided by NAB. Okay. Now put it in this one. Put it in this one. So SV will come out to be theta divided by, instead of V, C theta R divided by this NAB that I can take in the numerator. Theta and theta will cancel. SV will come out to be NAB divided by CR. Now tell me, NAB divided by C. NAB divided by C is SI. So this SV will come out to be SI divided by R. This is the relation between voltage sensitivity and current sensitivity of the galvanometer, where R is the resistance of galvanometer. Where R is the resistance of galvanometer. Okay, now there is a question over here. The current sensitivity of a moving coil galvanometer is 5 division per milliampere. SI is given as 5 diV per milliampere. Guys, if you want to convert this to the ampere, how can you do it? 5 diV. So milliampere means 10 raised power minus 3 ampere. Take this in the numerator, it will become 10 raised power plus 3, that is 1000. So this is going to be 5000 diV per ampere. Okay, voltage sensitivity of a galvanometer is given as 20 diV per volt. So it says the resistance of the galvanometer is, we say SV is equal to SI divided by R. R is equal to SI divided by V. SV. SI is 5000. SV is 20. This is going to be 250. 250. Okay. In order to increase the sensitivity of a moving coil galvanometer, sensitivity of a moving coil galvanometer is theta divided by I, which is equal to NAB divided by C. In order to increase the sensitivity of a moving coil galvanometer, one should decrease the strength of the magnet. If we decrease the strength of the magnet, sensitivity will decrease. No. Torsional constant of its suspension. If we decrease the torsional constant, this is going to increase. Yes. The number of turns in the coil. If you decrease number of turns in the coil, sensitivity will decrease. No. Area of the coil. If you decrease area of the coil, sensitivity will decrease. No. So which option is correct? Option B. I hope you got the feeling in this particular case. How does a moving coil galvanometer actually work? So basically, moving coil galvanometer, you have got a magnet in which a coil is placed. So through this coil, current flows. When the current flows through the coil, it rotates in this magnetic field, due to which this jockey also rotates. It shows you the reading when it is deflected. Now to bring the jockey back, we use this helical spring. So this creates the restoring torque. So this restoring torque has to be equal to the torque which brings the which takes the jockey forward. So that's why we say this is called the equation of moving coil galvanometer. Guys, please tell me in the chats if this is crystalline clear. Tell me, oh, is this clear? Next chapter we have EMI. Is this clear? Tell me. Is this clear? Yes, we are going to take a break, but before that you need to tell me, is this clear? Is this clear? Is this clear? Tell me in the chats, everybody out there. Tell me. Yes, we'll take the break. In just a second, let it complete. Okay, we'll do the solenoid also. Don't worry. We'll do the solenoid also. Okay. Chill, take a chill pill. Don't worry. We will do the solenoid also. Okay. Just a second. No, don't leave. Don't leave. I'll tell you something. Just a second. Wait. Guys, let's finish the solenoid in 5 minutes since a lot of students are requesting over here. Solenoid. 5 minutes, just 5 minutes, then we'll take the break. We'll take the break till 6. See guys, solenoid. This is a coil. That is what we call solenoid. Okay, like heat recoil. This is a solenoid. Current in the solenoid is I. So whenever the current flows through the coil, it produces the magnetic field. So here magnetic field is produced along the axis of the solenoid, something like this. This is the magnetic field produced along the axis of the solenoid. So when current flows through this solenoid, magnetic field is inside. If I say magnetic field inside the solenoid, listen to me very carefully. We say it is mu naught N into I. Okay, what is N? N means number of turns per unit length. Per unit. Number of turns per unit length. Okay. How many number of turns are present on the unit length? That is small n. And we can write this number of turns per unit length as total number of turns divided by total length also. Okay. Per unit length. So we can write it like this also. N is equal to total number of turns. Okay. Total turns divided by total length of the solenoid L. So you can say this B inside is also equal to mu naught Ni divided by L. These are the two formulas that we study in the solenoid. And one more important thing, if I say this is the magnetic field inside the solenoid, if I say magnetic field at the ends of the solenoid, that will be whatever is the magnetic field inside, its half will be at the ends. So that I can say magnetic field at the ends of the solenoid, that is mu naught Ni divided by 2. You can write it like this. Now, if somebody says, can you plot the graph? Can you plot the graph? Guys, see, at the center, this is the center of the solenoid. From the center to this means inside. From here to here, this is considered to be the ends of the inside the solenoid. This is out. This is the ends. These are the ends of the solenoid. At the ends of the solenoid, magnetic field is going to decrease. Okay. At the ends of the solenoid, magnetic field is inside, it is going to remain the constant. This is inside. Inside, magnetic field is constant. Outside, it will be half. Outside, it will be half. Okay. Then you have toroid. See guys, toroid means, let's suppose this solenoid. If you basically make this solenoid of a circular shape, you turn the solenoid and make it in a circular shape, it becomes toroid. This is what we call the toroid. It is an endless solenoid also. This is what we call the toroid. And my dear NEET aspirants, from here to here to its center, we say radius is R. Now, if this toroid is made from the solenoid also, if this toroid, I'll give you the break, 2 minutes. If this toroid is made from the solenoid also, so we can say magnetic field of this toroid will be same. Mu naught, I can say Ni divided by L. But here, L means the length of the solenoid. Here, length of this toroid is 2 pi r. Array circumference na. What is the length of this toroid? 2 pi r. So here magnetic field is going to be mu naught Ni divided by 2 pi into r. Now guys, take a look. Let's suppose if I say, sir, this radius till here, it is R1, and a radius till here, till the outer end. Here, this is R2. Guys, this is the general radius I am taking. That is R. So this is called inner radius. This is a tube-like structure. Till here, it is called R1. Till here, it is called R2. So I can say magnetic field is inversely proportional to R. So till here R is less. So here magnetic field is large, here magnetic field is less. So if I say B maximum is going to be mu naught Ni divided by 2 pi R1. If I say magnetic field minimum, it is going to be mu naught Ni divided by 2 pi into R2. So this is the entire discussion of toroid and solenoid. So let's see the chapter. EMI, I would say, let's take a break. It is that is 5:55. Break till, I can say, it's 5:14. Let's take 6 p.m. Okay, next chapter after the break. Yes. And we'll take 3 more hours, okay? Now, guys, let's move on to the electromagnetic induction. Let's move on to the electromagnetic induction. The very first topic, the very first topic that we need to discuss over here is that is magnetic flux. Okay, first one is magnetic flux. What does the magnetic flux actually mean? Magnetic flux simply means it is the number of magnetic field lines passing the surface perpendicularly. Like in this particular case, we say how many number of magnetic field lines are crossing? I would say 2. These magnetic field lines, maybe because of some magnet, these magnetic field lines are coming out and these are crossing the surface. And here, how many magnetic field lines are crossing through this surface? I would say 3. So here magnetic flux is 3. Okay, yes. Whenever field lines cross through the flux, we say magnetic field will be produced. Now we say this magnetic flux is actually equal to, that is B. Phi B means magnetic flux. We represent it with phi B. That is B A cos of theta. This is what we call the magnetic flux, B A cos theta. Or we also call it, this magnetic flux will be simply, that is B dot A. Because AB cos theta is A dot B. B dot A means BA cos theta. Now, boys and girls, take a look exactly over here. Take a look exactly over here. Current I flows through the ring. Find the flux through the square loop placed at the center. This is a circular ring in which current I is flowing. There is a square loop placed at the center. Guys, see. Everybody knows that, sir, this ring is going to create the magnetic field. Now, if I ask you what is the direction of the magnetic field at the center, this is the direction of magnetic field at the center, outwards. Okay. So basically, sir, magnetic field at the center is outwards. And how much is the magnetic field due to a ring? Sir, that is mu naught I divided by 2r. We have studied this. Due to a ring, magnetic field at the center is mu naught I by 2r. This magnetic field is crossing the area of this loop. And what is the area of this square loop? It is always perpendicular to the surface. This is the area. So area of the square loop is side square, that is L square. What is the angle between area and this magnetic field? Magnetic field is also outward. If this is a board, what is the direction of the area of the board? Perpendicular to the board. So theta in this case is, I would say, 0. What is going to be the flux through this? Flux through this will be magnetic field crossing through this. That is mu naught I divided by 2r. Okay. That is B. What is flux? Flux is BA cos theta. A is L square and then we say cos of 0. So magnetic flux in this case will be mu naught I into L square divided by 2r. Next. Now, the reverse of this. Let's suppose, my dear NEET aspirants, you have got a square loop. At the center, you have placed a ring. Now, in this square loop, current is flowing. Current is flowing. Now, my dear NEET aspirants, could you please tell me, in this particular case, what is going to be the flux? Flux will be simply magnetic field into area. Cos 0, cos 180, it will be one and the same thing. So, magnetic flux. Now, here, in this particular case, magnetic field will be produced by the square loop. Tell me, what is the magnetic field due to the square loop at the center? This also I have told you 2 root 2 mu naught I divided by pi into L. Then, this magnetic field which is being produced at the center, what is the direction? Place your fingers along the direction of current, or like this. Place your fingers along direction of current, curl your fingers inward. Here also inward. So magnetic field in this particular case is inward. So this magnetic field is crossing the area of this loop. What is the area of this loop? That is pi into r square. What is going to be the flux? Flux will be 2 root 2 mu naught I divided by pi into L, and area is pi r square. Area is pi r square. This is going to be the magnetic flux in this particular case. Lenz's law. Lenz's law. Let's see what does Lenz's law actually mean. My dear NEET aspirants, let's suppose this is a magnet over here. This is a magnet over here. Listen carefully. Sorry, this is a ring over here. And you have a magnet over here. When you take this magnet close to the ring, okay, means, guys, see, because of this magnet, magnetic field lines are coming out. When you take this magnet close to the ring, more number of field lines are crossing through the ring. This is a ring. When you take the magnet close to the ring, more number of field lines are crossing the ring. When you take the magnet away from the ring, less number of field lines are crossing through the ring. Okay. So we say, due to this change in magnetic field through the coil, current starts flowing in the coil. Whenever you change the magnetic field or magnetic flux through the coil, current starts flowing in the coil. Now, if somebody says, what should be the direction of that current? Direction of that current is basically given by Lenz's law. How does the current flow in the coil? Whenever you change the magnetic field through the loop, this is a loop. If you take the magnet close to the loop, more number of field lines are crossing the loop. Current starts flowing. If you take the magnet away from the loop, less number of field lines are crossing through the loop. So current starts flowing. Now, if somebody says, what is the direction of that current? Direction of that current is given by Lenz's law. See, if the magnetic field through the coil increases, okay, if you take the magnet close to the coil, means magnetic field will increase. Current in the coil will oppose the magnetic field. Current in the coil will be in such a way so that it opposes the magnetic field. I will show you, wait. And if the magnetic field is decreasing through the coil, then current will support the magnetic field. Let me show you how. Let's take a look at the question. So basically, current will oppose the increasing magnetic field and current will support the decreasing magnetic field. Okay? Yes. Yes. Now, boys and girls, take a look. What I want you to understand in this particular case is, magnetic field here is decreasing. You have got a coil in this one. Listen carefully. This is called a primary magnetic field. Primary magnetic field is increasing. Okay. Now, guys, see. We say, listen to me very carefully. Current in this coil is, let's suppose I would say in this direction. Assume for a second, current in the is clockwise. I'm saying current in the coil is clockwise. Okay. Sir, how is the current being produced? Because whenever the magnetic field through the coil changes, either increases or decreases, current is produced. Now, I'm assuming the current is clockwise. Now, due to this current, whenever the current flows through the coil, another magnetic field is being created. So that is, because of this current, I would say secondary magnetic field is being created at the center. And that will be, could you please tell me what is the direction of that secondary magnetic field? Curl your fingers along direction of current, thumb is pointing inwards. So here it will be inwards. This is B secondary. So B secondary in this particular case is inwards. Okay. And this B primary is outwards. Now you tell me one thing. If primary magnetic field is increasing and the direction of primary magnetic field is outward, and it is increasing. And in this particular case, you are saying that the current in the coil is clockwise. If the current in the coil is clockwise, due to this current, one more magnetic field is being produced, that is secondary magnetic field. Now, this secondary magnetic field is basically opposing the primary magnetic field. Why? Because primary magnetic field is outward, secondary magnetic field is inward. So means direction of the current is correct. Now, let's suppose if I assume the direction of the current is ACW, anti-clockwise. So what does that mean? That means the secondary magnetic field produced by the current will be also outward. So outward. This is also outward. It means you are supporting the current. But what does Lenz's law say? The current should be in such a way so that it opposes the increasing magnetic field. Listen to me very carefully. What I want you to understand in this particular case, boys and girls. See. If I say, listen guys, if I say if I say, let's suppose this is the magnetic field over here. This is the magnetic field over here. This magnetic field is decreasing. In this decreasing magnetic field, you are placing a coil. Okay? Yes. Now, if you want, see guys, if the primary magnetic field is towards the right, secondary magnetic field, if it is towards left, means it is opposing. If secondary magnetic field is also towards the right, it means it is supporting. Now tell me here. If primary magnetic field is decreasing, we say primary magnetic field is inwards and it is decreasing. Now, in case of decreasing magnetic field, Lenz's law says that current must flow in such a way so that it opposes the decreasing magnetic field. So we say B secondary has to be inwards also. Yes or no? Because Lenz's law says that you must support the decreasing magnetic field. So how is this possible that the secondary magnetic field must be, I would say, inwards, when the direction of the current in the coil is, I would say, clockwise? Now, curl your fingers along the direction of current, thumb is pointing inwards. So then only secondary magnetic field is going to be, I would say, inwards when current is clockwise. I believe this is crystalline clear. I believe this is crystalline clear. Yes. Now take a look. Find the direction of the induced current. This is the wire over here. There is a coil placed. This is the coil placed. This is the magnetic. This is a current. Now see, because of this current, could you please tell me what is the direction of the magnetic field at this point? This is going to be outward. How do we find the direction? Place your thumb along direction of current, curl your fingers. Due to this, magnetic field at this point is going to be outward. Okay. This is what we call primary magnetic field. If primary magnetic field, my dear NEET aspirants, is outward, okay, and since this is increasing current, so this magnetic field will be outward and it is increasing. What about the secondary magnetic field? Sir, secondary magnetic field must oppose the increasing magnetic field. That has to be inwards. So how is it possible that B secondary is inwards? When the direction of the current in the coil is clockwise. When the direction of the current is clockwise. I believe this is crystal and clear to each and every single student. Okay. Yes. This I'll give you as homework. I would want you guys to do it from your end. This I will show you. This is the region of uniform magnetic field. B is uniform. Means it is not changing. See, since the coil is moving, when the coil is outside, no field line is crossing. So current at point A in the coil will be zero. No current flows. Because current in the coil only flows when there is change in magnetic field. No magnetic field is changing over here. So current is zero. What about this? At point B, the coil is going in. So means field through the coil is increasing. As it keeps on going in, more field is increasing through the coil. So we say at B, point B, magnetic field. Okay, here. We say magnetic field primary. This is the primary magnetic field. It is inwards and it is increasing. Okay. So can I say B secondary at this point? B secondary at this point has to be outwards because we must oppose the primary magnetic field. How is that possible when the direction of the current in the coil is anticlockwise? So current is anticlockwise. Boys and girls, when this is going in, at that point of time, we say more field lines are crossing. So magnetic field will increase. So inside, we say it is now placed inside. So magnetic field lines inside is constant. Magnetic field through this coil is constant. So current is zero because current is only produced when magnetic field either increases or decreases. While it is coming out, we say primary less number of field lines are crossing. While it comes out, so field lines through the coil will decrease. So primary magnetic field is inwards and is decreasing. So can I say secondary magnetic field must support it? That must be also inwards. How is that possible? That is only possible when the direction of the current is, I would say, clockwise. Okay, Curl your fingers, thumb is pointing inwards. So secondary will be then inwards. So this is the direction of the current over here. One more important question that you need to understand in this one, that is this. This is a coil, okay? This is the observer. This is the observer. Guys, this is a coil. This magnet is moving with the velocity v. Always remember, always remember. Whenever coil moves away from the coil, whenever magnet moves away from the coil, this coil will try to attract this magnet. Listen to me very carefully. This coil will try to attract this magnet. So this is the south pole, this is the north pole of the bar magnet. It will create north pole from this side, south pole from this side, because then only it is going to attract this, unlike poles attract. And if the magnet is coming close to this coil, it is going to repel it by creating the imaginary bar magnet. So north from this side, south from this side. Boys and girls, if the magnet moves away from the coil, this coil will try to attract this magnet by creating an imaginary bar magnet. North from this side, south from this side, because then only it is going to attract. If the coil moves close to, if the magnet moves close to the coil, it is going to create an imaginary bar magnet. North from this side, south from this side, then only it is going to repel. Now, listen to me very carefully. If I say, if the observer sees the north pole in the coil, if the observer is facing the south pole in the coil, if the observer sees south pole in the coil, then current in the coil is clockwise. Then this is the sign convention you guys are supposed to remember. Then in this case, current is clockwise. If the observer faces south pole, not this one, not in this, but in this, if the observer faces the south pole of this bar magnet, imaginary bar magnet, then current is clockwise. If the observer is facing the north pole, because south pole is from other side, then current in this case is anti-clockwise. Like, let's suppose there is one more question of the same pattern. This is the observer over here. This is a north, this is south, it is moving towards this. If this coil is moving towards this coil, if this magnet is moving towards the coil, it will create an imaginary bar magnet, north, south. Here, south, north. Sorry, here, north, south, because this will try to attract, this will repel. Now, this observer is facing north, current is anti-clockwise. This observer is facing north, current is anti-clockwise. Oh. I believe this is crystal and clear. Electromagnetic, Faraday's law of electromagnetic induction. See, what does Faraday's law of electromagnetic induction say? Take a look. When it comes to the Faraday's law of electromagnetic induction, it states that the magnitude of induced EMF in the circuit is equal to the rate of change of magnetic flux through the coil. Now guys, see. Let's suppose this is a coil. Let's suppose this is a coil. Okay. You are taking this magnet close to the coil, away from the coil. When you are taking this magnet close to the coil, let's assume we say magnetic flux changes. So we say if you take the magnet close to the coil, magnetic flux changes. Okay. Due to this change in magnetic field changes, magnetic field through the coil changes. If magnetic field changes, it means magnetic flux changes. If magnetic flux changes, it means current is produced in the coil, because we know whenever flux through the coil changes, current is produced. And when there is current in the coil, we say there will be EMF. EMF means potential difference V. According to Ohm's law, we say V is directly proportional to I. When there is potential difference, there will be current. Without potential difference, current cannot flow. So means there is EMF, there is potential difference. So basically what I'm trying to say is that by changing the magnetic field, flux changes. When flux changes, current is produced. When current is produced means EMF is there. So can I directly say, my dear NEET aspirants, by changing this flux, change in flux means d phi by dt. We say directly EMF is being produced. Array, sir. Oh. This is what we call Faraday's law of electromagnetic induction. Whenever flux through the coil changes, EMF is being induced in that coil. EMF means potential difference. And this EMF will be minus d phi by dt. This minus is because of the Lenz's law. Lenz's law says that if the primary magnetic field is increasing, you guys are supposed to support it. If the primary magnetic field is decreasing, then you guys are supposed to oppose it. Support it. In case of increasing, oppose. In case of decreasing, support. Now take a look. If I say instantaneous EMF, that will be d phi by dt minus d phi by dt. If I say, okay, this magnitude d phi by dt, average EMF, that is delta phi by dt. Instantaneous EMF means if through this coil EMF is being produced continuously at a particular instant, how much EMF is being induced, that is called instantaneous. So between this time and this time, how much EMF is being induced, that will be the average EMF, delta phi by delta t. Okay. One more important thing. If there is EMF, there will be current, average current. Average current will be average EMF, okay, divided by resistance. Array, I is equal to V by R, Ohm's law. Average EMF divided by this resistance. Now tell me, average EMF, that is delta phi divided by delta t multiplied by R. This is the current. Instantaneous EMF, that is d phi by dt into this R. D phi by dt into this R. And this is also, when current flows through the coil, this is the charge which is being flown through the coil. Okay? When we say current is flowing through the coil, what does that mean? It means charge is flowing through the coil. This is the charge, that is delta phi divided by R, change in flux divided by resistance of the coil. So basically, whenever flux through the coil changes, EMF is being induced. Let's suppose flux through this coil is changing continuously from 9 a.m. to 1 p.m. So EMF will be produced continuously from 9 to 1. If I say how much is the EMF produced at 11:30 exactly, that is called instantaneous EMF at a particular time. How much is the EMF induced from 9 to 1? That is average EMF. And when EMF is being produced means current is flowing. This is the average current flowing. This is the instantaneous current flowing. This is the charge flow. Please tell me if this is clear. Is this clear? Smash the like button if you're not liked the session yet. Is this clear? Yes. Now guys, take a look. Radius of a circular loop placed in a uniform magnetic field is increasing at a constant rate r0 meter per second. This is a circular loop which is placed in a uniform magnetic field, B. And its radius is increasing, means the ring is getting bigger every time. So my dear NEET aspirants, at what rate? So basically dr divided by dt is given as r0 meter per second. Means every second, how much radius is increasing? Every second, how much radius is increasing? R0. If I say dr by dt is 2, so that means every second it is increasing by 2 meters. 2 meters. If at any instant radius is r, then find the EMF induced. It says, now guys, tell me one thing. If the radius of this is getting bigger, more field lines will cross. If more field lines will cross, so field lines will change, so flux will change. When flux changes, EMF is being induced. So that EMF will be minus d phi by dt. So that you can write minus d divided by dt of what is flux? That is magnetic field into area. Cos theta, cos will be 0. Now what is magnetic field in this case? That is B. So this will be d divided by dt of, this is B, and area. What is the area of this loop? That is pi r square. So what I can say in this particular case, boys and girls, take this B out because magnetic field is given as constant uniform. Pi is also out. Then I can say dr square divided by dt, differentiation of r square with respect to t. Now do one thing. Multiply with dr and divide with dr. Why are you doing this? Because I cannot differentiate this r square with respect to time. Now interchange this and this. So it will be minus b pi dr square divided by dr into dr divided by dt. Now you can differentiate this r square with respect to r. So you can write over here minus b pi. What is the differentiation of r square? That is 2r. What is dr by dt? That is given as r0. So what you can write over here, that is 2 minus 2 pi b r r naught. This is the value of EMF. Okay, let's talk about this, my dear NEET aspirants. A conducting ring of radius r is placed perpendicularly inside a time varying magnetic field. Okay. So basically there is a ring. It is placed in a time varying magnetic field. It is placed inside a time varying magnetic field B naught plus alpha T. Okay. Now magnetic field is increasing and a radius of the ring is r. EMF induced in the ring will be, we can say, sir, this magnetic field is changing. Whenever magnetic field through the ring changes, EMF is induced. So this EMF will be simply minus d phi divided by dt. So this will be minus d divided by dt of phi is what? Magnetic field into area. Now, can I write this as minus d divided by dt? What is the value of magnetic field over here? That is B naught plus alpha t. Okay, and area. What is the area of this ring? That is pi r square. Area of this ring is pi r square. So you can say in this particular case, pi r square, r is constant. Radius of ring right now is not changing. That was in the previous question. So take this minus pi r square common. Now differentiation of B naught is constant. Okay, where this B naught and alpha are constants. Differentiation of B naught is 0 and differentiation of alpha t is alpha. So it will come out to be minus pi r square into alpha. This is going to be the EMF in this particular case. Is this clear? Tell me, guys. Is this clear? Is this clear, boys and girls? Let's move on to the chapter 6, that is alternating current. Chapter 6, that is alternating current. Okay. Array, alpha is also constant, bro, but alpha is in yeah. When the constant is in the addition, its differentiation is 0. When the constant is in the multiplication, at that point of time, it comes out. Tell me, is this clear? Let's start AC now. Now take a look, boys and girls. Listen to me very carefully. Direct current. Before alternating current, you must understand what is direct current. Listen carefully. It is a unidirectional current. Unidirectional current means, see guys, let's suppose if we take a battery over here and we take a resistance over here. Now, this is called positive terminal of the battery. This is negative terminal. Always remember, current flows from higher potential to lower potential. So that's why current comes out of the positive terminal and it goes to the negative terminal. Okay, so this direction of this current is one unique from positive to negative. It can never be from negative to positive. And if you make the graph of this current is called unidirectional current, direct current. If you make the graph of this particular current over here, guys, so this will be the graph would be this. It is constant and it is positive only. So if you consider this from positive to negative, if you consider this current as positive and from negative to positive, if you current that negative, so this will be only positive. It cannot be negative. It will be, its direction is unique. I comes out of the positive terminal, current comes out of the positive terminal and goes into the negative terminal. This is a unidirectional current. Now see, what is a bidirectional current? Listen to me very carefully. Let's suppose you take an AC source over here. Sir, what is this? This is called DC source. DC source is this battery. DC source is that source which provides the direct current, this IDC. This current is direct current, unidirectional, or only from positive to negative. Okay. Now, if you take an AC source and you connect this to a resistance, now in this particular case, this AC source sends one cycle of the current like this, okay, another cycle of the current like this. So means this current you take as positive, this current you take as negative. So in this particular case, this is what we call AC source. AC source is that source which provides the alternating current. One cycle of the current is positive, another cycle is negative. So it means bidirectional current, as I shown you over here. This current can be positive and it can be negative. Like this, current versus time. So this current is what we call alternating current. From the upper side, we consider current as positive. From the lower side, we consider this as negative. And you see, value of this current is changing. So here, current is 0, then it is becoming maximum. At this point, this is the maximum value of the alternating current. Then again, it becomes 0. Then it becomes maximum from the negative side. Then it becomes 0. I believe this is clear. This is also an alternating current. So this is called a square wave AC. So this remains constant for some time. Then it changes the direction, remains constant for another time. Then again, it changes the direction, remains constant, remains constant. This is called a square wave AC. Square wave AC. And this alternating current, this is called sinusoidal AC. We have to study this only. Sinusoidal AC. That is square wave AC. Okay. And so if somebody asks you from now onwards, what is an alternating current? Alternating current is that current which is positive as well as negative. So if I make the graph, my dear NEET aspirants, in case of sinusoidal alternating current, see this is going to be the graph of sinusoidal alternating current. And my dear NEET aspirants, if I say, what is the equation of this? Equation of this will be something like this. I is equal to I naught sine of omega t, something like this. This is going to be the alternating current. Okay, like if I say, when it comes to the direct current, sir, tell me which current is this? This is a direct current, IDC. It can be 4 ampere, 10 ampere. We mention it like this. And here, this current is basically AC, alternating current. We mention it like this. This I naught means peak value of the current. This I naught means peak value of the current. Maximum value of the current, because it is changing. Initially, current is 0. This is peak. Then it's 0. Then peak from the negative side. This omega is what we call angular frequency. This omega is also equals to 2 pi into f. Or we also say this omega is 2 pi by t. You can write it like this also. Okay. So I naught is the peak value. Omega is angular frequency. T is time. You can say it like this. This is the alternating current. Now guys, take a look. In an AC circuit, the current is expressed as, this is the current which is expressed as 100 sine of 200 pi t. This is the current. Okay. In this circuit, current rises from 0 to peak value in time. Guys, see, let's suppose if I make this current, if I make the graph of this current something like this. If I make the graph of this current, this is the graph. Can I say in this particular case, what is the value of t over here? It is 0. It says when the current becomes peak, maximum. What is the time? What is the time in which it becomes the maximum, or I would say peak? Now guys, see, whenever you see this question of this sort, you do one thing. What is the peak value of this current? I naught, that is 100. Put this 100 over here. So it becomes 100 is equal to 100 sine of 200 pi t. Sir, what if it says find the time in which current becomes 50 ampere? Then you need to put 50 here. What is the time in which current becomes 70 ampere? Then you need to put 70 over here. Now guys, see, 100 will cancel out because this is instantaneous current. What is the time in which it reach peak? Put the peak here. So it becomes 1 is equal to sine of 200 pi t. 1 means, when is the value of sine as 1? We say sine of pi by 2, sine 90 is equal to, I would say, sine of 200 pi t. Now tell me, boys and girls, sine will cancel, pi and pi will cancel. So 1 divided by 2 is equal to 200 into t. So time will be 1 divided by 200 into 2 is 1 by 400 seconds. So how much time it is going to take in reaching the maximum value? 1 by 400 seconds. Now see, the peak value of an alternating EMF is this. This is the peak value of an alternating EMF. The peak value of alternating EMF E given by E is equal to is 10 volts. Okay, peak is given as 10. Frequency is given as this. So basically E naught is given as 10. This is alternating voltage. Frequency is given as 10. So alternating voltage will be provided by alternating source, AC source. Okay, time is given as 1 divided by 600 seconds. The instantaneous value, we are supposed to find the value of E. Basically, it says that if the peak value of alternating EMF is 10 volts, frequency is also 10. Frequency is 50. Time is this. What is the value of E? You can say E is equal to E naught. What is the value of E naught? 10. Then we say cos of. How can you write omega? 2 pi into F. Okay, omega. Then we say T. Because omega is also 2 pi into F. So what I can say, E is equal to, this is 10 cos of 2 pi. Now tell me, F, what is the value of F? Frequency is 50 and time is 1 divided by 600 seconds. Now 0 and 0 will cancel. 5 ones are 5 12s are. 2 ones are 2 6s are. So EMF will come out to be 10 cos of pi by 6. Cos pi by 6 means cos 30. Cos 30 is 1 by 2. So root 3 by 2. So 10, this will be root 3 by 2. 2 ones are 2 5s are 10. So this will be 5 root 3 volts. Okay. This is a question from J Means 2022. What is the question? The current flowing through the circuit is 5 sine of, see, current is given as 5 sine of 120 pi t. How long the current will take to reach the peak value starting from 0? How much time it is going to reach the peak value? Peak is 5, so put 5 over here. This will be 5 sine of 120 pi t. Now 5 will cancel. Here it is 1. So 1 means sine of pi by 2. That is sine 90. It will be sine of 120 pi t. Sine will cancel. Pi and pi will cancel. So t will be equals to 1 divided by 240 seconds. So in 1 divided by 240 seconds, it is going to reach the peak value. RMS value. Take a look, my dear NEET aspirants. How do we define RMS value? RMS value simply means what? It is what we call root mean square value. RMS value simply means what? A root mean square value. Okay. Now, how do we calculate root mean square value? Listen to me very carefully. Listen to me very carefully. Whenever you have to calculate the root mean square value of any current, we say RMS. First, you have to do the squaring. Okay. Then you have to find the mean means average. Then you have to apply the root. First do the squaring, then find the average, then apply the root. Final value is going to be RMS value. Like if you have a sinusoidal current. Guys, directly remember, if you have a sinusoidal current, if somebody asks you, what is the RMS value of this current? You say peak divided by root 2. Directly remember. So for sinusoidal current, what is the RMS value? Peak divided by root 2. Now see, in an AC circuit, current is expressed as this. I is equal to 100 sine of 200 pi t. In the circuit, the current rises from 0 to peak value. The current rises from 0 to peak. This we have already solved. Okay, we can change the question. I can give you the question like this. Let's change it. Okay. The current rises from 0 to RMS value. Yes. Now see. Guys, let's suppose I make the graph of this current something like this. Peak value is how much? 100. Let's suppose RMS value is somewhere around over here. This is the RMS value. how much time it is going to reach this RMS value, this time you guys are supposed to find. Now, first of all, tell me what is going to be the RMS. RMS is going to be I naught divided by root 2. So that will be 100 divided by root 2. Now, if you have to find the time in which it is going to reach the RMS value, put the RMS value over here. This. So that means 100 divided by root 2 will be equals to 100 sine of 200 pi t. Now tell me, this and this will cancel. 1 by root 2. When is the value of sine as 1 by root 2? Sine 45. Sine 45 means sine pi by 4 will be equals to sine of 200 pi t. Now, can I say in this particular case, guys, sine and sine will cancel, pi and pi will cancel. So 200 into 4. So time will come out to be, that will be 800. 1 divided by 800 seconds. So this is the time in which it is going to reach what RMS value. I believe this is crystalline clear. I believe this is crystalline clear. Okay, mixture of AC and DC. If you ever get to see a current something like this, okay, this current over here in this particular case, this one, this is what we call DC, which is alone, in which you have the current, in which you have cos, sine, this is what we call AC. If they ask you to find the RMS value of mixture of AC and DC, you'll be taking I1 square, this, and peak value of this I2 square divided by 2 directly. Like this. This is the question. What is the RMS over here? This is mixture of AC and DC under root of I1 square, that is 4 square, plus I2 square, this peak value of this 5 square divided by 2. I believe this is clear. Next. If you have mixture of two ACs, this is also AC, this is also AC. If you have mixture of two ACs, and if they ask you to find the RMS value, here RMS value will be under root of I1 square, peak value of this, its square, peak value of this, its square divided by 2. Like if I say you have I is equal to 4 sine of 200 pi t plus 3 cos of 400 pi t. You have to tell me IRMS. This because this is the mixture of two ACs. So we'll be saying under root of I1 square 4 square plus I2 square 3 square divided by 2. I believe this is crystalline clear. LCR circuit. LCR circuit. LCR circuit. Okay, is this clear? Oh? Tell me, is this clear till over here? Come on. I'll be sharing the PDF in this Telegram channel. t.me slash YAWAR MANZOOR, or you can say Yawar Manzoor Physics. Yawar Manzoor Physics. Okay, yes. Now guys, take a look. Take a look. LCR circuit, series LCR circuit. LCR means this is what we call inductor. Okay. This is what we call capacitor. Okay. Parallel plate capacitor. And this is what we call resistor. So in like resistor has got resistance, similarly this has got capacitance, this has got inductance, L. Yes, this is inductor. And when all the three are connected in one circuit, this circuit is called LCR circuit. And an AC source is connected to this. This is an AC source, not a DC source, which provides the alternating current. Yes. And boys and girls, this AC source is going to provide the voltage VL to this, okay, to this inductor, VC to this capacitor, VR to this resistor. Potential difference across inductor, across capacitor, across resistor. Okay. One more important thing, my dear NEET aspirants, listen carefully. When it comes to this LCR circuit, first and the foremost thing, listen carefully. Let's plot the phasor diagram. Okay, listen. We assume in phasor diagram, we plot the current and voltages in terms of arrows, with an arrow. We show in phasor diagram, we show current with an arrow. Like if I say this is the current, we assume current to be like this. This is the current. In phasor diagram, we show current with an arrow, with a vector you can say, with an arrow you can say. Okay. And potential difference also with an arrow. So remember this particular point, we say potential difference across resistor will be along this current. Always remember. Potential difference across resistor will be in the same phase as current, will be in the same phase with current. If the direction of current is forward, we assume we make the direction of potential difference of resistor also in the same direction. Potential difference of the inductor we make upward, and potential difference of the capacitor we make downward. What does that mean? Potential difference across the inductor leads current by pi by 2. This means this anti-clockwise. ACW, it means lead. It means lead. And this means this clockwise, it means lag. Behind. So voltage across capacitor lags behind current by pi by 2. How much is this angle? Pi by 2. Potential difference across inductor leads voltage or leads current by how much? Pi by 2. Okay. So in case of LCR circuit, this is the phasor diagram. VR current, VL VC. Let's assume if I say if VL is greater than VC, this potential difference across inductor is greater than potential difference across capacitor. Then I say resultant of this one and this one will be bigger minus smaller, VL minus VC. Then I can make it like this, VL minus VC, this is VR. And resultant of this and this will be this V net. And if somebody says, what is the value of V net? V net will be this square plus this square. VR square plus VL minus VC whole square. Yes. Now let's make the impedance diagram. Listen carefully. How do we make the impedance diagram? Take a look, guys. How do we make the impedance diagram? Can I write this as V is equal to, okay, one thing I must tell you over here. In an LCR circuit, this has got resistance R. Sir, does this capacitance also have resistance? Yes, that is XC. This is called the capacitance of, this is called the resistance of capacitor. Capacitor also has its own resistance. That is called XC. This is called capacitive reactance, resistance of capacitor. Inductor also has its own resistance. That is called XL. That is called inductive reactance. Okay, inductive reactance. Now, my dear NEET aspirants, what I want you to understand over here, listen to me very carefully. What I want you to understand over here. Okay, can you write this VR as I into R? Potential difference across inductor is I into R, current into resistance. Can you write this as VL? That will be I into XL. Absolutely, sir. Can you write this as I into XC? 100%. Current into this resistance of capacitor. Now, this I, and I will be cancelled. So what remains? R, XL, XC. This is called impedance diagram. So in case of impedance, in impedance diagram, we only show resistances. Resistance of resistor, inductor, capacitor. Now, in this particular case, boys and girls, I need to show you something. Let's suppose if this XL is greater than XC. If XL is greater than XC, then we say LCR is inductive in nature. If in an LCR circuit, this value of XL comes out to be greater than XC, then LCR is inductive in nature. If this is bigger than this, so resultant of this and this will be upward. That will be XL minus XC. This is R. Now resultant of this and this, that will be Z. And this Z is called impedance. So could you please tell me what is the value of this Z? This Z will be under root of this R square plus XL minus XC whole square. And this is what we call impedance. Impedance is what? Impedance is the net resistance of LCR circuit. It is the net resistance of LCR. Impedance is what? I would say net resistance of LCR is what we call the impedance. Net resistance of LCR is what we call the impedance. Yes. Now, boys and girls, listen to me very carefully. This angle over here is phi. If somebody says, what is the value of this tan phi? Tan phi will be simply perpendicular by base. That is XL minus XC divided by, I would say, R. Okay. And if somebody says, what is the value of cos phi? Cos is based upon hypotenuse. That is R divided by Z. This is what we call power factor. Power factor. Okay. Now, if let's suppose we say LCR is capacitive in nature, what does that mean? That means XC is greater than XL. If LCR is capacitive in nature, that means this is greater than this. So resultant diagram will be from the lower side. So that will be this. So could you please tell me what is the value of Z in this particular case? That will be under root of this square, R square, plus this, that is XC minus XL whole square. And could you please tell me, boys and girls, could you please tell me, boys and girls, in this particular case, what is the value of tan phi? Tan phi, this will be perpendicular, this is base. That will be XC minus XL divided by R. This will be the value of tan phi over here. As I told you, capacitive reactance. Capacitive reactance is also equal to this. Capacitive reactance means the resistance of capacitor, 1 by omega C. You can write it like this also. 1 upon omega is 2 pi into F. This is C. So this capacitive reactance is inversely proportional to frequency. Even if you have to make the graph between XC and frequency, it would be like this. And when it comes to this inductive reactance, resistance of inductor, you can write it like this, 2 pi into F into L. What? This is directly proportional to frequency. You can make the graph between XC and F. This will be directly proportional because it is directly proportional. Guys, tell me, is this clear? Is this clear? Is this clear? Oh, tell me in the chats quick. Okay. Now, guys, take a look. Find XL, XC, Z. Okay, this is the circuit over here. In this circuit, you guys are supposed to find what? XL, XC, Z, phi, V0, okay, and power factor. Okay. Now, boys and girls, in this particular case, Could you please solve this particular question? Come on, give it a shot from your end. Very simple. R is given, L is given, C is given, and current in this particular case is also given. Can you tell me the value of answer of this question? Come on, give it a try. Now take a look. Take a look. Guys, see. If I say I is equal to I naught sine omega t, what is the value of I naught over here? 10. What is the value of omega over here? 100. Let's find the value of XL. XL will be omega into L. So XL in this particular case, omega is 100 and L is 0.16. So this will be 16 by 100, 100 will cancel. So XL will be equals to 16 ohms. Let's find the value of XC. That is 1 upon omega C. 1 upon omega is 100. C, what is the value of C? 500. It is micro, so 10 raised power minus 6. Solve it, XC will come out to be 20 ohms. XC will come out to be 20 ohms. Now, my dear NEET aspirants, which one is bigger, XC or XL? We say XC is greater than XL. So this is capacitive in nature. This LCR is capacitive in nature. If this is capacitive in nature, could you please tell me what is the impedance under root of R square plus? If this is bigger than this, then you say XC minus XL. If this is bigger than this, XL minus XC. Its whole square. So Z will be equals to under root of this R square. R is how much? 3 square plus XL minus XC. That is 20 minus 16. That is 4. So 4 square. Okay. So under root of 16 plus 9, that is 25. So Z will come out to be 5. Now, what is the value of tan phi? Tan of phi. Tan phi will be, guys, listen carefully. That is XC minus XL divided by R. Arey, recently you studied, na? If this is greater than this one, see? Tan phi. If XC is greater than XL, XC minus XL divided by R. And that is going to be the net diagram. So, tan of phi, XC minus XL, that is 20 minus 16 divided by 3. So, it is 4 by 3. When is the value of tan as 4 by 3? When this is 53 degrees. Because this is 4, this is 3, this is 5. So, tan 53 is 4 by 3. So, value of phi is 53 degrees. V naught. V naught is the peak value of the voltage. This will be I naught, peak value of current into net resistance Z. If you say in capacitor V is equal to IR, in capacitor V is equal to IR, okay, in capacitor V is equal to, in resistor V is equal to IR, in capacitor I into XC, in inductor I is equal to I into XL. So in LCR, you can say I naught into Z. So V naught will be equals to, what is the value of I naught? I naught is given as 10 and Z is 5. So this is going to be 50 volts. Okay, power factor. As I told you, power factor means cos phi. That will be R by Z. What is the value of R? That is 3. Z is 5. 3 by 5. I hope this is crystal and clear. Resonance condition. Guys, what is the resonance condition? Arey, XL is correct, yeah. XL, XC is correct. Now take a look over here. Resonance condition. It is in the micro, na? It is not in the farad. This is microfarad, bro. That's why when you convert this to the farad, you multiply with 10 raised power minus 6. Is this clear till over here? Huh? Resonance condition. What does resonance condition actually mean? Listen carefully. What does resonance condition actually mean? This is an LCR. This is the impedance of LCR. Okay. This is not the impedance diagram. Let me make the impedance diagram. Yes. Resonance condition means when the value of XL becomes equal to XC. If this XL is equal to XC, they will cancel out each other. What is the net resistance? Z will be equals to R. Even you can find it. Z will be under root of R square plus XL minus XC whole square. When these two become equal, so their resultant is 0. So Z will be equals to under root of R square. Square and root will cancel. Z will be equals to R. Z will be equals to R. Okay? Yes. Now you say at resonance, XL is equal to basically XC. What is the value of XL? Omega into L. What is the value of XC? 1 upon omega C. Now, take this omega here. Omega square will be 1 upon LC. So, omega will be equals to 1 upon under root of LC. This is what we call resonance angular frequency. This is what we call resonance angular frequency. Now, can I write this omega as 2 pi f also? So, this will be 1 upon under root of LC. Take this 2 pi over here. Frequency will be 1 upon 2 pi under root of LC. This is called a resonant frequency. This is called resonant angular frequency. This is called resonant frequency. Even in some questions, it is also mentioned F naught, omega naught. In an LCR circuit, L is given as 8, C is given as this. The value of resonant angular frequency, omega is equal to 1 upon under root of LC. Put the value of L, put the value of C, get the answer. There was a question. Question was this. This is an LCR circuit. This is an LCR circuit. And in this LCR circuit, VRMS across resistance was given as 300 volts. VRMS across inductor was given as 700 and net voltage of this was given as 500 root 2 sine of omega t. We were supposed to find peak voltage of the capacitor. This is a beautiful question. There is an LCR circuit. RMS voltage across resistor is given as 300. Okay. RMS voltage across inductor is given as 700. Net voltage is this. You are supposed to tell me peak voltage of the capacitor. Plot phasor. Plot the phasor diagram. Plot the phasor diagram. Listen carefully. What is VR? This is RMS, by the way. VRMS is given as 300. Okay. VL is given as 700. But this is RMS. Phasor of RMS. Phasor of RMS voltages. Okay. And net is given as, guys, is this RMS or this is peak? This is peak. This is peak V naught. When we say RMS, how do we find RMS? Peak divided by root 2. So this is 500 root 2 divided by root 2. This and this will cancel, so it will come out to be 500. So this is 500. This is VRMS, but it's net. Now tell me one thing. Before finding this, let's find the RMS voltage of capacitor. If this is 700, this is 300, do you think that resultant of 700 and 300 is 500? No, sir, not possible. Resultant of 400 and 300 is 500. If you find the resultant of 400 and 300, that will be 500. So how is it possible that the resultant should be 500? So resultant will be only 500 if from the lower side, RMS voltage of capacitor is, I would say, 300. Then only we say this 700 minus 300, that will be 400. Now this 400 and 300 will have the resultant of 500. So this came out to be, this came out to be what? RMS voltage of capacitor. Now, my dear NEET aspirants, if RMS voltage of capacitor came out to be 300, RMS is basically peak divided by root 2. It is 300. Now take it over here. So peak will be 300 root 2. So this is the answer to the question. RMS came out to be 300 root 2, but peak will be 300. So RMS came out to be 300. So peak will be 300 root 2. Transformers. Let's take a look, guys. Transformers. You might have seen, let's suppose this is your house. Okay. This is a television in your house. This is the supply line which comes from the outside. Do you directly connect this with the television? No. Why? Because, sir, if we connect this directly to the television, it is going to burn the television. Because sometimes the voltage coming from the outside may be huge. Sometimes the voltage coming from the outside is less. In that case, it will not work. So what we do is we use the transformer. So the supply coming from the outside, this alternating supply goes into the transformer. Now, if this supply is large, this transformer, this is also called voltage stabilizer. It stabilizes the voltage. It is going to decrease that voltage. And it is going to send the amount of voltage which this needs, that is 220. So if, let's suppose, the voltage coming from the outside is large, it is going to decrease that and send it accordingly. If the voltage coming from the outside is less, in that case, this is not going to work. So transformer automatically steps that up, that voltage, and sends the sufficient voltage so that the television works. So this is the work of a transformer, to stabilize the voltage. Now guys, see, this transformer is made up of soft iron core. And there is a coil which is wind over here. Okay. So this is called primary winding, primary coil. There is another coil over here that is called a secondary coil. The current which comes from the outside, that is called I primary. This goes into this primary coil. And the voltage in the primary coil is V in. This is the input voltage. And number of turns in the primary coil is NP. And my dear NEET aspirants, when the current flows through this coil, it produces the magnetic field. Because whenever current flows through the coil, it produces magnetic field. And that current, that magnetic field is crossing the area of the coil. So flux is produced. So flux produced in the primary coil is phi p. Now this flux is transferred to the secondary coil. Okay. And in the secondary coil, flux created will be phi s. Number of turns in the secondary coil is ns. Output current given by the secondary coil is I secondary or I out. So output voltage is V out. This is the secondary coil. Now two equations you need to remember over here. If somebody says, listen carefully, sir, what is the output flux in the secondary coil? You simply say it will be flux in the primary coil multiplied by number of turns in secondary upon number of turns in primary. This is the first equation. Guys, when the primary current enters the coil, it produces magnetic field. Due to that magnetic field, flux is produced. That flux is being transferred to the secondary coil. So flux in the secondary coil is equal to flux in the primary coil, number of turns in secondary upon number of turns in primary. Now, we say voltage in the secondary coil. It will be voltage in the primary coil, input voltage. Okay. It will be number of turns in secondary upon number of turns in primary. Directly remember this. If somebody says current in the secondary coil, output current, this will be current in the primary coil. Okay. The number of turns in primary, here only you will be having the number of turns in primary upon number of turns in secondary. Keep this thing in your mind, my dear NEET aspirants. These are the three equations you need to remember in case of the transformer. Okay, one more important thing. Okay, wait. Step up. Let's suppose the voltage input is less. You need to step this up. You need to increase the voltage. Input voltage is 50 and let's suppose I am keeping, listen carefully, I am keeping number of turns in the primary coil as 50, number of turns in the secondary coil as 100. Okay, let's check the output voltage. Guys, V output will be simply number of V input, number of turns in primary, number of turns in secondary upon number of turns in primary. Input is 50. This is number of turns in secondary is 100. This is 50. This and this will cancel, so this will be 100 volts. So basically, if you want to step up the voltage, in that case, you have to keep the number of secondary turns as 100. So in that case, you need to keep the number of secondary turns greater than number of primary turns if you want to step up the voltage. So basically, that tick, tick, tick that you do in the stabilizer, that is basically increasing or decreasing the number of turns in the secondary coil. Let's suppose you have input voltage as 100. You want to step it down. So let's keep number of primary turns as 100, number of secondary turns as 50, number of turns in the secondary coil. Now let's check the output voltage. This will be input voltage 100, number of turns in secondary 50, number of turns in primary 100. Okay, this and this will cancel. So answer is 50. So if you want to step down the alternating voltage, in that particular case, my dear NEET aspirants, you have to decrease the number of secondary turns. One more important thing. Efficiency of a transformer. Listen to me very carefully. Efficiency of a transformer. Let me write it over here. Efficiency of a transformer. Efficiency of a transformer. Efficiency of the transformer is NETA. And this means output power divided by input power. This is what we call efficiency of a transformer. How much, let's suppose, and we can write it like this. Output power is equal to NETA times of input power. Let's suppose, my dear NEET aspirants, if efficiency is 20%, what does it mean? It means output power will be 20% of input power. What does that mean? That means the amount of power you are sending to the transformer, it is only giving 20% of that as output. So it is not a good transformer, it's a bad transformer. You are giving 100% input. It is giving you 20% output, 20% of the input. Like, if I say for an ideal transformer, we say efficiency is 100%. So can I say in this particular case, output power will be equals to 100% of input power. So whatever the output power you are giving, exactly you are getting, whatever the input power you are giving, same you are getting as output power. So can I say in this particular case, output power, 100% means 100 by 100 of input power. So this will cancel. So in this particular case, output power will be equals to input power, means power loss is zero. Let's take a look. A 220 volt input is supplied to a transformer. Okay. Input voltage is 220 volts. The output circuit draws a current of 2 ampere. Output circuit draws a current of 2 ampere at 440 volts. Output voltage is 440. If the efficiency of the transformer is 80%, NETA is given as 80%. If the efficiency of the transformer is given as 80%, okay, the current drawn by the primary windings, of the transformer is, so means you are supposed to find the primary current. Now tell me, can I say in this particular case, guys, output power will be NETA times of input power? Power is, how do we find power? That is V into I is equal to neta times of V into I. Array output power, input output current, input power, input volt, output voltage, output current, input voltage, input current. V out, I out, V in, I in. Now tell me, output voltage is 440, output current is 2 ampere, neta is 80%, 80% means 80 by 100, input voltage is 220, input current is 2 ampere. Okay. Input current we have to find out. I primary. 220 ones are, 220 twos are. Now 2 into 2 is 4. 4 ones are, 4 twos are 8, 4 zeros are. Now 0 and 0 will cancel. 2 ones are, 2 fives are 10. This 5 will go over here. So primary current came out to be 5 ampere. The primary winding of a transformer has got 500 turns. NP is 500. Okay. Secondary winding has got 5,000 turns. NS is 5,000. The primary is connected to an AC supply of 20 volts. V input is 20 volts. The secondary will have an output of V output. You guys are supposed to find out. V output is equal to V input into number of turns in secondary upon number of turns in primary. This is 20 into secondary has got how many turns? 5,000. So this will be 500. Okay. This is 20 into 50. Did I make any sort of mistake? 20 volts, number of turns has got 500. 500 and this is 20 volts input. Okay. The primary winding of the transformer has got a 500 turns. Okay, NP is 500 and the secondary winding has 5,000 turns. Then the primary is connected to an AC supply of 20 volts. Okay, the secondary will have an output of, correct? Huh? Is this clear? Oh, tell me. Is this clear? Come on, give me the signal in the chats. Tell me. Okay. Sorry. Yes, 5 is also there, na? That's why I was confused. So 20 into 50 divided by 5. 5 ones are 5 tens are 200. Correct. Okay. Okay. Let's take a look over here, guys, boys and girls. Okay. Now, this is chapter 7. This is chapter 7 over here. Take a look, boys and girls. Listen carefully. So, we are starting the modern physics. We are starting the modern physics. Okay, let me finish the modern physics first. Okay. Guys, let's finish modern physics high weightage. First, we need to finish the modern physics, okay? Now take a look. So, boys and girls, the very first thing that we need to understand over here is dual nature of matter and radiations. In this particular chapter, first we'll be starting with the energy of a photon. First, we'll be starting with the energy of a photon. Okay? When it comes to the energy of a photon, we say energy of a photon is simply, we say H into F. H into F. I have placed the optics also. See? Don't worry, okay? Everything is mentioned over here. Critical angle, TIR, apparent depth, apparent height, magnification. Okay. Number of images, number of this. So wave optics also. Wait, na? In wave optics also everything is there. Huh? Take a look. Energy of a photon. Guys, when it comes to the light, we say, let's suppose this is a light source. From this light source, we say light is coming out. In modern physics, we will be assuming this light as a particle. These are the particles which are coming out of this light source. So these particles are what we call photons. These particles are what we call the photons. Okay, these particles are what we call the photons. And these photons are, we say, this is what we call light. This is what we call light. Now, my dear NEET aspirants, since we say when these photons are falling, my dear NEET aspirants, let's suppose these photons are falling on this. Okay? These photons are falling. We say it is energy falling. How much is the energy of a photon? We say energy of a photon is H into F. H means Planck's constant. F is frequency. Or you can write it like this also. F is, we say F means c by lambda. C is the speed of light, lambda is de Broglie's wavelength. This is also the energy of a photon. Or we say energy of a photon like this also. 2 into 10 raised power minus 25 divided by lambda. This is also the energy of a photon. But this is the energy of a photon in joules. And this lambda is in meters. If you ever have to find the energy of a photon in joules, and where lambda is given as meters, in meters, so you will be using this formula. Okay. Then, my dear NEET aspirants, further you have two more formulas. That is this one. This is the energy of a photon in electron volts, where lambda is in nanometers. When lambda is in nanometers, energy is in electron volts, 1240 divided by lambda. This is also the energy of a photon in electron volts when lambda is in angstrom. So if you ever have to calculate the energy of a photon in electron volts, you'll be using this, but when lambda is in angstrom. Okay, yes. Now guys, let's take a look. What is the energy in joule associated with a photon of 4000 angstrom? Now see, you have to find the energy in joule. Whenever you have to find the energy in joule, you will be using this 2 into 10 raised power minus 25 divided by lambda. This energy is in joules, lambda is in meters. And one more important thing, my dear NEET aspirants, listen carefully. We say 1 angstrom. We say 1 angstrom is equal to 10 raised power minus 10 meters. We say 1 nanometer is equal to 10 raised power minus 9 meters. So what I can say in this particular case, guys, this energy of a photon we can write 2 into 10 raised power minus 25 divided by lambda. Lambda over here is, I can say 4000 into, I can say this is 4000 angstrom. Guys, you need to convert this to the meters into 10 raised power minus 10. Solve this 0.18 into 10 raised power minus 18. Then, my dear NEET aspirants, if you have to find the energy of this photon in joules, so sorry, in electron volts, you can write this 12400 divided by lambda. So this equation we use in order to find the energy of photon in electron volts, but when lambda is in angstrom. So you can say E is equal to 12400 divided by lambda. Lambda is given in angstrom. So you can write over here. You can write over here 4000 angstrom. Okay. Okay. And this will be in the electron volts. This and this will cancel. This will be 3.1 electron volts. Okay. Okay. Yes. Take a look at this energy of light. Now, guys, my dear NEET aspirants, when I say, let's suppose this is a light. This is a light source. This is a light source. So from this light source, my dear NEET aspirants, we say these are the photons coming out of this light source. These are the photons coming out of this light source. These are the photons coming out of this light source. Okay. These are the photons coming out of this light source. So basically, these are N photons. So N photons actually mean light. So light is basically made of N number of photons. So if somebody asks you what is the energy of a light, you say that is NHC divided by lambda. This is what we call energy of light, NHC divided by lambda. N means number, see, what is the energy of one photon? Hc by lambda. For N photons, NHC divided by lambda. Then, my dear NEET aspirants, we define here only power of light. We define here only power of light. Listen to me very carefully. I'll make you understand this power of light. See, when it comes to the power of light, let's suppose you have a bulb over here. You have one more bulb over here. From this bulb, these are the photons falling. Photons falling. These are the photons falling from this bulb. In this particular case, large number of photons are coming out of the bulb. Less number of photons are coming out of the bulb. So power of this bulb is large, power of this bulb is less. Why? Because more number of photons are coming out, less number of photons are coming out. So power means number of photons falling or we say energy falling per second. Power is energy upon time. How much energy is falling every second? So here more photons are falling means more energy is falling every second. Here less energy is falling every second. So when it comes to the power, it is NHC divided by lambda into T. Energy means NHC by lambda, T means time. Intensity. Guys, see, when it comes to the intensity, listen to me very carefully. Intensity simply means energy upon time into area. That means energy upon time is power. Like I'll make you understand. Let's suppose this is a bulb over here. This is one more bulb over here. From this bulb, large number of photons are falling. These are the photons falling, coming out of this bulb. These are the large number of photons falling. These are the large number of photons falling. Okay. Now, my dear NEET aspirants, what I can say in this particular case, we say here, less number of photons are falling in this particular case over here, large. If I take the unit area, on this unit area, we say large energy is falling every second. On this unit area, less energy is falling every second. So intensity at this point will be large, intensity at this point will be less. Like this is a bulb. So here intensity of the bulb is large because large number of photons are falling over here. At that corner, less number of photons are falling. So over there intensity is less. Here intensity is large, over there intensity is less. Intensity means number of photons falling per unit area. In the unit area, how many number of photons are falling? So intensity is energy upon time into area. What is energy? Energy is NHC divided by lambda. Okay. Divided by time into area. This is what we call intensity. This is what we call intensity. This and this. Okay. Yes. Now comes the photoelectric effect. Listen to me very carefully, boys and girls. Now comes the photoelectric effect. Okay. Now comes the photoelectric effect. See, when it comes to the photoelectric effect, guys, I hope intensity is clear. And one more important thing I just want to say. Let's suppose this is a point source. So due to this point source at r distance, we say this intensity. Due to this, it is power upon area, or you can directly remember one thing. Intensity is inversely proportional to r square. So as you keep on moving away from this point source, intensity will decrease. Yes. Photoelectric effect. See, photoelectric effect simply means, let's suppose this is a light source over here. From this light source, these are the photons falling on this. And when the photons fall on this metal surface, electrons are ejected from this metal surface. When photons fall on the metal surface, electrons are ejected from the metal surface. Okay. So I would say when light falls on the photosensitive metallic surface, electrons are ejected from the surface. This process is called photoelectric effect. Now guys, work function. Work function means minimum energy required to pull the electrons from the material. That is what we call the work function. Like, let's suppose this is a material over here. This material has got phi. Phi means it has got work function of 2 electron volts. This material has got work function as 5 electron volts. What does it mean? It means that if you have to pull out the electron from this metal surface, see, how does electron leave the metal surface? When photon falls onto the metal surface. When photon falls onto the metal surface, then only electron leaves the metal surface. Now we say if the energy of photon is equal to the work function, then only it can leave. Why? Because this is the minimum energy required to pull the electron from the metal surface. So here, what is the minimum energy required? 5 electron volt. It completely depends upon the material. So here, if you say energy of photon is 4 electron volt, then it cannot pull out the electron from the metal surface. Because minimum energy required to pull the electron from the metal surface is how much? 5 Now, experimental setup of photoelectric effect. Is this clear till over here? Come on, guys. Tell me in the chats. Is this clear till over here? Quick. Is this clear? Come on. Tell me in the chats. Is this clear? Come on. Tell me, guys. Now take a look. Experimental setup of photoelectric effect is basically you take over here a tube-like structure. And in this tube-like structure, you place the opening over here and you place a light source. This metal surface is called cathode. This metal surface is anode. And the photons come through this opening and it falls onto the cathode. Okay, it falls onto the cathode. Electrons are ejected from the cathode. Now, my dear NEET aspirants, let's suppose there is a photon. Work function of this is, let's suppose, 2 electron volts. Let's suppose you are sending a photon over here, which has an energy 8 electron volts. Okay? Yes. Now, this photon is interacting with the electron here. It transfers the 8 electron volts to the electron. Now, this electron uses 2 electron volts in the work function. Means it has to come out of the metal surface. Rest of the energy, my dear NEET aspirants, will go into the kinetic energy. 8 electron volt was the energy given by the photon to the electron. Now this electron is using 2 electron volts in coming out. So rest of the 6 electron volts it is using in moving forward, because it has to move forward now to produce the photocurrent. So we say energy of a photon is used in work function plus kinetic energy maximum. So some portion of the energy of photon is used in coming out of the metal surface and some is used as kinetic energy maximum. This is called Einstein's photoelectric equation. This is called Einstein's photoelectric equation. Okay? Yes. Now, my dear NEET aspirants, what I want you to understand over here is that is this one. Listen carefully. Listen carefully. See. Since in this particular case, this is the graph between photocurrent and EMF. This is the graph between photocurrent and EMF. I'll make you understand. Let's suppose you have got, this is the cathode and this is anode. This is cathode and this is anode. You are connecting a battery over here. Let's suppose if I say 10 electrons are coming out of the cathode. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And only 4 electrons are able to move forward. Sir, why not rest of the electrons? Because rest of the electrons may be facing the collisions. It is not like electrons come out of the cathode, all the electrons will move smoothly. No, rest of the electrons may be facing the collisions. That's why. Now, boys and girls, so if these electrons are able to reach anode, when these electrons move, we say current is being produced, photocurrent. So, battery is not connected yet. When EMF is 0, battery is not connected. 4 electrons are moving. So, photocurrent versus EMF. So, in that particular case, current is not 0. If I say graph starts from here, it means photocurrent is 0. But we say on its own, how many electrons are moving? 4, without the battery. So that's why flow of electrons is current. So photocurrent is not zero when EMF is zero. Now, what you did is that you applied the battery. You connected the battery. First, you applied 10-volt potential. It created some positive charge here because this is positive, this is negative. If positive terminal is connected to this anode, it will create positive charge over here. As you keep on increasing the charge, we say this charge over here increases. So 20 volt, 30 volt, 40 volt. And my dear NEET aspirants, as the charge keeps on increasing, it attracts these electrons. It attracts these electrons. So the time will reach, let's suppose when you applied 40 volts, I would say in that particular case, all the 10 electrons will be moving. Then if you apply 50 volts, still 10 electrons will be moving. So basically, when EMF is zero, photocurrent is there. As you keep on applying 10 volts, so this more electrons are flowing. So after some time, graph will be constant. Okay, so 20 volt, 30 volt, now electrons keep on shifting, keep on shifting. So let's suppose at 40 volts, 10 electrons actually moved. All the 10. So then photocurrent becomes constant at that. This is what we call saturation current. Saturation current. Saturation current. Okay? Yes. Now listen to me very carefully. Now let's suppose you reverse the polarity of the battery. Reverse the polarity of the battery means you are applying positive to this side, negative to this side. When you apply negative charge to this side, in that particular case, negative charge will be occupied onto this. Now, initially, how many electrons were flowing? 4. Now, this negative charge will repel these 4. So let's suppose you applied minus 10 volt. It repelled this one. Now only 3 are flowing. So photocurrent decreases. So when you applied minus 10, photocurrent decreases. When you applied minus 20, photocurrent decreases. When you applied minus 30 volts, now I would say only 1 electron is flowing. When you applied minus 40 volts, now this is also not flowing because they are facing maximum repulsion. So this is minus 40 volts. So at minus 40 volts, I would say photocurrent becomes zero. This potential is what we call stopping potential. That negative potential when photocurrent becomes zero, Okay, that potential when photocurrent becomes zero is what we call the negative potential, my dear NEET aspirants. Okay. Is this clear, boys and girls? Give me the signal in the chats. Is this graph clear? Is this graph clear? Okay. So in this particular case, my dear NEET aspirants, in this particular case, as you keep on increasing the negative potential here, negative charge here, it will repel these electrons. At a particular value of negative potential, photocurrent becomes zero. That potential is called stopping potential. We say at stopping potential. Listen carefully. At stopping potential. At stopping potential. At stopping potential. My dear NEET aspirants, we say kinetic energy is equal to, we say EV naught. Remember this. E is the charge on an electron. I would say V naught is the stopping potential. V naught is the stopping potential. Okay? Yes. So this is basic. See, if you keep on increasing the positive potential, then photocurrent increases and then it becomes constant. If you keep on increasing the negative potential, photocurrent decreases. At particular value, it becomes zero. That is called a stopping potential. One more important thing. This Einstein's kinetic energy equation. Guys, we say energy of a photon is equal to work function plus kinetic energy maximum. See, there are different ways to write this particular equation. Listen carefully. I can say this equation something like this also. Energy of a photon is h into f. Work function you can write h into f naught. F naught is the threshold frequency. It is the minimum frequency. Like what is work function? Minimum energy at which photoelectric effect takes place. This is the minimum frequency at which photoelectric effect takes place. Threshold frequency plus this you can write EV naught. Okay, this is also the version of this. You can write it like this: hc divided by lambda is equal to hc divided by lambda naught, because frequency is c by lambda, plus I would say EV naught. Even you can write it like this also. Guys, see, energy of photon is h into f plus is equal to, this is h into f naught plus 1 by 2 mv square. Kinetic energy you can write as 1 by 2 mv square also. This you can write hc divided by lambda is equal to hc divided by lambda naught plus I would say 1 divided by 2 mv square. 1 divided by 2 mv square. Okay? Yes. Yes. Now take a look, boys and girls. For a certain metal, frequency is 5 times the threshold frequency, F naught. The maximum velocity of the photoelectrons, is 8 into 10 raised power 6. See, guys. This is, I would say, in this particular case, a metal surface. And there is a photon which is falling onto this metal surface. Okay? And this photon has got the frequency. For a certain metal, frequency is 5 times the threshold frequency. Frequency of this photon is 5 times the threshold frequency. Okay. Threshold frequency is the minimum frequency at which photoelectric effect takes place. Okay. Okay. Then, my dear NEET aspirants, it says, the maximum velocity of the photoelectrons, the electrons which are being ejected from this, it has got the velocity V1 is equal to 8 into 10 raised power 6. If frequency F is equal to 2 times of F naught, it says if the frequency of the photon is F is equal to 2 times of F naught, then the velocity of the electron will be. This is the question. Now, when I looked at the question, I saw frequency, threshold frequency, velocity. Which equation of photoelectric effect I'm going to use? Frequency, threshold frequency, threshold frequency, and velocity. I believe this is the equation which is fitting over here properly. So what is that? That is, we say as h into f is equal to h into f naught plus 1 by 2 mv square. Yes, sir. Now apply this in case 1 and apply this in case 2. That's the case 1. So we say case 1. In case 1, you can say h into f. H into f. What is the value of f? That is 5 times of f naught is equal to hf naught plus 1 by 2 m v1 square. Okay, take it over there. 5 hf naught minus hf naught. This will be 4 hf naught is equal to 1 by 2 m v2 square. Case 2. Case 2. Case 2. Case 2. Case 2 is this one. So that is h into f. What is the frequency over here? 2 times of f naught is equal to hf naught plus 1 by 2 mv square. 1 by 2 m v2 square. Because velocity of electron here is v2. Now, could you please tell me in this particular case, take it over here, 2 hf naught minus hf naught. This is going to be hf naught is equal to 1 by 2 m v2 square. Yes. This is equation first and this is equation second. This is equation first, this is equation second. Now, my dear NEET aspirants, what I want you to understand over here is divide first and second. So this will be 4 HF naught divided by HF naught. 1 divided by 2 mv2 square. 1 divided by mv1 square. It is v1. Divided by 1 by 2 mv2 square. This and this will cancel. HF naught will cancel. 4 is equal to v1 divided by v2 whole square. Take it over here. This will be root 4. Root 4 is 2. So v1 divided by v2 will be equals to 2. So v2 will be v1 divided by 2. What is the value of v1? 8 into 10 raised power 6. 8 into 10 raised power 6 divided by 2. So this will be 4 into 10 raised power 6 meter per second. Is this clear? Oh, tell me. Now the similar pattern of question I have given over here. Take a look. See, two radiations of photon energies. See, two radiations of photon energies. Listen carefully. This is a photon. It is having the energy 1 electron volt. And there is another photon which is falling. It is having the energy 2.5 electron volt. Successively fall on the photosensitive metallic surface of work function. Work function of this is given as 0.5 electron volts. The ratio of maximum speeds of emitted electrons is, so velocity of electron here is v2. It says what is the value of v1 divided by v2. Simple. Now see, what is the type of equation that I'm supposed to use over here? See, can I make one more? Energy of a photon plus is equal to work function plus kinetic energy maximum, that is 1 by 2 mv square. Yes, I can make so many types of equations from this one. Now see, energy of photon is given, work function is given, velocity is given. Which equation I can use? E is equal to work function plus 1 by 2 m v1 square. Okay. Okay. Now I can say in this particular case, apply this equation in case 1. So we can say in case 1, energy of a photon is 1 electron volt is equal to work function is 0.5 electron volts plus 1 by 2 mv1 square. Now 1 minus 0.5, that is 0.5. 0.5 means 1 by 2 electron volt is equal to 1 by 2 mv1 square. Okay. Case 2. In case 2, energy of a photon is 2.5 electron volt is equal to work function is 0.5 electron volts plus 1 by 2 mv2 square. Now take it over here. 2.5 minus 0.5, that will be 2 electron volt is equal to 1 divided by 2 mv2 square. This equation second. Divide first and second. If you divide first and second, what will you get? 1 divided by 2 divided by this 2. Okay, electron volt is equal to electron volt will be cancelled now. Is equal to 1 by 2 m v1 square divided by 1 by 2 m v2 square. This and this will cancel. So what I can say in this particular case, v1 divided by v2, its whole square will be equals to 1 by 4. Take it over here. So it will be v1 divided by v2. It will be equals to 1 divided by under root of 1 by 4. That is 1 by 2. 1 is to 2. Is this clear? Is this clear? Is this clear? Tell me quick. Tell me in the chats, is this clear? Come on. Is this clear? Come on, give me the signal in the chats. Okay. Now take a look. Guys, this series I would want you guys to remember directly. Frequency is proportional to energy of photon. Okay? Because we say energy of photon is h into f. If frequency is large, energy of photon is large. Okay? And my dear NEET aspirants, then we say kinetic energy of electron is work function plus energy of photon is equal to work function plus kinetic energy maximum. If energy of photon is large, kinetic energy is large. So then we say kinetic energy is EV naught. V naught is stopping potential. If this is large, this is large. So in nutshell, what I'm trying to say is that this and this. So if frequency is large, stopping potential will be large. If stopping potential of two graphs is same, means frequency of two graphs is same. Similarly, this has the relation with this intensity and photocurrent. Please directly remember, intensity and photocurrent has a relation with each other. Frequency and stopping potential has a relation with each other. Keep these two things in your mind. Let's take a look at this. Let's take a look at this. Compare the intensity and frequency of three graphs. These are the three graphs. You are supposed to compare the frequency and intensity of three graphs. I would want you guys to focus over here. Now, can I say for these three graphs, photocurrent is same? Photocurrent is equal to same. If photocurrent is same, could you please tell me photocurrent has a relation with what? I would say intensity. So I can say in this particular case, intensity of three graphs would be same. Absolutely. Now, stopping potential is different. V naught is different. So I would say frequency is different. And in this particular case, V3 is greater than V2 is greater than V1. So frequency of 3 is greater than frequency of 2 is greater than frequency of 1. Next, if you take a look at these two graphs, here we say photocurrent is not same. What does that mean? Intensity is not same. I2 is greater than I1. Intensity of this is greater than this. And in this case, stopping potential is same. What does that mean? For two graphs, I would say frequency is same. Because frequency has a relation with what? Stopping potential. And photocurrent has a relation with what? Intensity in this particular case. Okay. Now take a look. De Broglie's wavelength. Guys, see. When it comes to de Broglie's wavelength, de Broglie said, everything in this universe is a form of energy, which behaves like a particle as well as wave. Like this is an object. If this is this object, is this pen a particle or wave? This is a particle. We can feel its particle nature. De Broglie said, if this is moving with certain speed, it behaves like a wave also. So what is the de Broglie's wave? That there is a particle. Its mass is m, velocity is v. What is the de Broglie wavelength? What is the wavelength of this? Sir, is this particle or a wave? We can feel its particle nature. It is a particle. De Broglie said it's a wave also. And what is the wavelength of this particle? That is h divided by m into v. This is called de Broglie's wavelength. De Broglie's wavelength. Or we call it matter wavelength. Either you call it the matter wavelength or you call it the de Broglie's wavelength. It's one and the same thing. Either you call it the matter wavelength or you call it the de Broglie's wavelength. It is one and the same thing, boys and girls. I can say it something like that. De Broglie's wavelength and matter wavelength. Okay, yes. Now, de Broglie's wavelength in terms of kinetic energy. This is the de Broglie's wavelength in terms of momentum. MV means momentum. This is in terms of kinetic energy. H upon under root of 2mk. De Broglie's wavelength for a relativistic particle. Relativistic particle means that particle whose speed is comparable to the speed of light, like electron, proton, which is moving with a very faster speed. H under root of 1 minus v square by c square upon m naught into v. H means Planck's constant. V is the speed of that particle. C is the speed of light. M naught is the rest mass. Okay. M naught is the rest mass of that particle. V is the speed of that particle. Charge accelerated with potential difference delta V. Okay. So its de Broglie's wavelength is, we can say h upon under root of 2mq delta V. De Broglie's wavelength of a charged particle which is accelerated with potential difference delta V. Charge at rest. If there is a charge which is placed in an electric field, this is a charge which is placed in an electric field. Okay, so it has, after time t, it has de Broglie's wavelength h upon under root of qe into t. Q is the charge, E is the electric field, T is the time. Charged particle placed in the magnetic field. If you have the magnetic field over here, this is B, and you are placing the charge in this magnetic field. Okay. So when you place a charge in this magnetic field, it moves in a circle. We have discussed this already. It has radius. So what is the de Broglie's wavelength of this charged particle? H upon QBR. Q is the charge, B is magnetic field, R is the radius of the circular path. For a gaseous molecule at temperature T, we say H upon under root of 3mkBT. M is mass, K is the Boltzmann's constant, T is the temperature. This is what we call de Broglie's wavelength of gaseous molecule for an electron moving in the nth orbit. Let's suppose this is the nucleus. An electron is moving in the nth orbit. Nth orbit means, if I say, let's suppose it's moving in the 5th orbit, so value of n is 5. So if this is the electron which is revolving in the nth orbit, its de Broglie's wavelength will be nh. N means which orbit it is moving. H is Planck's constant, upon under root of 2m into 13.6. This is the de Broglie's wavelength. Okay, now guys, take a look. There's a question over here, 2021 mains. The following have got the same kinetic energy. Which one has got the largest de Broglie's wavelength? See. Listen carefully. Alpha particle, okay. Alpha particle, proton, neutron, electron. When it comes to the mass of electron, it is less than mass of proton, which is less than mass of neutron, which is less than mass of alpha particle. Alpha particle has got mass 4 times mass of proton or neutron. Neutron and proton has almost equal mass. Slightly mass of neutron is greater than proton. Electron has very less mass. Now see, we say lambda is equal to h upon under root of 2m into kinetic energy. Sir, why are you using this equation? Because in this question, I can clearly say that kinetic energy is given. So if all these particles have got same kinetic energy is same. Okay. If kinetic energy is same, my dear NEET aspirants, H is same. So we said this de Broglie's wavelength is inversely proportional to mass only. The one which has got large mass will be having less de Broglie's wavelength. So I can say de Broglie's wavelength of electron will be large because it has got less mass as compared to de Broglie's wavelength of proton, as compared to de Broglie's wavelength of neutron, as compared to de Broglie's wavelength of alpha particle. This is the relation. This is the relation. The ratio of velocities of proton and alpha particle if the de Broglie wavelength of both of the particles are same. Proton, alpha particle. Guys, see, mass of proton is m, mass of alpha particle is 4 times mass of m. Okay. Now see, it says proton and alpha particle, they have got same de Broglie wavelength. Okay. So we can say h divided by m into v of proton is equal to h divided by, what is the mass of this? 4 times mass of proton into v of alpha. This, the ratio of velocity of proton. Okay, take it over there. So velocity of proton divided by velocity of alpha, it will be 4:1. Guys, de Broglie's wavelength was given. We were supposed to find the ratio of velocities. That's what I did. So we say h is equal to m divided by v. Sorry, lambda is equal to h by mv. Mass of proton into velocity of proton. Mass of alpha particle, that is 4m, into velocity of alpha particle. This one. An electron and a photon have got the same energy. When we talk about electron, see, when we talk about electron, take a look, boys and girls, when we talk about electron, listen carefully. When we talk about electron, we say de Broglie's wavelength for an electron is h upon what is given? Energy. An electron and a proton have got same energy. So you need to consider that equation of de Broglie's wavelength in which energy is present. So h upon under root of 2m into E, Ke. It is Ke because E is given, that's why I'm taking E. This is for electron. And for photon, how do we find the energy of a photon? E is equal to hc divided by lambda. So take this lambda over here, it will be hc divided by E. This is for photon. Okay. The ratio of de Broglie's wavelength associated with electron and the wavelength of photon. So it says wavelength of electron. Guys, you have to tell me the ratio of de Broglie's wavelength of electron and photon. Both have got the same energy. So de Broglie's wavelength of electron divided by de Broglie's wavelength of photon. It will be, for this, h upon under root of 2m. Okay. 2m into E upon hc divided by E. It will be h upon under root of 2m into E into E divided by hc. H and h will cancel. Okay, it will be E divided by under root of 2m into E into C. Do one thing, multiply with root E and divide with root E. Don't you think that a root E into root E is E? So this E will be cancelled with this E. What remains here? Root E divided by a root of 2m in the denominator into 1 by C. You can write it like this. 1 by C, then whole. This whole root. E divided by 2m and whole root is 1 by 2. E divided by 2m whole root is 1 by 2. 1 by C, E divided by 2m whole, this option A. A is matching. Chapter 8, atoms. Is this clearer? Tell me. Come on. Okay. Let's take a break till 8:30. Yeah? Little break. Now, guys, atoms. See, guys, see. Listen to me very carefully. When it comes to the chapter atoms, we need to understand different models of an atom. See, we will be directly moving on to the Bohr's model, okay? Because Thomson's model was purely theoretical model, okay? In Rutherford's atomic model also, you won't be getting that many questions. Directly Bohr's model of atom. Bohr's model of atom, okay? So there were three postulates from the Bohr's model of atom. Three postulates, okay? So the first postulate was, guys, see, when it comes to the first postulate of Bohr's model was, listen to me very carefully. We say everything in this universe is made up of small, tiny particles called atoms. How does that atom actually look like? See, Bohr's first postulate was an electron is moving around the nucleus. Guys, this is the nucleus. An electron moves around the nucleus. So means this electron is performing, I would say, circular motion. Okay, circular motion. Okay. And if electron is performing circular motion, means it is an accelerated motion. It is an accelerated motion. Accelerated motion, my dear NEET aspirants, means electron is accelerating. When electron accelerates, wave is produced, and it says stationary wave. Stationary wave is produced. Wave is produced. Okay. So stationary wave is that wave which does not radiate the energy, lose the energy. It does not lose energy. Does not lose energy. Okay. So stationary wave is that wave which does not lose energy. So this electron does not lose energy while revolving around the nucleus. Hence, it cannot collapse into the nucleus. Hence, atom is stable. Hence, atom is stable. It defines the stability of an atom. So when an electron revolves around the nucleus, it does not lose energy. It produces the wave called stationary wave. So it does not collapse into the nucleus. So hence, atom is stable. We can say it something like that. Second postulate. Second postulate. Okay. Second postulate says that an electron only revolves in those orbits in which its angular momentum is nh divided by 2 pi. An electron revolves only in those orbits, not in every orbit, not in the random orbits, only in those orbits where its angular momentum is nh by 2 pi. N means if n is 1, so in the first orbit, angular momentum is h by 2 pi. In the second orbit, it is 2h by 2 pi. In the third orbit, it is 3h by 2 pi. Okay, and so on. And then we say, third postulate, my dear NEET aspirants, third postulate. When it comes to the third postulate, if an electron, guys, listen to me very carefully. This is the nucleus. Electron revolves around the nucleus. If an electron is revolving in the higher orbit, and if it moves to the lower orbit, if it makes the transition from higher orbit to lower orbit, energy is released in that process in the form of photon. Photon is released. And if an electron moves in lower orbit, makes the transition to higher orbit, in that case, we need to supply the energy to the electron. So if an electron is moving in the higher orbit, it makes the transition to the lower orbit. We say photon is released. If an electron is moving in the lower orbit, okay, and we say it makes the transition to the higher orbit, we say in that particular case, energy is what? Absorbed. It needs the energy at that point of time. Now see, take a look, my dear NEET aspirants. Velocity of an electron in the nth orbit. Mathematical analysis of Bohr's model. Since an electron moves in the nth orbit, okay, since an electron moves in the, let's suppose electron is moving around the nucleus. And what is the charge of the nucleus? That is Ze. Z means atomic number. E is the charge on the proton. And this electron is revolving, it has certain velocity. So velocity of an electron in the nth orbit is 2.2 into 10 raised power 6 Z by n. Z is the atomic number. For hydrogen, atomic number is 1. For helium, it is 2. N means which orbit it is revolving. So this is what we call V naught, Z by N. This is the velocity of an electron in the nth orbit. Graph is this. Graph between V and N, it will be inversely proportional. Why? Because velocity is inversely proportional to N, directly proportional to Z. That's why it is this one. Now, if somebody says the radius of an electron in the nth orbit, this is ZE. This is, I would say, an electron is revolving in nth orbit. How much is the radius? Radius will be 0.53 n square by Z. 0.53 angstrom, or we can say R naught n square by Z. So what is the relation between R and n square? Direct between this, it will be inverse. So you can say R naught and Z, and it will be rectangular hyperbola. R and N, because R is proportional to N square, that's why upward parabola. And R and N square, if you put N square here, it will be power 1. So here power 1, so it will be straight line. Guys, when you put N here, then it will be upward parabola. If you put directly N square here, then it will be straight line. Now JEE 2025 question is asked over here. Assuming the validity of Bohr's atomic model for hydrogen-like atoms, the radius of Li2 positive, you have got Li2 positive. Guys, for Li2 positive, I can say atomic number is 3. Z is equal to 3. In its ground state means N is equal to 1. Okay, you have to tell me radius of an electron in the ground state of this. Radius of the electron in the ground state of this. Okay, radius of electron in the ground state. You can say radius of this electron in the ground state will be R is equal to R naught N square by Z. It is actually given. Instead of R naught, it is given A naught. So I will be writing A naught N square. N is 1 square divided by Z. Z is 3. So it will be A naught divided by 3. So it is 1 by X into A naught. What is the value of X? X will be 3. Find the radius of Li2 positive ions in its ground state. This one done. Find the maximum angular speed of the electron of hydrogen atom in stationary orbit. See guys, if an angular speed means omega. Remember, V is equal to R omega. There is a relation, V is equal, this is the relation between linear velocity and angular velocity. V is equal to R omega. Now here you can say omega is equal to V divided by R, my dear NEET aspirants. Omega is equal to V divided by R. Now what you can do in this particular case, you can say omega is equal to, this is V divided by R. Listen carefully. Omega is equal to V divided by R. Now, what is V? You can say omega is equal to, what is V? This is V naught Z by N upon, this is R naught N square divided by Z. Now it says, for a hydrogen atomic number is 1 in its stationary orbit. Stationary orbit means ground state, N is 1. Now tell me, what is the value of V naught? 2.2 into 10 raised power 6. Z by N. Z is 1. This is 1. Upon, this is 0.53 angstrom. That means 0.53 into 10 raised power 10. Okay? 10 raised power minus 10. So this will be 1 squared by 1. Okay? Now further you can solve this. 10 raised power minus 10 will go in the numerator, it will become 10 raised power 16. So 2.2 divided by 0.53. Okay. Into 10 raised power 16. Now solve this, you'll get the answer. Solve this and get the answer. Now, time period of revolution of an electron in the nth orbit. Time period of revolution of electron in the nth orbit. Let's suppose an electron is revolving in this orbit. And how much time it is going to take in completing one cycle? That is called time period. This is the time period. 1.51 into 10 raised power minus 16 n cube by z square. If I say an electron is revolving, okay, how much magnetic field it is going to create at the center? Okay, magnetic field due to an magnetic field at the center of the atom due to the revolution of electron. B naught n z cube by n raised power 5. Value of B naught is this. Z cube by n raised power 5. Frequency. Guys, we say frequency is inverse of time period. So what is time period? 1.51 inverse of 1 upon 1.51 into 10 raised power 1.51 into 10 raised power minus 16 n cube by z square. 10 raised power minus 16 n cube divided by z square. Don't you think we can write it like this? Guys, 1.51 we can write it like this. 3 by 2. 3 divided by 2 means 1.51 into 10 raised power minus 16 n cube by z square. Now take this in the numerator, it becomes 2 by 3 into this in the numerator 10 raised power 16, this in the numerator z square by n cube. Okay. Yes. Now guys, listen. Let's suppose this is the nucleus. It is having the charge Ze. And electron is revolving around the nucleus. Okay. This is electron E. This is radius R. And its mass is m. Now tell me, boys and girls, it has velocity mass. Whenever there is an object which has velocity as well as mass, it has kinetic energy. So the kinetic energy of this electron in the nth orbit, it will be Ze square upon 8 pi epsilon naught r. Directly remember this. This is the kinetic energy of an electron in the nth orbit. Okay. Now, since this is a charge, this is a charge. At center, it is nucleus, it has charge, this has charge. What is the potential energy? Potential energy will be minus Ze square upon 4 pi epsilon naught. This is the potential energy of between nucleus and the electron. Total energy. Total energy is basically this plus this. So when you do this plus this, Ze square upon 8 pi epsilon naught r minus Ze square upon 4 pi epsilon naught r, it will be minus Ze square upon 8 pi epsilon naught r. Now from this you can clearly see total energy is, I would say, negative of kinetic energy. Yes, sir. Because you see, kinetic energy is exactly total energy, but this is negative. So even I can say mod of total energy is mod of kinetic energy. Okay. And that will be potential energy divided by 2. Because potential energy is, guys, Ze square upon, you can write this 4 into 2. So 2 into 4. So Ze square upon 4 pi epsilon naught r, that will be potential energy divided by 2. You can write it like this also. You can write this also. Now see, kinetic energy is positive, potential is negative. And what is the K and R relation? Inverse. Here also inverse, this is negative. Here also inverse, this is negative. Now if you make the graph, see, kinetic energy is positive, that's why graph between K versus R is from upper side. Potential energy is negative, that's why graph is from negative side. Total energy is also negative, that's why graph is from the lower side. Okay. This is very important. This is very important. Okay. One more important thing I would want you guys to understand over here. There is one more relation. This is after the derivation, we get this relation. This is the total energy of an electron in the nth orbit. Minus 13.6 Z square by n square. Okay. Now we say for hydrogen Z is equal to 1. If you put Z is equal to 1, it will become 13.6 by n square. And even kinetic energy is exactly total energy but positive. So it will become 13.6 divided by n square. So this is one more way to write the total energy of an electron in the nth orbit, 13.6 divided by n square. Now see, we say total energy of an electron in hydrogen atom is minus 13.6 divided by n square. Let's suppose if we talk about the first orbit. If we talk about first orbit, for first orbit n is 1. So it will be minus 13.1 and it is in electron volts. This energy is in electron volts. So if I say minus 13.6 divided by 1, it will become minus 13.6 electron volts. Now, total energy of an electron in the second orbit. First orbit is also called ground state. Second orbit is called first excited state. So it will be, for here, it will be 2 square. 13.6 divided by 2 square is 3.4. For third orbit or second excited state, put here 3. 3 square is 9. 13.6 divided by 9, it is 1.51. In the fourth orbit or third excited state, it will be 4 square, so it will be 0.85. This is the energy of an electron. Okay. Now take a look at this question. This is a question from JEE 2025. I want you to understand this very carefully. Considering Bohr's atomic model for hydrogen atom, just a second, guys. Now see, considering Bohr's model for hydrogen atom, okay, the energy of hydrogen atom in its ground state is same as the helium in its first excited state. Okay, the energy of hydrogen atom in its ground state is same as the energy of helium in its first excited state. Guys, see, for hydrogen atom, when we say ground state, N is equal to 1 and Z is equal to 1. What is the energy? Total energy will be minus 13.6 Z square by N square. This is the general formula. Z is 1, N is 1. So it will be minus 13.6 electron volts. For helium, He positive. What is the value of Z? Z is 2. And in its, for helium, in its first excited state means second orbit. So N is equal to 2. So energy will come out to be minus 13.6 Z square by N square. So it will be minus 13.6 Z square, that is 2 square, N square, 2 square. This and this will cancel. Oh yes, it came out to be same. So means energy of an electron in the second orbit of helium is same as the energy of an electron in the first orbit of hydrogen. This is correct. Similarly, you check these from your end. This is your homework. Simple. I have told you the logic. This is the only logic behind it. This is a previous year question of NEET. The total energy of an electron, total energy is given as minus 3.4 electron volts. Okay. Total energy is given as minus 3.4 electron volts. Okay. Tell me what is kinetic energy. Kinetic energy is positive of total 3.4 electron volts. Okay. What is potential energy? We say total energy is simply kinetic energy plus potential energy. Total energy is minus 3.4. Kinetic energy is 3.4 plus potential energy. Take it over here. Minus 3.4 plus minus 3.4. Minus 6.8 electron volts is the potential energy. I believe this is clear, boys and girls, ladies and gentlemen. This question I'm giving you as homework. Please do check this from your end. Spectrum. What does spectrum actually mean? Listen carefully. We say it is the collection of radiations of different wavelengths on a photographic plate. Listen. Let's suppose you have a white light over here. You are passing this white light through the prism. When the white light is passed through the prism, it is splitted into 7 different colors. V, I, B, G, Y, O, R. It is splitted into 7 different colors. When a white light is passed through the prism, it is splitted into 7 different colors. V, I, B, G, Y, O, R. Okay, absolutely. And when these 7 different colors fall onto the spectrum, when these 7 different colors fall onto the spectrum, it makes a red spot, orange spot, yellow, green, blue, indigo, violet. This creation of these spots is what we call spectrum. Creation of these lines is what we call the spectrum of different wavelengths. These lines have got different wavelengths because different colors have different. Now, there are 2 types of spectrum: absorption spectrum and emission spectrum. Take a look. What is the energy of an electron in the first orbit? Minus 13.6 electron volts. What is in the second orbit? Minus 3.4 electron volts. How much is this gap? This gap is this minus this. Okay, or this minus this. 13.6 minus 3.4. So this gap is 10.2 electron volts. Means if you want to make the transition of an electron from first orbit to the second orbit, how much energy is required? 10.2. Yes. Now see, let's suppose you are sending a photon which is having the energy of 10.2 electron volts. And you send the photon of 10.2 electron volts. This photon is eaten up by the electron here. So when electron takes all of this 10.2 electron volts energy, it will transfer to the second orbit. So when it is transferred to the second orbit, we say a dark spot is created on the screen. There's a bright screen. So creation of this dark spot is what we call absorption spectrum. Absorptions, what does it indicate? It indicates that electron has eaten up the photon. It has made the transition from lower orbit to the higher orbit. So that's why this dark spot was created over here. Creation of dark spot on the bright spectrum, bright screen. This is what we call absorption spectrum. Then you have emission spectrum. Let's suppose if an electron is revolving in the higher orbit, it makes the transition into the lower orbit. And when it makes the transition in the lower orbit, energy is released. And my dear NEET aspirants, energy is released in the form of photon. So photon comes out. And it falls onto the screen or spectrum. So when it falls onto the screen, a bright spot is created. Creation of this bright spot indicates that energy has made the electron has made the transition from higher orbit to the lower orbit. Then only we say these spots are being created over here. Now, if the energy of this photon matches, or we say if the frequency of this photon matches with the frequency of red, then red spot will be created. If the frequency of this emitted photon matches with the frequency of yellow, then the yellow spot will be created. This is called absorption spectrum. Now, this emission spectrum, this emission spectrum can be shown on the spectral series also. Like. The first series is Lyman series or K series. Listen to me very carefully. This one, which you were showing over here, this we show in the spectral series. Same thing. In spectral series, we make the orbits with the straight lines. This is the first orbit, second, third, fourth, fifth, and up to so on infinity. Okay. Now, my dear NEET aspirants, if an electron makes the transition from higher orbit to the lower orbit, we say photon is released. It falls onto the screen. So line is formed. That line we can show over here in the spectral series also. So this is like this line. What does this line indicate? This line indicates that if an electron has made the transition from n is equal to 2 to 1, second to first orbit. So the line which was created on the spectrum, we show that over here also in the spectral series. This is the first line of Lyman series. If an electron has made the transition from second to first, okay, from third to first, second line is formed. This is what we call K alpha, K beta, K gamma. This one is K gamma. So if an electron has made the transition from last line to last final orbit, infinity to 1, this is the last line, final line. So means if the electron makes the transition from higher orbits to the first orbit, these only we show in the Lyman series. Means final orbit in the Lyman series is 1. Initial orbit can be 2, 3, 4 and so on. Now see guys. When it comes to this is the first line of Lyman series. First line. See guys, first line of Lyman series will be having the minimum energy. Energy will be minimum. Even frequency will be minimum, because if frequency is minimum, if energy is minimum, frequency will be minimum. That's for sure. Okay, yes. And wavelength will be maximum, because wavelength is inversely proportional to frequency. Directly remember this. Last line. Last line will be having the maximum energy, maximum frequency, and minimum wavelength. Minimum wavelength. Keep this thing in your mind. Then you have Balmer series or L series. If an electron makes the transition from higher orbits to the first orbit, okay, sorry, higher orbits to the second orbit, this we show in the Balmer series. So here final orbit will be 2, initial orbit can be 3, 4, 5, and so on. And my dear NEET aspirants, what I want you to understand in this particular case, here also, first line will have maximum wavelength, minimum frequency, minimum energy. Last line will have maximum energy, maximum frequency, minimum wavelength. Then Paschen series. If an electron makes the transition from higher orbits to the third orbit, okay, that we show in the Paschen series. So we say final orbit here is 3, initial orbit can be 4, 5, 6, and so on. Okay. Okay, so these are the 3 series upon which the questions can be asked. Then you have PF and bracket series. Over on those questions are not asked. Now see, wavelength of the photon emitted. Listen to me very carefully. Listen to me very carefully. When an electron makes the transition from higher orbit to the lower orbit, we say the line is formed on the spectrum, or we say photon is released. That photon creates the line, falls onto the screen and creates the line. Either you say energy of that photon or you say energy of that line. It is one and the same thing. So energy of the photon emitted, or sorry, wavelength of the photon emitted or wavelength of the line formed on the spectrum. That will be 1 by lambda is equal to R. R is Rydberg constant, 1 by n final square minus 1 by n initial square. Okay. So lambda is what we call wavelength. Lambda is what we call wavelength. 1 divided by lambda is what we call wave number. This is what we call wave number. So this is the wavelength of the line which is created on the spectrum, or this is the wavelength of the photon emitted, one and the same thing. Let's take a look. There is a question which was asked in JEE 2025. Take a look, boys and girls. The ratio of shortest wavelength of Balmer series. Guys, see, Balmer series. Which one has the shortest wavelength in case of Balmer series? Last line. So it is talking about the last line. Because first line has got the shortest wavelength. Yes, last line has got the maximum energy, minimum wavelength. So last line of Balmer series means, when is the last line formed? When n initial is infinity and n final is 2. You can check it also. Balmer series. This is the last line of Balmer series. N initial is infinity, n final is 2. Okay, last line. First line has got maximum wavelength. Okay. What is the wavelength? 1 upon lambda Balmer is equal to R Rydberg constant, 1 by n final square, 1 by 2 square minus 1 by infinity. So 1 divided by lambda Balmer will come out to be R. 1 divided by 2 square is 4. So lambda Balmer will come out to be 4 divided by R. Is that clear? Yes. Then we say Lyman series. Lyman series. Okay, last line of Lyman series. Last line. So in this particular case, n initial is infinity and n final is 1, because finally it comes to 1. So 1 divided by lambda Lyman is equal to Rydberg constant, 1 by n final square, that is 1 square minus 1 by infinity. So what you can say, 1 divided by lambda Lyman is equal to r. So do the reciprocal, lambda Lyman will be 1 divided by r. Now you have to find lambda Balmer divided by lambda Lyman. Lambda Balmer is 4 by r. Lambda Balmer is 1 by r. This and this will cancel. It will be 4 is to 1. Is this clear? Tell me. Okay. J 2025. J 2025. Okay. For a hydrogen atom, the ratio of largest wavelength of Lyman series to that of the Balmer series. Okay. The ratio of largest wavelength of Lyman series to that of Balmer series. Okay. Ratio of largest wavelength. Largest wavelength means which one? First one. Lyman. Okay. Lyman series. Largest wavelength means first line. Means first line. So first line will be created when n initial is 2 and n final is 1. Because when an electron moves from 2 to 1, first line is created. So I would say 1 by lambda Lyman, it will be r. 1 by n final square, 1 by n final square, 1 by n initial, 2 square is 4. 1 by lambda Lyman will be equals to 4 minus 1 is 3 by 4. 3r divided by 4. 4 minus 1 is 3. 3 divided by 4. So lambda Lyman will be 4 divided by 3r. Okay, Balmer first line. Because first line has got the maximum wavelength. So this is created when n initial is 3 and n final is 2. When an electron moves from 3 to 2, then we say first line is created. So 1 divided by lambda Balmer, it will be Rydberg constant. 1 by n final square, 1 by 2 square, minus 1 by n initial square, 1 by 3 square. Okay. So this will be 1 divided by lambda Balmer. It is equal to r. 1 by 4. Okay, this is 1 by 4. 9 minus 4. Okay, that is 5. Divided by 4 into 9, 36. So lambda Balmer will come out to be 36 divided by 5r. Now, lambda Lyman divided by lambda Balmer. 4 divided by 3r into. When you take this in the numerator, it will become 5r divided by 36. Okay. 4 ones are 4 nines are. R and R will cancel. So this will be 5 divided by 27. So lambda Lyman will be lambda Balmer 5 by 20. Nuclei. Nuclei. Let's start the chapter nuclei. Let's start the chapter nuclei. Okay, now take a look. Nuclei. We'll teach radiation pressure also. Let's finish this one. Now, guys, nuclei means nucleus. When we talk about the atom, what is at the center of the atom? This is what we call nucleus. What is at the center of this atom? That is what we call the nucleus. Okay? What is at the center of the atom? That is what we call the nucleus. Now, my dear NEET aspirants, what I want you to understand over here is, this is a nucleus. What is inside the nucleus? You have got protons, you have got neutrons. These are the particles which are present inside the nucleus. Now, my dear NEET aspirants, if these are the particles present inside the nucleus, what is the radius of the atom? Radius of the atom is 10 raised power minus 10 meters. Radius of nucleus is 10 raised power minus 15 meters. Now, the particles which are present inside the nucleus are called nucleons, hydrons, or baryons. Okay? Yes. Now, representation of a nucleus. How do we represent the nucleus? We represent the nucleus with a letter. Let's suppose this X. Now, over here at the top, we mention A. At the bottom, we mention Z. A actually means mass number. Mass number means number of protons plus number of neutrons. And Z means atomic number. Atomic number means number of protons. Okay? Yes. Now, my dear NEET aspirants, when I say number of neutrons will be A minus Z. Okay? Yes. Listen to me very, very, very carefully. Let's suppose if I say this is a nucleus over here. This nucleus has got like X, like this X, 10, 5. What is this 10? Mass number, number of neutrons plus number of protons. What is this 5? Number of protons. So number of neutrons will be 10 minus 5, that is 5. Okay. Then you have over here, boys and girls, that is binding energy. Now see, this is very important. Okay. This is very important when it comes to the binding energy. Listen to me very carefully. Let's suppose you have a nucleus over here. Its mass number is, I would say, A. A is the mass number of the nucleus. And Z is the atomic number of the nucleus. A is mass number, Z the atomic number. Let's suppose you break this nucleus over here. Listen to me very carefully. You break, so you are using the energy. And when these nucleons were inside the nucleus, collective mass of this nucleus was actually M. Collective mass was M. And when you break this nucleus, you take these nucleons out. Now, you take Z protons out because Z is the atomic number, means Z protons. And mass of one protons is MP. Z protons will have ZMP. This is the mass of Z protons. And how many neutrons? A minus Z. So A minus Z will be the neutrons. Mass of one neutron is Mn. What is the mass of A minus Z neutrons? A minus Z into Mn. Now, when you check, this mass came out to be greater than collective mass. So when these particles were inside the nucleus, its mass was large. Okay, sorry, its mass was less. When they were taken out, its mass increased. It came out to be greater than M. It was supposed to come to equal to M, but it came out to be greater than M. Why? The reason is the energy which you used in breaking the nucleus, that energy got stored in the form of nucleons. That energy got stored in the form of mass, okay? That energy was stored as mass of the nucleons. The energy which is used in breaking the nucleus is stored in the form of mass in nucleons. And this energy is what we call binding energy. So can I say over here, sir, mass defect has occurred. Final mass came out to be greater than initial mass. So we can say mass defect has occurred over here. Yes. So we say due to this energy only mass defect occurred. And how much is the mass defect? Mass defect means delta M. That means final mass minus initial collective mass. Now, let's suppose if somebody asks you how to find this binding energy. This binding energy will be simply mass defect into C square. Mass defect into C square. So this binding energy, what is mass defect? ZMP plus A minus Z into Mn minus M into C square. This is what we call binding energy in this particular case. Okay, yes. Now, one important thing I just want to tell you over here. Binding energy per nucleon. You have got binding energy. What does it binding energy mean? It is the total energy used to take out. See, when you break the nucleus, you take out all the nucleons out of the nucleus. So energy used to take out all the nucleons out of the nucleus. Out of the nucleus. Okay. Energy used to take out all the nucleons out of the nucleus. That is binding energy. If I say binding energy per nucleon, we say this is energy used to take out all the nucleons, energy used to take out one nucleon, out of the nucleus. Energy used to take out one nucleon out of the nucleus. Yes. Now, we said this binding energy per nucleon is proportional to stability. So more is the binding energy. See, if I say if I say binding energy per nucleon is 14 electron volts, binding energy per nucleon is 5 electron volts. This is more stable as compared to this. Why? Because here it requires 14 electron volts to take out one nucleon from the nucleus. Okay. Yes. Take a look. Graph between binding energy per nucleon versus mass number. Graph between binding energy per nucleon versus mass number. Understand this very carefully. Binding energy per nucleon versus mass number, the graph came out to be something like this. Now, my dear NEET aspirants, when it comes to the this came out to be the graph, or this is what we call stability. Why? Because binding energy per nucleon is proportional to stability. Now see, it was seen that those nucleons which is having mass number between A is equal to 30 to A is equal to 170, these are having this graph. This is the graph. This graph means high stability. They are highly stable. Those nucleons which are having mass number less than 30, like 16, 15, 14, they are having less stability. They are unstable. Also here, see, graph is going down. Those nucleons which are having mass number greater than 170, they are also unstable. Okay. It is mentioned. Those nucleons with mass number less than 30 are called lighter nuclei and are unstable. Those nuclei with mass number greater than 170 are all heavy nuclei and are also unstable. Now see, everything in this universe wants to become stable. Now these two lighter nuclei join together, fuse together to form a bigger nuclei so that they attain stability. Let's suppose this is having mass number 14, this is having 16. 16 plus 14. Okay, now it becomes stable. That is 30, now it becomes stable. So basically, my dear NEET aspirant, this process in which two nuclei fuse together to attain stability, this is called a fusion. Similarly, this bigger nucleus, this is unstable. It will break into two smaller nuclei. Let's suppose its mass number is 200. It is breaking into 100 and 100. Now it becomes stable. This process in which a bigger nuclei breaks into two smaller nuclei, that is what we call the fission. That is what we call the fission. Okay. So here two lighter nuclei will combine to form a bigger nuclei in order to attain stability. And this process is called fusion. And energy is released in this process. And a bigger nuclei with mass number greater than 170 breaks into two smaller nuclei to gain stability. This process is called fusion. Energy is released in this particular process. Energy is released in this particular process. Okay? Okay? Yes. Now you have Q value of the reaction. After this, I'll show you the questions. Q value of the reaction. Now, what is Q value of the reaction, my dear NEET aspirants? Take a look. Q value of the reaction simply means this is how much energy is released or absorbed. Take a look. Let's suppose you have two nuclei, A plus, I would say, B. These are what we call the reactant nuclei. When these reactant nuclei, let's suppose they are converted to the product nuclei. These reactant nuclei are converted to product nuclei. Like over here, fission fusion takes place. In fission and fusion, two reactant nuclei are converted to the product nuclei. This is the nuclear reaction. Similarly, two reactant nuclei are converted to the product nuclei. During this process, we say some energy may be, we don't know what kind of nuclear reaction is this. Some energy may be absorbed or released. That energy is what we call Q value of the reaction. So Q value of the reaction can be calculated. Mass of reactants minus mass of products into C square. Mass of reactants, mass of A plus mass of B, minus mass of products, mass of C plus mass of D into C square. In terms of binding energy also you can calculate it. Okay. In terms of binding energy you can also calculate it. Binding energy of products. Okay. This Q is binding energy of products minus, this is binding energy of reactants. Binding energy of reactants. Binding energy of products minus binding energy of reactants. Okay. Yes, 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 yes. One more important thing. If mass of A plus mass of B came out to be greater than mass of C plus mass of D, in this particular case, Q will come out to be positive. When Q is positive, energy is released. It's an exothermic process. If mass of A reactants is less than mass of products, Q will be negative. So energy is absorbed. It's an endothermic process. Okay, it's an endothermic process. Like here, if, guys, listen carefully, if binding energy of products is greater than binding energy of reactants, if this is greater than this, like 10 minus 5, it is plus 5. So Q will come out to be positive. It means energy is released. Okay. Now, if I say binding energy of products is less than binding energy of reactants, Q will come out to be negative. If Q will come out to be negative, we say energy is absorbed. Energy is absorbed. Okay. Yes. Take a look at this, my dear NEET aspirants. Energy is absorbed. Take a look at this. Energy is released. Okay. Energy released when two deuterium, 1H2 plus 1H2. Okay. Combined together when two deuterons, 1H2, fuse to form helium nuclei. That is 2He4. Okay. Plus Q. You are supposed to find out how much energy is released in this process when two deuterons fuse to form a helium nucleus, 2He4. And given, this is a JEE 2025 question, binding energy per nucleon of 1H2 is 1.1 MeV. Now guys, see, We say Q value of the reaction will be binding energy of products minus binding energy of reactants. Listen carefully. Q is equal to, product is this. It says binding energy per nucleon of 2He4. Binding energy per nucleon of 2He4 is 7.0. What is binding energy per nucleon? Amount of energy used in taking out one nucleon from the nucleus. So how many nucleons are over here? 4, because mass number is 4. So if you want to take out one nucleon, how much energy is required? Array 7, that is binding energy, na? So we say one nucleon has got 7 binding energy. 4 nucleons will have got how much binding energy? So we'll be saying 4 into 7, bro. Array, sir. So this is the binding energy of products, total binding energy. Binding energy of one nucleon is 7. For 4, it will be 4 into 7 minus binding energy of reactants. In reactants, how many nucleons? 2 plus 2 is 4. What is the binding energy per nucleon of 1H2? So binding energy of one nucleon is 1.1. So how many there? 4. So 4 into 1.1. Array, sir. So this will be 28 minus 4.1. Okay. So 23. Okay. 4.4. 23.6. So 23.6. Is this clear? Now this one. The binding energy per nucleon of 3Li7, 2He4 and this, when this is the reaction, 3Li7 plus 1H1 gives 2He4 plus 2He4 plus Q. Okay, this is the question. In this particular case, you guys are supposed to find the value of Q value of the reaction in this question. You are supposed to find Q value of the reaction in this particular question. Take a look, my dear NEET aspirants. Take a look, my dear NEET aspirants. See guys, you are supposed to find the value of Q value of the reaction. So we can say Q value of the reaction will be, listen guys, binding energy of products minus binding energy of reactants. Okay. Binding energy of products minus binding energy of reactants. So this Q value of the reaction will be binding energy of products. Listen to me very carefully. These are the products. So binding energy per nucleon for 2He4 is 7.06. So for one nucleon of helium, it has got how much binding energy? 7.06. How many are total? 4 plus 4 is 8. So total binding energy is 8 into 7.06 minus. Reactants. See, this is 1H1. This means proton, 1H1. So means this is just one particle. One particle will have 0 binding energy. Binding energy is used when you need to separate 2 particles, 3 particles. So it has 0 binding energy. So how many nucleons are there in reactant? 7. So binding energy per nucleon of 3Li7 is 5.60. So 7 will have how much? 7 into 5.60. Okay, now solve this, you will get the binding energy. 17.6 it will come out to be, I guess. Okay, yes. Yes, yes, yes. One small concept over here. Rest mass energy. Rest mass energy. Rest mass energy. Let's suppose, my dear NEET aspirants, listen carefully. You have an object, its mass is m. Like you say, you have an object, its mass is m, it's moving with a velocity v. You define its kinetic energy, 1 by 2 mv square. Because whenever the object is in motion, it has kinetic energy. Whenever the object is in motion, it has kinetic energy 1 by 2. But you have mass over here. Due to the mass of an object, it has energy stored in it, associated with it. That is called E is equal to mc square. This is called rest mass energy. Like, let's suppose if you have mass of an object is 10 kg. If somebody says how much is the energy stored in this mass, you say E is equal to m is 10 into c is speed of light, 3 into 10 raised power 8, its whole square. So energy will come out to be, this is 10, 3 square is 9, 10 raised power 8 whole square is 10 raised power 16. So this will be 90. 90 into 10 raised power 16. Or you can write it like this, E is equal to 9 into 10 raised power 17 joules. This much of energy is stored in how much? How much mass? 10 kg mass. This is the energy stored in 10 kg mass. Okay? Yes. And one more important thing, density of nucleus. Guys, see, when you say density of nucleus, listen to me very carefully. We say density of nucleus. Listen directly, I'll say. Density of nucleus. It is 10 raised power 17 kg per meter cube and is constant for all nuclei. Very important point. So many questions have been asked in J mains on this one. Does not depend upon mass number. Mass number does not depend upon mass number. Like example, let's suppose there is a nucleus. It has X, it has mass number 17. There is a nucleus Y, it has mass number 25. If somebody says what is the density of X divided by density of Y, you'll be saying, sir, it is 1:1. Why? Because this density does not depend upon the mass number. It is same for all the nuclei, that is 1:1. Very important, very important, very important. Okay, one more important point in this particular case, size of nuclei. Size of nucleus. Size of nucleus. Now guys, see, when it comes to the size of nucleus, let's suppose this is a nucleus over here. Okay, size of nucleus will be radius. So radius of nucleus is equal to R naught A raised power 1/3. Keep this thing in your mind. Keep this thing in your mind. So we say this radius is proportional to A raised power 1/3, mass number raised power 1/3. Okay, like if you have a nucleus that is X, its mass number is 4. Nucleus, it is Y, its mass number is 8. If I say what is the radius of the two, radius of X divided by radius of Y, you'll be simply saying that is mass number of X divided by mass number of Y whole raised power 1/3. So it will be, that is 4 divided by 8 raised power 1/3. 4 ones are 4 twos are, that is 1/2 whole raised power 1/3. This is going to be the relation. Guys, tell me, is this crystalline clear? Is this crystalline clear? Come on, come on, come on, come on, come on, come on. Give me the signal in the chats. Give me the signal in the chat, so. Is this clear or tell me? Okay, guys, let's start. Let's start. Now, let's take a look over here. Let's take a look over here. Semiconductors. So, before starting the semiconductors, let me give you an idea about the semiconductors. See, you have conductors, okay? You have semiconductors, you have insulators, okay? We say conductors. We say conduction is possible. Conduction is possible. We say conduction is not possible. Conduction is not possible. Okay. And we say, my dear NEET aspirants, when it comes to the semiconductors, these semiconductors can behave like conductors also. These semiconductors can behave like insulators also. So means its conductivity can be varied. We can basically change its conductivity. So basically in this particular case, semiconductors lie between conductors and insulators. So you cannot convert an insulator into a conductor. Okay. Similarly, when it comes to the semiconductors, you can convert this into a conductor and this to an insulator. That's why these are the special materials. Band diagram. Band diagram of semiconductors. Guys, see. We say this is the nucleus. Around the nucleus, electron is revolving. Electron is revolving in this orbit. Okay. Electron is revolving in this orbit. Now, my dear NEET aspirants, these electrons are revolving in this orbit. Okay. This electron is revolving in this orbit. If we keep on zooming, this electron is actually, these electrons are actually in the energy band diagram. Like we say, guys, see, if let's suppose this is the orbit, if we keep on zooming, inside this, you will be having the band diagram. In reality, these electrons are present in what? These electrons are present in the band diagram, Okay. So directly you remember over here, We say when it comes to the band diagram of semiconductors, listen carefully. Band diagram of semiconductors looks like this. This is what we call conduction band, and this is what we call valence band. Guys, don't get confused over here. We say electrons in an atom. We say electrons in an atom. We say electrons in an atom, my dear NEET aspirants, are in revolving in the orbits. So in reality, when you keep on zooming, these electrons are present in the band diagrams. In reality, which you show over here, this electron is present in the orbit. In reality, if you keep on zooming, these electrons are present in what? Band diagrams. And those band diagrams at microscopic level, it looks like this, These are called bands, okay? Energy levels. These are called energy levels. And so basically it is just, see. It is like this. This is the orbit in which electron is present. If you keep on zooming, it will come out to be like this. It will come out to be like this. This is called conduction band. This is called valence band. So if you zoom this, so in these conduction bands and valence bands, actually electrons are present. But from a large distance, we say it is present over here. But in reality, these are present in conduction band and valence band. This is called band diagram. Now, this is the conduction band. This is valence band. Okay, these are called energy levels. This is the gap, energy gap between the conduction band and valence band. This is called, this is called a minimum energy level of conduction band. And this is called maximum energy level of conduction. Maximum energy level of valence band. This is called a minimum energy level of conduction band. Okay. Yes. So my dear NEET aspirants, now see, at 0 Kelvin, when there is, let's suppose this is the band diagram of semiconductor. We have not increased any temperature to the semiconductor. At 0 Kelvin, conduction band is completely empty. At 0 Kelvin, this conduction band of semiconductors is completely empty. And valence band is completely filled. This valence band is completely filled. Now, my dear NEET aspirants, let me tell you one thing. The electrons present in the conduction band are called free electrons. Because of these electrons, only conduction is possible. Flow of electrons is possible. Electricity is possible. Now, if we increase the temperature, let's suppose at T is equal to 300 Kelvin, we say the bonded electrons will move to the conduction band. You keep on increasing the temperature. These are what we call the bonded electrons, which are present in the valence band. These are not free to move. These are free electrons. The bonds break, electrons shift to the conduction band. Okay, this electron will go here. 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 So we say, when this electron leaves this position, we say a hole is created over here. A hole means vacant space is created over here. So we say electron hole pairs have been created. When electrons shift from valence band to conduction band, we say electron hole pairs have been created, my dear NEET aspirants. Okay, when you increase the temperature. And because of these are what we call the free electrons. These are what we call the holes. And together we say electron hole pairs have been created. Okay, and electrons have got negative charge. These holes have got positive charge. How? Because when negative charge leaves the position, we say positive charge is occupied on to that point. Because, see. Let's suppose this is having plus 2 Coulomb charge, minus 2 Coulomb charge. If you remove this minus 2 Coulomb charge, what remains over here? Positive. Deficiency of electron is what we call positive charge. That's why here it is deficiency of electron. And excess of electron is called negative charge. Okay. Now, there are two types of semiconductors. Intrinsic. These are what we call pure semiconductors. Okay. And these are what we call impure semiconductors. Okay, now take a look. Conduction in pure semiconductors. Listen to me very carefully. Pure semiconductor in which no impurity is added. Pure semiconductor. I'll make you understand. I'll make you understand. Listen carefully. My dear NEET aspirants, let's suppose you have got over here. You have got over here in this particular case. This is a pure semiconductor. In case of pure semiconductor, we say already some electrons and holes are present. Electrons and holes are present. Holes have got positive charge, electrons have got negative charge. Like this. This is a pure semiconductor. Some holes are present, some electrons are present. These are the free electrons, these are the holes. Okay, yes. Now I'm showing it like this. Now, in the actual scenario, it is like this. So we say pure silicon. Silicon is what we call the pure semiconductor, intrinsic semiconductor. So this is silicon crystal, silicon, silicon, silicon. We say here, these are the valence electrons of the silicon, and this is the hole. Now, when you apply the you apply the battery, you connect the battery. This is positive, this is negative. Battery creates the electric field. When battery creates the electric field in this semiconductor, we say these electrons experience the force. We know that force on the negative charge will be opposite to electric field. These electrons will experience the force in the opposite direction. So these electrons will shift here. These electrons will shift here. And these holes, my dear NEET aspirants, see, when the electron shifts here, now electron occupies this hole. Now hole will be created over here. So in this particular case, we actually say electron is also moving and this hole is also moving. So we say current is being created by both. And if I say what is the net current produced, that is Ni. Then we say E, A, Ni is the intrinsic charge density. E is the charge on an electron, A is the area. Okay. Delta V, potential difference. L is the length. Okay. Then mu E plus mu H. So this is the mobility of electrons plus I would say mobility of holes. Okay, this you guys need to directly remember. You don't have to do anything with this, but you directly remember this. This is the current produced in the pure semiconductor. This is the current produced in the pure semiconductor. Okay, yes. Now take a look. What I want you to understand over here. That is extrinsic semiconductors. These are extrinsic. Extrinsic semiconductor means N-type semiconductor. Okay, there are two types of extrinsic. We say N-type and P-type semiconductor. Extrinsic means in which impurity is added. Sir, why do you add the impurity to the pure semiconductor? So that its conductivity increases. We add impurity to the semiconductor so that its conductivity increases. So we make N-type and P-type semiconductors. Okay. Now, boys and girls, listen to me very carefully. Boys and girls, listen to me very carefully. We say when it comes to the N-type semiconductor, this is a semiconductor over here. Okay, this is a semiconductor over here. Okay. I am taking a pure semiconductor in this particular case. Silicon, 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 silicon. This is a pure semiconductor. And in this pure semiconductor, I am actually adding the impurity that is phosphorus. Phosphorus is a pentavalent impurity in which phosphorus has got 5 valence electrons. Okay, this is a pure silicon. And silicon has got how many valence electrons? 4. 1, 2, 3, 4. So means with 4 electrons, it can create a bond over here. So now, when it comes to the phosphorus, it has got 5 valence electrons. So what will this phosphorus do? This see, in order to fit into this crystal, phosphorus must have only 4 electrons, but it has 5. So it will lose 1 electron. So this phosphorus, it will lose 1 electron. When it loses 1 electron, it will become phosphorus positive. It will become phosphorus positive. That is what we call positive donor ion. This is what we call positive donor ion. So when you add phosphorus to this, so see, phosphorus has replaced this silicon. Okay. So when you add phosphorus to this, so phosphorus has got how many electrons? 5. In order to fit into the crystal, it must have 4. So these are the 4 electrons of phosphorus. And 1 electron which it is donating, that is this one. Now see, this is the free electron in the crystal. Similarly, on adding millions of phosphorus, millions of electrons, free electrons will be donated. Now, by adding this impurity, we say its conductivity has increased. Its conductivity has increased. So because you have increased the number of electrons over here. Now see. So we say in case of n-type so how do we make n-type semiconductor? When pentavalent impurity is added to the pure semiconductor. So we say electrons will be the majority charge carriers. Electrons will be the majority charge carriers. So my dear NEET aspirants, Ne is the majority charge carriers. Why do we say? Because here, majority charge carriers in this particular case will be the electrons. Okay. And NH, number of holes, will be the minority charge carriers. Guys, let's suppose this was a pure semiconductor previously. Pure semiconductor has some holes, okay, and some free electrons. By adding the impurity, a lot of free electrons have been added. Now, number of holes is less, number of electrons is large. That's why we say majority, minority. Okay. Current due to electrons is much, much greater than current due to holes. Okay. And number of electrons is equal to the number of donor ions. This is important. Let's suppose if you are putting 1 phosphorus, how many electrons are donated? 1. If you are putting million phosphorus, how many electrons are donated? Million. So that's why number of electrons is equal to number of donor ions. Number of electrons is equal to number of donor ions. I hope this is crystal and clear. P-type semiconductor. Okay. So when it comes to the P-type semiconductor, we say in case of a P-type semiconductor, my dear NEET aspirants, we add boron. That is a trivalent impurity. When it comes to the boron, this is a trivalent impurity. Trivalent impurity means which has got 3 valence electrons. So when here we take a germanium. Silicon is a pure semiconductor. Germanium is a pure semiconductor. When you add germanium, when you take a germanium crystal, pure semiconductor, germanium has also got 4 valence electrons. Okay. Now, in order to fit into the crystal, this boron must have how much? How many electrons? 4. But since it is having 3 only. So what will happen? This boron, okay, this boron will basically accept 1 electron plus 1. It will gain 1 electron. So it will become boron negative. That is negative acceptor ion. Acceptor ion. So when you add boron to this crystal, see, this boron is added to the crystal. It becomes boron negative. So it was having only 3 electrons. This one, and this one. Now, it will basically take 1 electron from germanium. So germanium will basically donate 1 electron to this boron. Okay. Now it will be having 4 valence electrons and a hole is created over here. So my dear NEET aspirants, when you add a trivalent impurity, in that case we say holes. Let's suppose if you are adding millions of boron, in that case millions of holes are created. Millions of holes are created. So can I say I would say P-type semiconductor, what is the majority charge carriers? We say majority charge carriers are basically holes. And what is the minority charge carriers? Minority charge carriers are electrons. Number of holes is much, much greater than number of electrons. And number of acceptor ions, that means boron, is equal to number of holes. If you add 1 boron, how many holes are created? 1. Okay. If you add 5 borons, how many holes are created? 5. So that's why number of acceptor ions is equal to number of holes. Okay. Yes. Now see, conductivity of a semiconductor increases on doping. Doping means adding the impurity. When you add the impurity, either pentavalent or trivalent, number of holes, positive charge increase, number of electrons, negative charge increase. Okay. So conductivity of semiconductor increase on doping, correct? Doping raises the temperature of semiconductor. Doping does not. Adding impurity does not raise the temperature. We say assertion is correct, so option 3. Assertion is correct, reason is false. Assertion is correct, reason is false. Option 3. For a given applied voltage, conduction current in n-type semiconductor is more than the p-type semiconductor. Guys, in n-type semiconductor, what is the majority charge carriers? What is the majority charge carriers in n-type semiconductor? Okay, we say electrons. And electron have got more mobility. Mobility is electrons are free to move. They are lighter as compared to holes. So mobility of electrons is greater than mobility of holes. Reason is correct, assertion is correct. So electron have got more mobility. Electrons are more free to move. So they are having more, I would say, what? Conductivity. Okay. So this option A is the correct option in this particular case. Okay. Yes. Which of the statement is true for p-type semiconductor? Electrons are majority charge carriers. P-type semiconductor. In p-type semiconductor, holes are majority charge carriers. Pentavalent atoms are dopants. No. Electrons are majority charge carriers. No. Okay. Holes are majority charge carriers and trivalent atoms are dopants. Option B. NEET 2013. In n-type semiconductor, which of the following statements is true? Holes are majority charge carriers and trivalent n-type. Electrons are majority charge carriers? No. Trivalent atoms are dopants? No. Electrons are no. Holes are minority charge carriers and electrons are dopants. Option D. Option D. Holes are minority carriers and pentavalent atoms are dopants. P-N junction diode. P-N junction diode. Okay, P-N junction diode. Okay. Now guys, the maximum length of the stream is 12 hours. Maximum length of the stream is 12 hours. Okay. Wait. Okay. So this PN junction diode, I think we have to study in the next stream. Guys, next stream will be, this session I'll end, but the next stream will start at 10:30. Next stream will start at 10:30. Next stream. Okay. 10:30 p.m. Next stream 10:30 p.m. Okay. Next stream 10:30 p.m.